And we're live.
Hi, everyone. Welcome to our very first Aviators Community Day. First and foremost, we want to give a big shout out to all of our speakers today for being part of this gathering. Of course, our goal here with Logic App Aviators has always been focused on bringing our community closer, allowing us to connect, learn, and grow from one another. We value diversity and encourage everyone to be open minded. This is a space where you can kick back, have fun, and learn while building meaningful connections. Throughout the event today, we want to hear from you. So make sure to ask questions and share what you've seen here today. And if you like today's event, make sure to make some noise that you're interested using our hashtag Logic Apps Aviators so that we can make this happen again. And before we kick things off, we also want to give you guys a massive thank you for showing up and being part of the first Aviators Community Day. We're very grateful to have you here. And so now it's time for us to start off with Microsoft's own Swetcha talking about custom code.
Hi, Switcha. You're on mute. So we
Hello.
can take that one out of the way.
Cool. So, Wagner, can you share my screen if you don't mind?
Yes. All yours.
Yes. All right. So, hi, everyone. My name is Kent Weir. I'll be co-presenting with Swetcha. I'm part of the PM team and here to make an announcement. And so it's pretty exciting. I think we need a drum roll. So what we're going to announce today is custom code extensibility for Azure Logic Apps standard. And let me get to the slide here. And so this is something that we've been working on for a little bit of time now. And it's finally ready to share with the world. This is a public preview. And so the goal of this is that you will be able to author custom code, compile that custom code, and then be able to use a built-in action found in Logic Apps standard. In this case, it's here on the screen, to be able to go ahead and call this compiled code. Now, we do have a local debug experience for both workflows and code, which is pretty cool. So the ability to set a breakpoint in your workflow configuration, a breakpoint in your code, and to be able to jump to those breakpoints back and forth, which is pretty awesome. We also have full support for dynamic schema, inputs and outputs, including complex types. So what this means is that as you go ahead and build out, say, a method within your code, and you want to call it from Logic Apps, I'm sure you have an expectation that you'd be able to go ahead and use Token Picker and use dynamic content in order to go ahead and populate the request, and then also be able to use the output downstream in subsequent actions. And that is something that's supported and is actually quite neat. Another benefit of this, and this is based on a lot of customer feedback, is that customers were looking for the ability to run their code in the same service plan. So in this case, the workflow service plan as the workflows. So this helps you in terms of your development lifecycle of being able to build these things in the same session of VS Code, the ability to then go ahead and deploy it, and then deploy it to a single service plan. And what this also means is that this executes on the same machine, so you don't have another security surface that you have to manage and protect. That's all happening for you. Now, one of the initial drivers of this was certainly BizTalk migration. As we talk to customers, there's a lot of .NET investments that have been made, and customers are looking for a way to move that forward as they are on their journey to migrating integration workloads to the cloud. But certainly, you don't have to have BizTalk to use this. Generally, there's always some needs for some extensibility, and so that's what we're offering here today. And now this is public preview as of today. Look for a blog post around noon Pacific. We just started working through some last minute logistics in terms of deployment, but this is something that you'll be able to go ahead and try later on today. So do look for blog post on Tech Community, and we will make it available and you'll be able to go ahead and try it out. So with all of that said, I'm going to hand it over to Swetcha, who's actually one of the engineers that worked on this project. So you are getting some great insights by one of the people that actually built this feature. So Swetcha, over to you.
Awesome. Thank you, Kent. If you go ahead and show my screen. So I'll be showing you guys the new feature. And to kind of start off, one of the really cool things that we created for public preview is having another VS Code extension that'll allow for you to create a function and a logic app in the same workspace. So I'm going to go ahead and do that. I'm just going to call this workspace for now. And I'll provide this a function name. So we'll just call this AV Func app. And then for namespace, let's do test function. And then we'll do a stateful workflow. And then for this, let's call this logic. And I'm going to open this in a new window. And as it's opening, you'll see that we will have a workspace that will include both the function app as well as the logic app as well. Let me expand this. Oh, whoops, wrong one. Okay, I think that one. All right. Okay, so let me go over to the actual class itself. So as you can see here, we provide the user a template. And so this kind of just will be some kind of template code that you can execute. So that way you can ensure that it's working on your end before you start adding any of your custom code. And as you can see here, we have a specific trigger for this type of custom code action. And then we also are able to give different parameter values. So we're able to do like integer strings, but we can also do complex objects like a JSON object, for example, or a J object. So this is the template in this case. And then we also have the logic apps. I'm going to go ahead and open the workflow, and I'll open this up in the designer as well. But as you can see, we also provide a logic app workflow.
Switcher, I think your screen is on the other screen. So you just needed to bring that same one where the invoked functions.css might be on the second monitor.
Bad. Okay, can you guys see it now?
Or just share the full screen.
Okay, let me know if you can see the workflow now. Okay,
Yes.
that looks right. Okay, sorry about that, guys. So this is the workflow that I was referring to. And this basically gives you a template workflow so that way you can also execute the logic app before you start adding any of your own additions. And in case we didn't see the CS class, I'll show that again. So like I mentioned before, we have a template function. And in this case, we have a specific trigger action for this type of like custom code feature. And then we're also able to give different parameter values. So in this case, we can do stuff like integer, string, but we can also do dynamic parameters. So in this case, like we're going to use an integer and a string, and I'll show how this comes into play later on from how you can call it from a Logic Apps perspective. So I'm going to go ahead and run this now, or build, sorry, I'm going to go ahead and build the function side. Okay, and it succeeded. And before we get started with the Logic App side, I'm going to go ahead and start up Azure, right? We need to do this 3 times for each of the services. Okay, and then I'm going to go ahead and open this in the designer. And in this case, I will actually show you like the new action that we created for this. So this is going to be the invoke function action. Okay, and as you can see, this is the action. This is like the template that is like the action that's provided with the template. But what I'm going to go ahead and do is delete this and create a new one. And with one of the like really cool features that we implemented is we're able to get function names and parameters dynamically. So the user will no longer have to input this directly the way they would have had to in private preview. So I'm going to go ahead and pick my function parameters. Okay, let's go ahead and save this. And then I'm going to go over here and click on the Logic Apps side to run this. Let's see, right here. So right now I am going to run the function that we just, or the Logic app that we just created. And it's a bit slow, so just give it a little bit. Okay, and if we remember, this was the name of our function that we gave it. So now it's been injected into the runtime. And so what we can do now is we can go into the overview and run the trigger on it. And that'll be able to actually execute our code. All right, I'm going to go ahead and run the trigger. Let me pull this down so that way I can expand the run a bit. Okay, so it looks like the first one that I clicked on already succeeded. We can wait for this one to succeed as well, but I'll open this run up so that way we can get an idea of what it is that it's going to show us after the code has been executed. So if you look here, I gave it the different inputs, right, for the zip code and the Celsius value. And this is the body that we are going to retrieve from our output. So in this case, we get like the zip code, we get the current weather. And one of the really cool features that we have is that you'll be able to grab these tokens individually. And so you won't necessarily have to just call like the entire output. You can call like whatever token you need. So I could call just the current weather, and I can show that again as well. But let me go ahead and show the response. And in the response, we are calling the body. Okay, so then I'm going to also show the debugging feature. But really quickly, I want to show off the dynamic tokens that I was referring to. So if we go here, we can see that we're able to call all of those tokens individually, as well as calling the output overall. All right, so now I'm going to go ahead and debug. Okay, I'm going to put a breakpoint in both the Logic app and the function app. And at first you have to attach it to the Logic app, and then you will have to attach it to the .NET function one. And what we'll do here is after both of those are attached, I'm going to go into the overview and run the trigger. And by doing that, you will be able to debug both the function class as well as the workflow.json file. So I'm going to give it a few seconds, make sure I can see it in the call stack before I go ahead and run that trigger. Let's double check that that's going. Okay, so it looks like both of those are good. We'll go ahead and open the overview. Alrighty, and once I press this, we should be able to debug. So as you can see, it goes into our workflow.json file. And now after I click over this, it will take me into the function class. And if we look over here on the left side where the local variables are popping up, you can see that after we go through each variable, we can get the value that we are giving it. So it's really nice that you can be able to see exactly what you're going to be able to debug with this project. So as you can see, I can get all of the values for this. I'll expand this a bit. Never mind. Okay, and then I'll go through, and then we can see that there is the result. And after stepping over this, we'll come back to the weather class. Let me step out of this. And yep, you can see that our invoke function action executed properly. But yeah, that is the debugger as well. So it's really nice that we have both capabilities. And I think this will be really great for developers to be able to actually debug both the function side and the logic app side. But that is the entirety of the demo. If you guys have any specific questions at the end, please feel free to ask.
Yeah, there's been some questions, Swetcha, that I've been answering sort of as you've sort of worked through the demo, but thanks for demoing that. That's cool. So one thing we wanted to do here as part of this event was ask you some questions about your experiences. I feel like there's many people that were curious what it's like to be an engineer at Microsoft and sort of what a day in the life is, if you will. So I've got a few questions to ask you, if you don't mind.
Yeah.
Question number one is what was your initial reaction when you found out you're going to be working on this custom code project?
To be very transparent, I was honestly incredibly intimidated. I think this was my first job coming out of college, and it was my first project starting on Logic Apps. So it's definitely intimidating in terms of the scope of the project. But I remember seeing the mock-ups and being incredibly interested in what this was. And I knew that this was a product that a lot of people could benefit from. And as time went on, I feel like the worry of the scope of the project kind of died down. And it was more of just a genuine interest to get this out there for people. And now I'm wow, this is so cool that we can execute code in a Logic app like this. And as I understand the project more, I'm this is just such a cool project. And I'm honestly so grateful that I was able to work on this.
Cool. Yeah, no, it's been a lot of fun, and I've been pretty excited about it too. So I hear you. Another question is, what was the most challenging requirement that you had to deal with as part of this project, and how did you solve it?
Yeah, so I think one of the hardest requirements was getting the ball rolling on how to go about invoking a function from a compiled assembly in the Logic App side. There's a lot of smaller aspects of this, like how to invoke an assembly by reflection. There are things that you kind of know as a dev, but to use that knowledge and incorporate it into the Logic Apps runtime and how it works with their architecture. I think that was one of the big things that we had to initially get started. And once that was figured out, it was a big error process on how we could go about experimenting with this to get it to be injected into the runtime and then later on be invoked. After that, we were able to kind of get the ball rolling on everything else. And I think this requirement definitely needed a lot of research. And I think because this touches on the functions SDK and it touches on the Logic Apps runtime, there were two kind of bigger components that I had to learn about as I started this job. So honestly, just a lot of learning. But overall, I think it is a hard thing. But once we got that ball rolling, it was, I think the rest of the requirements were honestly very much so easier at that point because we had just gotten past that one.
Makes sense. And so so we've had a private preview. I think we launched private preview in, I think it was January, and we had some customers that participated in that, and we certainly appreciate the feedback that we got from them because I feel like that helped accrue a lot of value to where we are today. So since private preview, of the investments we made into the custom code experience, what's your favorite new feature and why?
So my favorite feature is the new VS Code extension that I just showed at the beginning. Initially, we had to set up two separate workspaces for VS Code to be able to run one function and to run Logic App on the other side. Then we were able to get it to work in one workspace. And so there's just been an evolution of it, but we had to test it completely manually. So the fact that users can go in, click a button, enter in what they need for functions, for the Logic Apps, just naming stuff, and we just spit it out for them. It's such a great feature. We had a front end engineer named Sammy who worked on this, and like she did an incredible job. And I think it's made it so much significantly easier for a lot of people to use this product. And like in general, from my end, like testing as a developer, like this has reduced time for testing significantly. And I think it just makes it so much more accessible, especially with the template. Now that people can have something to go off of, we know that they can at least have a working product before they start incorporating their own code.
Yeah, absolutely. Shout out to Sammy. That was some work that was done in short order, and once again, like joined the team and ramped up quickly. So it's very awesome. And I think the key benefit is, like, I think from a goal perspective, we wanted someone to be able to go in and click that icon and have like a working solution in a matter of a couple minutes, and just know like, hey, this is working. And then it's now like, oh, like, how do I build upon this? How do I sort of incorporate my own logic and things like that? And I think we've been able to achieve that. So I'm pretty pumped about it. I think it's a great feature. I'd also say I think the dynamic schema stuff's pretty cool too.
Yeah, the drop downs.
Yeah, so kudos to you. I think the build tasks that go and compile the code, and then there's some metadata that's generated that the designer can then use to figure out like what are the inputs, what are the outputs. I think that's a pretty cool feature too. So. And then last question, I think we'll probably have time for a few from the audience as well. So folks, feel free to drop something in chat. So I guess anything else you'd like to share with the audience based upon today's demo?
I would just say, like, again, I'm really grateful to have gotten to work on this project, especially as a new grad. Like, it's just such an overall amazing project, and like to have some kind of ownership over it is amazing. I'm really proud of the work that Sammy and I have contributed to this. And like, it's just really nice to be able to see this go from an idea to an actual product. And I'm excited to see what customers think of it. And then lastly, like, I would really appreciate, like, if you guys have any feedback, to please reach out to Kent or I. Like, there's so much that we can take from that and like build before GA. And we're always looking for more feedback. I know from my end and from Sammy's end too, like, we would love the feedback on this product.
Cool. Thank you so much. I think there's a couple here in chat that we can try to address. Wagner, I wanted to drive that just so you can click the button.
Yeah, sure. So first question is from Cameron McKay. So when setting a breakpoint in the workflow JSON file for the Logic Apps, does the designer show the state at the point of pausing the breakpoint?
Yes, it should. So I don't think I did it on my end, but you can like kind of pause and like play the like action on the left side of VS Code. You can do both for those. In my case, I was just stepping over so I could give people more insight on what is provided in the variable information.
Yeah. And one point to note is that although you don't see that on the designer, is always the code base, right? So you see that at the code level, but all the items on the pane there is going to be reflected for the Logic Apps as well as the functions. Next question that we have is from Stephen Clennan. Will it scale when creating custom code that takes a lot of the memory and CPU? How that is going to work?
So I can give a little bit of a description on this, Kent. If you have any more intake after this, let me know. But I would say this is something that we will have to experiment with. Since this is kind of just something that we've been using, we haven't really been able to like scope with the scale yet. And we don't know how much CPU or memory this will take.
Yeah, and just to add to this, just to give some insights into architecture, because actually in the blog post, we talk about this a little bit. So I guess number one, from a principle perspective, like think of this in the paradigm of Logic Apps today, right? So if you've got any sort of like upper limits, so if you go to like the limits and configuration page, like you're going to see things around like the default timeout for an action to execute, like that's 10 minutes by default. The other thing is if you go ahead and look at message payload, generally you've got like 100 meg limit as well. So think of it in those terms. It's not necessarily something we're doing specific to the custom code itself, but it's more of like, how does this fit into the existing Logic Apps architecture? Now, I think there's some sweet spots for using this feature, and we call this out in the blog post, which will be out later today. So if you need to do some like, custom business logic, go for it. If you need to do some parsing, go for it. Some sort of data validation, go for it. I would call it like simpler data transformations, go for it. If you're trying to take like a BizTalk pipeline component that does streams a 1 gig file, like this is not that solution, right? Like we're still talking about like cloud-based architectures. So, to a certain extent, like this is public preview. We are interested in learning from customers and getting your scenarios. But I'd say that should be some rough guidelines in terms of like where to get started with this and what you can expect. And obviously, like when we talk about like Logic Apps density, generally that's more bound by triggers in the sense of like how many workflows can I put in a Logic app, and sort of what's like sort of the performance footprints or characteristics of that. This is going to run within like the same service plan and the same footprint. So if you end up doing a lot of like heavy custom code work, like that might warrant scaling out or that might warrant scaling up. Like it's, there's always sort of that give and take in terms of like, what am I trying to do? But, as we get more feedback from customers, more usage, certainly we'll be putting up more guidance around this and share more of those characteristics.
Okay. I think we are at time since we have a whole lot of more content to go. Right?
Maybe just one last thing. I see Warren's question here. So looking forward to learning more about this. So yeah, there will be a blog post later out today. As soon as this is public, we've sort of pushed to marketplace. The blog post will go out there. We'll give you a complete walkthrough of how you get this working. And then also I've already got a video on my YouTube channel as well that sort of does a walkthrough. So there will be resources right away that you'll be able to take advantage of.
Cool. And I'm assuming that you're going to be staying a little while on the chat, replying some other questions. Cameron just put another one.
For sure.
Right?
Yeah.
But unfortunately, we have to go to the next one. Yeah. Actually, while Stephen arrives, because I saw him connected and he's just leaving. If you wanted to take that last one, because I think it's going to be relatively quick, and then I can bring Stephen to the stream.
Yes. So gotcha. So this one, yeah. So when you deploy, because what happens is you have to compile your source code. That source code compilation actually gets copied or what we call bin placed into your Logic App workflow project. You deploy that as you do today, whether that's through CI/CD or right-click deploy. That will land in Azure. Obviously, it lands in a service plan, and the execution itself behind the scenes is on the same machine. And so that was like a conscious decision for ourselves. Like we wanted to reduce latency. We didn't want to introduce another security surface for you to have to govern and enforce. And so as a result, that's running on the same sort of Logic Apps infrastructure as your workflow.
Cool. Thanks. Thank you so much.
I wanted to call out about that we have the ability to be able to deploy to Logic App from VS Code as well. So if anyone wants to test it out, that is something you can try out.
Yeah.
Perfect. Mm-hmm. Thank you, both of you. There was as James said, it was mind-blowing, right? So thank you for all of that, and let's start with our next piece on the show. See you all later.
So.
Bye.
And let's bring Stephen. Hello, mate. You're on mute.
Hello, how are you doing?
Oh, good, thank you. So thanks for joining us. So today we're going to be bringing Stephen W. Thomas, that lots of people know, and he's going to give you 101 on how to get started with Logic Apps Standard. So with that, let's start that show. In 1 minute. There we go.
Hello, my name is Stephen W. Thomas, and today's session is called Getting Started with Logic Apps Standard. Let's get started with a little bit about me. I've been an independent consultant for over 20 years now. Along with being independent for 20 years, I've been doing overall consulting work in the integration space for over 23 years. I have been working with BizTalk Server since it first came out in 2001. And I've been working with Azure since the Service Bus was first released over 12 years ago. I've also spent over 6 years working with Logic Apps. For the past 18 years, I've been recognized as a Microsoft Most Valuable Professional. If you want to learn more about Logic Apps outside of this session, I will have additional links to resources at stephenwthomas.com/learn. Here I'll have links to Pluralsight courses that can help get you more information about Logic Apps, as well as links to outside resources to help you get started. Feel free to email me anytime with questions at steven@stevenwthomas.com, and make sure you follow me on LinkedIn and Twitter. Let's get started with a quick agenda of this short session. Here we're going to first start with consumption-based logic apps, so we can have an idea of what consumption is. And then we're going to spend the rest of our time on standard edition logic apps. We're going to take a look at running these in Azure, as well as running these locally. Let's get started with consumption. Consumption was the first release of logic apps that came out over 6 years ago. It does offer a low-cost option because it is truly serverless. There is no hosting that you need to worry about in order to run them. It's a pay-per-use model, so if you create a logic app and never run it for a year, you're not charged anything. When you do run the logic app, you're charged for the consumption of each resource that runs. So your actions and triggers are charged for each one. You can develop your logic apps either in the portal, inside of Visual Studio, or using VS Code. These consumption logic apps will only run in Azure though, no matter how you build the logic app. All consumption logic apps are stateful, which means your progress through the logic app is tracked with the inputs and outputs being readily available to review after the logic app runs. This can be useful in debugging, but can also increase the latency of your process. Consumption-based logic apps are always multi-tenant, which means additional clients will be running additional logic apps right next to your logic app. So you could run into the noisy neighbor type scenario. Now there was an isolated environment called the Integration Service Environment, or ICE environment, that was available, but that has now been retired and being replaced with standard edition logic apps. So what are the key differences that make standard edition logic apps important? First off, there really isn't a low-cost option out of the box. Your low-cost option for standard edition is to run them locally. As compared to consumption-based, where you didn't have to worry about hosting, now we're back to having to worry about hosting with our standard edition logic apps. These are generally hosted inside of an app service plan. You can develop your standard logic apps either in the portal or in VS Code. And no matter where you develop your logic app, they can run anywhere. You can run them locally, you can run them in containers that run locally or even in another cloud provider, or the most common is to run them in Azure in an app service plan. Standard edition logic apps can be stateful or stateless. Running a stateless process does have a few limitations, but it can greatly reduce your latency of that workflow. And there is native support inside standard edition for liquid transforms and XSLT maps, as well as for schemas. These features would cost extra using integration accounts if you're using consumption logic apps. And standard edition doesn't have the noisy neighbor issue because they run inside of isolated environments inside your app service plan. Let's talk about a few important points. First off, they're not interchangeable. If you build a standard edition logic app, you cannot simply deploy that into consumption and then expect it to work. There is configuration changes that will be needed. Enterprise solutions may leverage both. You may have logic apps that only run a few times a month and you run them in consumption, as where you may have logic apps that are more resource intensive and thus you want to create them as a standard version. Features are not always the same between standard and consumption. A lot of times new features are available first inside of standard, and then that feature is ported over to consumption. They do leverage different designers, so the look and feel of building a logic app between the two is going to be a little bit different. And connectors are not always the same. There may be slight differences in authentication methods or different ways connectors present themselves between standard and consumption. Microsoft is making great strides to ensure parity between the two for all of these connectors and features. And unlike consumption, a logic app created in standard is more of like a folder for additional workflows that run inside that. So when you create a logic app in standard, you could have multiple workflows that run inside that logic app and all share schemas and maps and resources that are assigned to that logic app. So let's talk for a moment about connectors for standard edition. There's 3 types of connectors, 2 of which we'll talk about here. First off is built-in connectors. These run actually inside the standard edition runtime. So with these, there's no rate restrictions, and there's no extra cost outside of your hosting environment to run these connectors. So if you're running these locally, there's no cost at all to execute them. They do also have full VNet access to all resources on that same VNet, which means if you have SQL Server running in your same VNet, you'll be able to access it just like a local resource. The other type of connector is Microsoft Managed Connector, and these run inside Azure even for workloads that are running locally. These are all metered connections, which means there is a per minute rate limit for each of the connectors. In my experience, though, these rates are generally very generous, and it's not something I would generally run into as an issue with being metered. These are also pay per execution. Now, the pay rate is very small. There's two types there's enterprise and standard connectors, but the pay per execution is there. If you're executing these tens of thousands of times a day, the cost is going to add up. With all Microsoft Managed Connectors, there is no VNet support. And something else to note is if you're using a stateless workflow, you cannot have triggers that are based on Microsoft Managed Connectors. Let's spend just a moment talking about costs. Locally hosted, obviously there's no cost to run the workflow, but there is the cost to make the external calls to your managed connectors. If you're running in an Azure hosted environment, there are additional costs that you need to think about. First off, there's a storage account associated with your app service plan. There's networking charges to upload or download data across the network. There's the cost of the managed connectors, like we see in local. But then there's the largest cost is the app service plan. And these can vary on the amount of resources you want to dedicate to your environment. And the base cost is around 25 cents per hour. Let's take a look at some getting started demos. What are we going to cover in the demos? We're first off going to take a look at the portal, where we're going to create an app service plan and create a standard edition Logic app. Then we're going to dive into things locally. We're going to create a local Logic app, run it locally, and then see how we can deploy this to our app service plan. I've now jumped over to our virtual machine that I'm going to use to show us our demos. I've logged into my Microsoft Azure account, and I've just created a blank dashboard with a blank resource group. Let's go ahead and create resources. And what I want to do here is create a Logic app. I'm going to create my Logic app. And I'm going to select my demo resource group. I'm going to give it a name. And just go ahead and leave the region as East US. And here's where I can select my plan type. If I wanted consumption, I can select that here, or we're going to do standard edition. I don't have an existing I don't have an existing app service plan here, so I'm going to go ahead and create a new one. If I wanted to rename it, I could select create. If I wanted to rename it, I could select create new and rename it here. I'm going to leave the name as default, and I'm going to leave the default pricing plan. I'm going to leave my zone redundancy as is, since this is just a demo. Next, we're going to jump to hosting, and this is the storage account of where my files are going to be stored for this app service plan. I'm going to leave it again as the default. There's another option to select SQL Server, which is in preview mode. I'm going to jump to networking, and here's where I'd have the option to add an existing VNet if I would like. I don't have any virtual networks created here, so I'm going to simply leave this off for now, but that is a great feature to know that it's available. Under monitoring, it has support for application insight, but for now I'm going to select no since I'm just building out this demo. I'm going to go to tags, review and create, and I'm going to go ahead and create this Logic app with the app service plan. Now this whole deployment will take 4 to 5 minutes. Okay, now that deployment is complete, I can simply click go to resource and see the resources that is created. This is a demo container that is created. This is our top level container in which I can now create workflows under. If I wanted to use schemas and maps, I could upload them here and they would be shared across all the workflows. There's a bunch of other features here that we're not going to talk about related to this app service plan, but we can see here that they're all set up down here as well as getting plan details. Let's jump into workflows. And I can go ahead and add a workflow here. I'm going to make it stateful. Just call it stateful 001 and click create. And that'll take just a moment and it'll create that workflow. And I can dive into that workflow and go ahead and open it in the Portal Designer and get started building the standard edition Logic app. I'm now going to jump from the portal into VS Code and see how we would create a Logic app locally and then deploy it into our exact same app service plan that we created here. Okay, I'm now in VS Code. The first thing I want to point out is that there is some prerequisite steps that are needed before you can get started building standard edition Logic apps locally. It can be a little tricky and a little complex to set up. And if you already have existing versions of some of these components installed, you could run into additional challenges. But what I've done here is put out the top 9 steps that I've outlined to get started creating and running standard edition Logic apps locally. And there is a very good document in the Microsoft Learn repository about create a standard Logic app workflow in single tenant Azure Logic Apps using Visual Studio Code. And I'll have a link to this along with these steps in the learning resources on my website. But this will give you a little bit of information about what I did before we got here to see how to create these Logic apps and run them locally. So we'll go ahead and we're going to get started with creating a Logic app and running it locally. I'm going to go to the Azure section of my VS Code, and here under local workspaces, I'm going to click create new. And I just select a spot where I'm going to deploy this, keep these files at. I'm going to select here, and it's saying, what type of workflow do I want to first create? I'm going to go ahead and create stateful workflow, and what I want to call it, stateful local, and I'm just going to go ahead and open it in the current window. And now this is going to create a set of files over here on the left. That document on the Microsoft portal walks through what all these different files do and how important they are. But for most of the stuff we're going to do, we can just ignore a lot of these projects or these files. One thing I have noticed is if you come over here and you convert it to a NuGet-based Logic app project, that does seem to make local debugging a little bit easier to do. And I've run into issues if I haven't done this. So I always do that on my projects. And then let's go ahead and build out this Logic app. You come over here, you can see my stateful local, and I have workflow.json. I can right click and say, open designer. And this will take it just a moment to open the designer locally. I'm going to say I'll go ahead and use connectors from Azure, and I'm going to have to select my region or my resource group. And then here I can go ahead and add a trigger. I'm going to add a request trigger here. And you can see here that it does say it's in-app. So it's in-app and it is a trigger. So that means it's going to run in my Logic app process, which is good. I'm going to receive a request. I'm going to set a variable. So I need to initialize. Again, it said it was in-app, which is good. My local variable. I'm going to set it to integer, set it to 7. And then I'm going to go ahead and do a response. And again, it says in-app, so that's good. You can see that it is an in-app response. Select my response, and I want the body to be our variable that we're setting. So I'm going to select body, click the little lightning bolt icon under variables, my local variable, and that's all set. I'm going to go ahead and save this. And now one of the good things of running locally is I can actually go ahead and create breakpoints inside of my workflow. This is one of the best features of being able to run these Logic apps locally. So to do that, I go over to my workflow view, and you'd see down here there is a trigger, and I can't actually create the breakpoint on my trigger, but currently triggers are not supported for breakpoints. So I'm not going to do that. It has to be on an action. So I'm going to do when I initialize my variable, and I'm going to do when I go ahead and send my response back. So I can just jump down to that. Now I can simply run this workflow locally. And to do that, I'm going to first start my local Azure storage emulators. This is part of the prerequisite steps when you set up the environment. And they're shown up right down here at the bottom. And to get all 3 started, I just simply click them. And that's going to get all 3 of these emulators started. Now to run in debug mode, I simply go over here to run. and I'm going to start debugging. Now this whole process to build and get everything ready to run will take a few moments. You will get some pop-ups about some unresolved dependencies and stuff like that. I'll just close out of these. They seem to be related to some SQL components that use newer editions of .NET than what I have installed on here. And I did start with this. When I set this up, I started with a brand new Windows 11 Pro virtual machine, and went ahead and started with a brand new clean installation. And you can see down here on the left, it says it is, or in the bottom window, it says it is building. So we'll go ahead and give this a moment to get ready for us to debug. Okay, you can see here, we've all popped up into debug mode. You can see our breakpoints over here on the left. I'm going to go back to the Explorer. And if I right click on my workflows.json, I can go to Overview. And this here will show me past executions of this workflow. If I'm not debugging them, I can dive into them and take a look at the data inside them. But most importantly, this gives me my callback URL. This is the address I need to call in order to make this work. So I'm going to grab that. Now I'm going to jump over to Postman and paste this in here. And I am doing a post. I'm going to send this. And I'm not getting a response back right away, which is great. I'm going to jump over here. That's because I am in my breakpoint. You can see local variables up here. I'm going to hit continue. It's going to jump to the next breakpoint, see additional local variables. And again, this isn't a very meaningful example, but if it was a larger workflow with much more going on, you'd be able to dive in here and see exactly what's going on. To give you an idea of your look and feel experience of doing the local debugging. Go ahead and complete this. It's going to complete the workflow. Jump back to Postman. Sure enough, I got our 7 back, so that was successful. And that was how simple it was to create a local additional logic app and do some debugging. Now I can come over here to run. I'm going to stop debugging. And I'm going to remove my breakpoints. And let's go ahead and try to run this again without debugging. Again, it's going to take in a moment, deleting all the old files, rebuilding new ones. Okay, that's built and launched back up again for us to run. Let's go ahead and run it again in Postman. And it got our 7 back right away this time, so it didn't hit debug. Let's jump back in here. And if we did want to know what happened to this execution, we could go to our overview. And sure enough, you see here is our identifier for this execution. You know, this one took 30 seconds because we hit the breakpoints and stepped through it. This one just executed in 1 second. And if we want to know information about this, and since this was a stateful workflow, if we wanted to know information about this, we can dive in here. And I can click on each of these shapes and get all the information, just like I was running a stateful workflow in the portal or running consumption logic apps. So very useful information here. And again, this was all running locally, all executed locally. Now, if I called a connector that was a Microsoft managed connector, of course, you know, there would be that external call to Microsoft and would require the external internet connection to make that happen. So now that I'm done with this, going to run, stop debugging. And now let's see what we need to do to get this to deploy to our app service plan that we created in the portal just a few moments ago. I'm going to go back to Azure here. And under Workspace, I just simply click Deploy. And I'm going to say Deploy to Logic App. And here it's going to list the available app service plans that I can deploy to. I'm going to do the one we just created, a demo container. Say Deploy. And this process is going to go through and deploy these Logic Apps into our app service plan that we just created. Now, this publishing task will take several moments, maybe 5 minutes or so. So we'll be back in just a moment. Okay, it looks like that deployment has completed. And then close this window. Let's jump back to our portal. And we can go to our Logic app that we created. We'll do a refresh. And here we have our stateful local Logic app that we have created locally. And we'll jump into the designer. And sure enough, it's the exact same Logic app that we did create locally. Now it's running here in a hosted app service plan. So now that we're done creating our Logic apps, I'm kind of done with this demo for the day. We can come back over here and we can go into our, the resource group that we created earlier, and we can simply see the 3 different resources that have been created. It's our Logic App, our storage account, our app service plan. And since we have our Logic App locally now, and we can deploy it at any time we want to the portal, we can go ahead and delete this app service plan if we're not going to use it anymore. This will ensure we're not going to be charged for these resources anymore. Simply select them all, say delete. We're going to say delete. And this is a pretty straightforward process here. You can see them execute at the top, and it deletes the Logic App storage account first, and then the app service plan. The app service plan takes just a moment longer, and this will clean up all our resources to make sure that we're not being charged for this anymore. Okay, and just like that, everything's gone, and we're back to everything being exactly like it was when we first started. So this concludes our demo and concludes my session on getting started with standard edition Logic Apps. As I mentioned before, feel free to reach out to me with any questions. You can always email me, Stephen@stephenwthomas.com. Thank you.
And we're back. Thanks, Stephen, for that. I saw that we have 2 comments, and one from you and one from Jose. So Jose was saying there's a great way to avoid unnecessary failed runs in a resource created in the cloud. And I'm assuming that was when you're talking about the local running, which is a new feature compared to consumption, right?
Yeah, no, I definitely have that, guilty of that as well. In consumption, I'll have, 25 or so failed Logic App runs before I get one right. So
Like
running it locally.
Red, one green.
Exactly.
Cool. And the other pointer is that's your word of advice, like deployment from VS Code is for demo or for the initial dev, just to see if whatever you have there is working. But friends don't let friends right-click deploy.
Exactly. I remember you saying that from Integrate, so I wanted to make sure I pointed that out.
Cool. Anyone, if you still have any other questions, I think we have like a couple of minutes before we bring our next guest. Feel free to add or any general comments. Any final words for the audience, Stephen?
No, just that I was kind of initially intimidated by setting up the local running of standard edition just from the prerequisites, and I know you guys are working on documentation and a process to make that better and cleaner. So I would definitely encourage everyone to give it a try, and it has some big benefits.
Yeah, we saw some of the some improvements already made, like when you're installing the extension now, it's going to identify all the other extensions that are required and install in one go. But we making other improvements that is coming later this year. So keep turning, and there's a good place to do a little bit of a plugin for our community calls. Like we're not having one today because we're having like the whole day of community sessions, but every third Thursday of the month on Pacific time around 11 a.m. we have Logic Apps community stand-up. So if you wanted to keep in touch with what's happening, just make sure that you join us around that time. And with that, I think Stephen is here, and Kent is probably going to be joining us to the soon to the kick off the next one. Thank you so much, Stephen, for give us that 101. I think it's something that we usually forget how important it is to keep those basic information for people to get started earlier.
Yep, definitely.
Cool. All yours, Kent. I'll disappear with you, Stephen.
Cool. So it's my pleasure to introduce our next speaker, a good friend of myself and everyone else, Stef-Jan Wiggers from the Netherlands. So thanks, Stef-Jan, for joining us. Stef-Jan is going to take us through some real-world customer scenarios in the manufacturing space, and that also involve Dynamics 365. So the floor is yours. The mic's yours, Stef-Jan. Thanks for joining us today, and looking forward to see what you have here.
Oh, sorry. Yes, I want to say. Hi, welcome to my session on Logic Apps in manufacturing. So I'm Stefan Wiggers, and I'm going to talk about a customer case that I worked on in manufacturing. So like I said, a customer case, setup, technology, monitoring, support, lessons learned. So I'm kind of going to dive into these topics. So that's kind of the agenda for this talk. And yeah, it's about a customer case in manufacturing. So it involves Dynamics 365 as an ERP system that communicates with other systems, including machines that run on-prem, that receive production orders, that need to be, do its production basically. And it will give you some information back, at least the machines will give the information back, like report is finished, that needs to be entered back into Dynamics. So the complete setup of this particular customer, similar to other customers that I've worked at, 2 customers actually that did ERP and manufacturing, that kind of stuff. So you got your Dynamics Finance and Supply Chain Management that talks to several systems, including production systems. And these production systems also report back some of the information of running their production, running or creating a product, basically. There's some other systems listed here as well. Something about Recipe Studio, advanced shipping notice. So that's kind of an intercompany exchange of information, and also sales orders. But yeah, in general, I'll just talk about Dynamics communicating with these systems, and you see some of these systems communicating back to Dynamics. So you're dealing with outbound integrations and you're dealing with inbound integrations, if you look at that. The approach was basically decoupling, as in there's information coming out of Dynamics and then going to these other systems, and these other systems might report back, and those messages or payloads basically get transformed back into and sent to Dynamics. So outbound was more or less based on business events and the concept of business events. Something changed within Dynamics. For instance, a production order confirmed, meaning that the production order can actually happen on the system that runs somewhere in a factory on-premise. So it's an on-prem integration, basically. We used Logic App for the in and outbound interfaces. So the controlling the process of an outbound, or let's say an outbound message, which could be a production order that needs to be sent to the production system. And on the other end, it could also be that the production system reports back that it's finished with some of the goods it used to produce something, and that's put back as a transactional message in Dynamics as being a journal. For this, we use Logic App to do that orchestration. However, the mapping of in and outbound payloads were done by functions. And it was all asynchronous communication based on a certain workload. There were X amount of production orders, I think about up to 50 or 60, and also report banks. So the payloads and the workloads are pretty low in that perspective, and handleable, and were able to be handled by Dynamics easily. So the technology choices were using Logic App consumption. Although Logic App Standard was available in preview, ultimately we didn't go for the Logic App Standard, also because there was no actual requirement for some of the capabilities that it support, like VNet integration. We're using Azure Functions, so the consumption model for that one as well, for the mapping and formatting of and the parsing of from JSON to XML or to text files, and I'll talk about that as well. We're using some simple managed connections for our Logic Apps. So there's interaction with Service Bus, Key Vault, File, Office for email. I'll talk about that. And the secure FTP connector that was available as well. And then with the file adapter, we also combined that with integration with the on-premise data gateway for the on-premise connectivity. So the production orders were moved towards the on-premise system, as in the on-premise network. From the network, those messages were pushed towards those machines. So those machines were not connected to the internet. It will ingest that data, ingest those messages, actually those orders, produce, and then report back. Eventually, also through the on-premise networking. Again, the on-premise data gateway plays a role in getting the message up to Azure, where it's then subsequently transactionally processed by sending commands towards, or at least transactional messages, to Dynamics 365. For deployment, we were using ARM templates back in the day, so we were not, and bicep was not available yet, so we're using ARM. And for notifications of errors, that was through email. So the landscape kind of looked like what you're seeing now. So it's You got a dev test subscription, you got a production subscription. Within the subscription, there were a couple of resource groups, and within those resource groups, as you can see, there was like a more generic one, common one, where you could find a common event grid topic, service bus namespace, and storage account. We had a resource group for some monitoring capabilities, like Logic Apps of the Logic and Log Analytics workspace, combined with an OMS dashboard. We had a separate resource group with all the Logic app that was kind of required for the orchestration of in and outbound interfaces, as I said before. And we have the functions doing the mapping and also moving from one format to the other one. Environment-wise, we had a development, test, acceptance, and production, and each of these environments was tied to an instance of Dynamics. Then the deployment was done through ARM templates, so we were using Azure DevOps for it, so the repo, the boards, but also the pipelines, and also using some of the wiki capabilities within Azure DevOps as well, all tied to a tenant. Azure Active Directory also tied to a team where you can find some other information, or at least the documents that were like referenced within the Azure in the DevOps wiki were documents as more functional documentation within SharePoint through Teams. So it's kind of the overall setup or landscape for this particular use case. So let's more dive into the integration itself. So on one end, you have your outbound integration, which means that a business event occurs within Dynamics. This business event gets kind of enqueued, but then ultimately needs to be delivered to actually an event grid topic. To do that, you need to configure an endpoint, which I will discuss later on. That particular event gets parsed, then based on that business event, it just contains a small amount of data, let's say a production order, ID, and some other information, allows us to call back to Dynamics through a trust between Azure and the Microsoft Cloud. That's where Dynamics is hosted. To retrieve that data, that's kind of an enriched message that's being placed on a service bus topic with certain properties. And then you have listeners. One of the listeners picks up that particular message, enrich it further through mapping, or at least the enriched message goes through mapping. And then ultimately, if it needs to be another format, another function will convert that, for instance, as depicted here, in a text file, which is subsequently sent to a file share on-prem. So that's where the on-premise data gateway comes in and the file connector for the Logic app. On the flip side, so the inbound integration, particularly for the production orders, that goes to the on-prem network, as I explained earlier, and from the on-prem network back to Azure, is that the inbound also uses the on-premise data gateway and the file adapter. That's a text file. The text file gets processed basically into a JSON message, JSON payload that's being pushed towards a queue, which subsequently picks it up and then starts interacting with Dynamics by creating a journal header, journal items, and a data action to confirm or basically set the transaction for the journal itself. As you can see in the previous slide, and also this one, that each of the Logic apps also have kind of a tagging, what type of Logic app it is, and I will dive that in when we come to monitoring. So the concept of outbound is through the business events. So business events are available in Dynamics as is. There are just standard amount of business events available, but you can also create a custom business event if you want. That business event ultimately needs to be delivered to what's called an endpoint, and the endpoint configuration is something that you can do in Dynamics, as you see in this slide. An endpoint can be towards a event grid topic, but it can also be a service bus or some of the other options available within Dynamics, as in configuring an endpoint to deliver that particular business event information. So in this case, you need an app registration that allows you to have that trust between Dynamics and the cloud, and it's also necessary to retrieve information from a key vault, where the information is regarding your event grid topic, more or less the DNS, more or less the secret or signature key, I believe, what you need, and that you can find that there in the key vault. So ultimately, that will look something like this. So you have an endpoint URL, your app registration information, your key vault DNS name, what the name of your secret is, at least the key, and then the value has to be retrieved. If you click OK, it will render and set up this connection. If it fails, then you get an error message. So ultimately how this flow is, and this is just an overall view of that flow, is that through Dynamics 365, a business event, let's say production order, let's say it's confirmed, ends up at an event grid topic. From that event grid topic, you have a listener, which is one of the Logic apps. That Logic app subsequently will call out to Dynamics using another app registration, retrieving more of that information, Then it would enrich that message and send it towards the service bus namespace. Then there would be another logic app listening to it because it has a different type of responsibility. One logic app is responsible of getting the information. The other one's responsible of parsing, mapping it, and ultimately deliver it, let's say, to an Azure file share or an on-prem, or through an on-premise data gateway, that file adapter, to on-prem, where subsequently it's been transported towards the machines. How does particularly this business event look like? And this is depicted here. It looks like this is a sales order confirmed business event. It has some information that you can parse within a Logic app, and then you can leverage to call out to Dynamics to retrieve more information. And these call outs we did using the OData protocol. And if you're familiar with the OData protocol, it's kind of a protocol where you can query on top of entities within Dynamics, for instance, and then you get information back. And you can apply certain filters on top of it, allowing you to get the subset of data that you want out of an entity. So that's kind of what your open data protocol is, and that's supported in Dynamics. It starts with a resource URI, resource path, and then your query options, as you can see. And you can also apply some of the filter operations, as you can see, like equal, greater than, logical, something you find in Logic Apps as well if you're using a condition action. So no data call through we leverage an HTTP connector, so not the connectors available in Dynamics, where we're using the HTTP connector because it gives us better performance, and we just want to standardize and just using as least connectors as possible in this case. As you can see there, filter expression is right there where I have the box, the filter expression, then the URL, and subsequently what type of query I want to do, which type of entity, including also the security through tenant ID, URL, client ID, and secret. And the secret comes from the key vault again. So that's why that connector is there. What's really important, having those Logic app orchestrate the in and outbound communication with those systems, is that it's robust, that it has kind of error handling. So what we did is that all of the Logic app have, that tag with IE, XT, and then a number. That's required to identify what Logic app potentially has a failure. So if it fails, then the information is sent towards an error message queue where there's a Logic app listening to it, and then forms kind of a message, an error message that's being sent out as an explanation, as you can see here, or at least an example of that something went wrong in a certain environment. And we did this because it's very important to have kind of the identification where in your process or where in your Logic app something fails, that so you can act upon it. And for this, I just have prepared a very small demo, what I call a robust HTTP Logic app that kind of follows the same paradigm with try, catch, and finally. So if I switch over, then you can see my Logic app, the robust Logic app. Let me just click to the designer view so you have a kind of a sense how this looks. This was just in general applied for all the Logic apps. So you have in this case, it's HTTP win, and then you have a try, catch, and finally. And in the try, you just have one, well, you can have multiple actions. This is just my, I'm just calling an API, and that API result gives a result back. And if somehow that fails, then I have a catch block with a couple of actions to basically get the error message out of one of the actions in the try activity. And then I have an error. Potentially, I can have also send this to a queue. It's not in this one, but I could do that. And then I have a finally that I can do response back and terminate. So if I would execute this using, for instance, Postman. So I'm calling out to the Logic app. Let's just do number one. I will send this out, and it will give me a result back. It just calls back to a Star Wars API, and then the number one is Luke Skywalker. Of course, if I do 100, then this will fail because there are not 100 people in the database of Star Wars. So now it fails. So that's responded back. If I switch to my Logic app and I just expect these runs. So in particular, I'm just going to look at this one. This one failed, as you can see. It fails here because detail not found. That, of course, ends up in the catch block, where you just respond back to the caller in this case. But then you start with the filter array because you want to get that information of the action that failed. So if I just scroll down a little bit more, then you can see that status 404. And some of that information is that consolidated, and you can send this, in the case of the customer, towards a queue, and then subsequently Logic App gives that information back to an incident management system, or at least sends it out to people saying, hey, this failed. So this is kind of a demo, but it's very, very important because all these Logic Apps were instrumented that way. So allowing us to identify where in our processes something failed and then notify someone so they can act upon it. So the mean time of identify is pretty much reduced a lot with just implementing zero error handling. But I think in general, you should make your Logic Apps robust using this type of manner of implementing a try, catch, and finally. Now, if I want to continue, so I talked about in and outbound, something that's very important, error handling in general. Also, when you do coding within the function, that contains error handling as well. I want to dive a little bit more into the experience and challenges, lessons learned regarding this particular use case. So one of the things that is pretty important as well is having automate as much as possible. So having each environment set up correctly. Initially, you could do this with landing zone, but going forward, when you push some of your common resources out, you can use infrastructure as code and have this correctly set up in all the environments to prevent configuration drift. The other thing is you set up monitoring as well, equally configured as well in all these environments, similar to all your interfaces and the Logic Apps and your functions using ARM templates and everything. For the Logic App, you kind of have to extract it. So the experience from a developer perspective is that for the consumption Logic App, Portal is fantastic. So you build your Logic Apps there, you can test them in the Portal. Means what I just showed you through a Postman, but differently you do a production order confirmed within an instance of Dynamics in a test environment, and will produce that business event, and then you can follow through in the Logic App going all the way down to on-premise if it's delivered. If you all tested it all and you think, okay, this works, then you can use that Logic App template extractor built by Jeff Holland initially, and Matthias Lockback continue maintaining this. Allows you to extract that template, optimizes it in using Visual Studio or Visual Code, and then push that to an Azure repo where you subsequently deploy it using Azure pipeline. So within your solution on-prem with the template of your Logic App, that's basically your workflow definition, but also some of the parameters for different environments. And the ARM template itself, you can push that to the repo, and then you can push that towards other environments. Similarly, functions you can build and test in Visual Studio, but then you can do this locally. You test it potentially by using Postman. You push that to the repo as well and use and deploy those through Azure pipelines as well. And within that, you can also apply certain branch strategy and extra going forward. The other aspect is monitoring. So the monitoring of your complete setup. So end-to-end monitoring. So how are you going to do this? So some of the monitoring we implemented using a workbook. Another thing is we're using Log Analytics Workspace. So you see a little screenshot there as well of all the Logic Apps. We're also using Application Insight, of course, for our functions. And we potentially also early on looked at Serverless 360 as a means to do this monitoring. That's not something you can buy off the shelf and configure and allow that to have that as a monitoring setup for, in this case, the Logic Apps. We ultimately ended up by using some of the things like what Azure natively provides and not went for a off-the-shelf product, but had more to do with the fact how monitoring is set up and who took ownership, but I'll dive into that later. Well, actually now, some of the challenges are like how we're going to do the monitoring setup, the support. So that was kind of challenging too. Who takes ownership? Those were kind of the challenges because we upfront did think about, okay, let's do this error handling and notification, and I later look at what the kind of supported, but I kind of struggle a little bit about who owns eventually the platform and who's responsible for what, taking up what kind of error, etc. The other interesting challenge could also be the connectivity with on-premise network. So we're using the on-premise data gateway, but then again, you have to think about your retrying mechanism when a network fails. within your Logic app. Try to deliver it. If it fails, try it again. You can potentially use exponential backoff in your Logic app. Performance was an issue more or less if you had too many files on-prem. So that's where more the performance came in, or let's say throughput, or is when you can get throttling because you end up getting into the limitations of your file adapters. You have to be wary about that a little bit. The other challenge a little bit was the mapping between a business event, at least the complete, let's say, enriched message toward a production order that had to be sent on-prem, because that was just a limited set of data versus a bulk amount of data you're getting through calling back to Dynamics. The other interesting thing was your business events configuration, which I showed you. If you did a database refresh, basically your configuration was gone as well. So you reconfigure your environments again. So that can be a little bit of a hassle as well. Also, because you're using an app registration, you have to think about the lifetime of that app registration, which is about 2 years, and depending how you configure that. So you have to think about that too. The other thing is your deployments also in consideration or in concert with your change management. Also when I'm going to push certain Logic apps for UAT testing. So that's an interesting thing too, and it comes back to your ownership. The other thing is with manufacturing, at least some of these processes going on, they can change a little bit. So sometimes it also means that Logic app had to change. So you have to think about branching strategy going forward when you're deploying certain capabilities or a certain Logic app or certain orchestration capability for your business process. And the other thing is a challenge was message sizes, which I have an example of. And this had more to do with your purchase orders, because they can become as large as bigger than your Logic app, or at least your message queue can handle. The standard can handle about 265 in size. And if it became bigger, then we entered into a problem. You could solve this by saying, okay, we'll go into a bigger SKU, but that was kind of costly. So we thought about, why don't we just solve this by using a claim check pattern and get it from a storage account back into another Logic app, because the size itself was not a problem for a Logic app, but it was for your message queue. So this kind of depicts, our message and size challenge. So it's the way I analyze it, and then we resolved it using that claim check pattern. The other thing is, like I said before, with how do we set up the support, how we're going to do, who takes ownership of what. The incident ultimately through an email came in top desk. So that's an email integration in this incident management system. And then, of course, you think about, okay, who's going to do triage? Who's going to, if it's technical or data related. So you see there's a picture, there's some Dutch words in there, but it's triage, data related, technical, and who fix it. First, second, and third line support. So where are we going to take? So if it's the customer doing first and second line support, or third tier, you would say first and second tier, or is it, a company that basically us doing this, we as an ISV, or is it, only the third tier support that we're going to do in combination with a fourth tier when you're going back to Microsoft if there are any issues regarding the technical setup of the platform. So we're running maybe in some type of issue, or maybe it's a Dynamics type of issue, and then you might have also put in an incident or a ticket with Microsoft saying, hey, there's something within Dynamics that doesn't really function well. So yeah, you really have to think about your support model in general in the complete setup with your interfaces. And then lastly, what's very important as well going forward is set up a knowledge base for the DevOps wiki capability. So document your integrations, your flows, your platform, what connectors you're using, what the most common errors could be, what kind of connections you have set up, the complete configuration of your development, test, acceptance, and production environment. And that really is helpful also when it comes down to supporting, that complete setup of interfaces between Dynamics and other systems, and going back to Dynamics again, the holistic view of what I showed earlier. That documentation can really help, and especially if you do it in DevOps, because then you have your knowledge base, your pipeline, your repo, everything centralized within your Azure DevOps, and that really can help going forward once you do your transition to support. So when it comes down to lessons learned, one of the things I already mentioned is that you need to build that knowledge base straight from the get-go once you're setting up your environments and start building your interfaces. Also start documenting this in the DevOps wiki, for instance, or if you GitHub, then you can do that in GitHub, using that wiki capability was really do that. The other thing I think is from this going forward, have a sound support system set up. Who takes ownership of what part of the environments. If it's the Azure environment who takes responsibility, when it comes to the Dynamics environment, who's kind of owning that. Those things are important. I think I also made it abundantly clear that Logic Apps need to be robust. Also, for instance, for monitoring perspective, or at least getting to identify where in my system something goes wrong. So I can identify, okay, this Logic App is an issue, and then you try to resolve that. So responsibilities, like I said, ownership is very important also when it comes to supporting in the end. And the other thing, I think the lessons learned, we need a proper change management process overall. So some of the basic things that or at least there could be basic things you think of, but yeah, you have to set this early on. It's a part of your governance as well. So this is some of the lessons that we learned. So if you want to get in touch, you can do so through LinkedIn. You can visit our website, so that's irc.nl. You can approach me through Twitter. You can look at my InfoQ articles if you like, because I'm also doing some side things like documenting or at least bringing news items out regarding the Azure platform, other platforms, AWS, and so forth. So this is an interesting website too. So that's also a means of getting in touch maybe. And then, yeah, I want to leave you by thank you for attending this and enjoy the rest of the event.
Hello.
Hello.
Stefan, it's really nice session. Just wait for Ken to join us as well. So that seems like he has some announcements to do.
I guess, were there any other questions for Stefan just before we get into that, or?
No, nothing on the nothing on the portal. Funnily enough, we still have one pending question from custom code. So people really got interested on that.
Oh, okay, gotcha. Do you want to bring that one up then, or?
Yeah.
If you don't mind.
The question that we had there about the custom code is how we'll be able to check the internal server logs errors of the custom code in Azure portal.
Okay, so this is a great question, and actually there's a blog post and video coming out tomorrow on this exact question. So like today, if you look at run history and you have like a failure in your custom code, you will see an error message. It'll be a fairly generic error message. This is, fairly deliberate and standard practice. It's kind of like calling an API. You never sort of expose a lot of, details over the wire. Now, the best way to address this, at least at this point in time, is if you do have application insights enabled for that particular Logic app. What will happen is that there will be a fairly detailed record in the exceptions table. And so in the video tomorrow, it'll be on the tech community blog post as well. We'll show you exactly sort of what that looks like. There's like what's called the innermost exception, something like that. And basically you're going to see something fairly verbose there, and you'll see the exact line where the code actually failed. So I think it's pretty helpful. Certainly we're open to other sort of feedback in terms of what you'd like to see in that regard.
Okay, so now we have a couple of questions for Stefan.
I see.
So
yes.
the first one is from Soren. So great content. Do you single sign-on on-prem data gateways, or is always clustered? I feel that it's very reliable, and taking criticality of the interface into account, you might not always need a cluster.
Well, actually, we didn't use a cluster. So the network responsibility was more on the company itself. So we're less involved in it. I do get it that you might want, for reliability, have it clustered. The other way would be that we, of course, leverage the retry capability. So if we spot a network issue, then, of course, that gets down into the error handling or stuff we set up as well in that Logic app. So let's get notified in the end. And we need to take that into account. But actually, with the on-premise data gateway, we didn't get that much, I would say, error. Sometimes it is that it just gives you, I think, the 404 or something, or at least it gives you the glitch. But because of that retry, it just tries to do it again a couple of seconds later or so, and then it's fine. So it's more network reliability, but in general, it's okay. So yeah, to answer the question is, yeah, we didn't use clustered. So
awesome. The next question that we have is from Justin. So, hi Steph, D365 FO business relies on a batch job to run, right? So there is any other ways to trigger the business events out of D365 FO?
It is the batch job run, and it's true. It's the batch job run that actually runs in behind the scenes. So basically, your business events get queued, and then that batch job basically tries to deliver them to your configure endpoint. There's other ways where our company created some custom, I would say, accelerator code, sending out the business event in a different way, but that's kind of proprietary knowledge. So I'm sorry, cannot disclose that.
Okay. Cool. I think those were the two questions on that. And just reminding people that you can put the questions on the chat at any time. You don't need to leave it for the end. We're going to be sometimes answering questions here and during the chat. Otherwise, we're going to bring the people to answer. Talking about that, we have one last one from Warren. And the question for him is, for bulk batch or import-export, is the best solution the DMF? If so, why is nothing built in out of the box to handle? Maybe it's a question for Microsoft instead of you.
Yeah, depending on your load is DMF. Although, yeah, again, our company built something custom around it, so to leverage what the best ingestion or export is of, let's say, data. So yeah.
Mm-hmm. Cool.
We have a kind of a queuing staging type of framework in the background to handle this kind of stuff as well. Not to, especially comes to the ingestion of Dynamics, depends on how Dynamics is sized and if it can really handle that load.
Okay. Cool.
Something, again, we have something custom for it. So
in this case, you create something custom so you could throttle for the
way your batch
what
jobs
Dynamics can support.
Yeah. It's a little bit more the mechanics on the backside of Dynamics, which I'm a little bit less familiar with, but.
Mm-hmm. Cool. Thank you. Let's see if there is any other question. I think we are on the mark. Just before we bring Anita and Santosh and Alex to the stage, Kent, you want to talk a little bit about our roundtable that we're going to have later on?
Yeah, so two things. The first thing, quickly, I'm going to put this into chat. So the custom code preview is now officially live. So you should see a link to the blog post. There's also a video there. So basically, this should just work. When you open up VS Code, a new extension should get downloaded, and that extension is going to include that new icon where you can go ahead and create the workspace. So that is there. Check out the video, check out the blog post, and feel free to add any sort of feedback, questions in the blog post as well. So that's sort of business item number one. And then the second item is later today, we're going to have a roundtable with some of the PG and also Sandro. So what we're going to do is open up a form where you can go ahead and ask any questions that you'd like to see answered. We'd also encourage you to look at other questions that have been asked and upvote them. We only have half an hour, but we're going to try to prioritize based upon interest. And, we'll have a great interactive session at the end of the day. I believe it's at 2:30 p.m. Pacific time, if I'm not mistaken, but it'll be part of that schedule. So go ahead and throughout the day, if there's sort of product-related questions or adoption-related questions, feel free to put them in there, and we'll see y'all then.
Yeah, and we'll make sure that we add that link to the chat as well. And with that, first of all, thanks so much, Stefan, for joining us again. It's always a pleasure to have you talking about Logic Apps. And we're going to bring Alex and Anita and Santosh to the stage so we can start the next show.
Thanks, Steph.
Bye. Thanks.
All right. And we're here joined now with Anita and Santosh. They're going to give us a little bit of a chat. So I'll let you guys kind of introduce yourself, and then, we can get the video rolling.
Hey, hi all.
Hi all. Hope you are all well.
Yeah, thank you everyone who has joined across the globe. My name is Santosh Ramurthy. I have close to 17 years of experience. I'm currently associated with KPMG and working as a pre-sales architect. That's more about me. Anita, you want to
Yeah,
go?
my name is Anita Ishwaran. And anyway, you will have more interesting things to know about me in the session. So please stay tuned.
Yep.
Great.
Hi all, I hope you are all well. So about me, my name is Anita Ishwaran. So I have got 17 plus of years of experience in Dynamics 365. It's like I started my career when AX was in 3.0 version where you have a blue screen. So and then you enter the login. So it's so good to see how AX has evolved during these years as a FO. So having said that, I not only focus on the technical aspects, I work on integration as well, plus other Azure technologies. So I am a senior digital architect with Sonata Software Europe Limited. So it is a gold partner of Microsoft Dynamics. I am from India, currently residing in UK. And I am the author of the blog anitasantosh.wordpress.com, which is given here. So it not only covers AX aspects, it has various topics like SSRS, CQL, Azure related, Power Automate, Logic Apps. So various topics have been covered in my blog. So do visit when you get time. And hobbies, reading books, as usual, writing blog posts. And I prefer short travel rather than the lengthy ones. Over to my co-presenter.
Hey, hi all. Hello everyone, wherever you are, whichever part of the world you are in. Myself, I am Santosh Ramamurthy, and I have close to 18 years of experience with the Dynamics products. So traditionally, we used to call that as a 3.0. Then we had a latest versions on 2009, 2012. Now that we have streamlined on the naming, we are working on a platform called as Dynamics 365. And under that, there is a suite called as Dynamics 365 Finance is the technology which we work on. And I am currently working as a senior technical presets architect with KPMG UK. Similar to my spouse who is sitting on this call as well. We both are from India, but we currently work in UK. So that's fairly in terms of where we are. And I'm a Microsoft certified professional. Plus, I do also blog. So I'm a Microsoft certified blogger as well, but it's been some time since I've last posted articles. But in terms of what exactly I do in terms of my day-to-day activities, where my hobbies are, I prefer most of the time sitting in front of the computer writing chunk of code. My obsession or possession is towards coding. So I'm kind of a hardcore developer, even though I'm having an 18 years of experience. I do a lot of client interaction in terms of gathering the business requirements as well. But if you see, my forefront is more in terms of building technology on the new stacks, which are available from Microsoft. So that's the core area of interest. Along with that, I am a fanatic on the cricketing aspect as well. So I do watch cricket, I play cricket, and at times I've made also a point to play cricket with my sons. I've got twin boys, so most of the time I spend around playing cricket with them. That's about me. So now you can understand like how we have got into a similar call sitting next to each other, right? So we both are from the same technology, but
so it's a kind of advantage where we can discuss our latest technologies, solutions, all this. It is just another advantage, added advantage to the family here.
Yeah. So that's about me. Yeah. If we can just move on to the next slide.
Yes. So it's about the topic, how we are going to integrate Logic Apps with Microsoft Teams and the Chat GPT. So yes, Santosh. Yeah.
Yeah. So of late, right? So we have seen that there is a key buzz around the Microsoft stack, or in terms of the AI, right? So AI being the next big thing in terms of the computing world, right? So we've keep hearing about Chat GPT, OpenAI, right? So these are the terminologies which we heard about, right? So one of the common thing which we know is we had virtual chatbots or the AI chatbots, And the upgraded version of this chatbots are nothing but the Chat GPT, right? So what exactly this GPT points to? It's basically a generative pre-trained transformer. It's basically a platform or a technology which is more like a human-like conversation. You can ask related to your day-to-day activities. You could ask something
anything about music or programming or daily news or the latest updates in the Microsoft world, whatnot.
Yeah, so we thought like this could be one of the starting technologies, right? We could, why can't we use this as a technology to try to work around a demo, all right? So that's been one of the forefront platform which we are using for today's demo. Plus, we've also thought about how could we use the different stacks from Microsoft, the different offering which Microsoft provides. Example, like a Logic App. A Logic App is basically an integrating platform as a service technology, which is built on containerized runtime, right? So Logic App in itself has close to 300 plus connectors.
And new connectors keeps coming every time, right?
Yeah. So that is one of the things which we have seen. And with in terms of the our experience, right? So we have heavily used Logic App in terms of integrating with ERP applications. So we have connectors for Dynamics 365, we have connectors for Salesforce, we have connectors for SAPs, whatnot, right?
And one major advantage is you need not be a developer if you are using Logic Apps. So it's like little to no code. So it makes any flexible for all the users here.
That's the other technology which we are using today. And then why not use the messaging platform, the cloud collaborative messaging platform which Microsoft provides. And that's been a preferred option more or less during the COVID era, right? It's taken over the other technologies like Slack or Google Meet, right? In terms of the way users have got into the Microsoft Teams. And one of the best places which we have seen this instant messaging service is not even in workflows, the workplaces. It's also used predominantly in schools and colleges, right?
Yeah. That too first during the COVID times, this has been predominantly used in schools, workplaces, where the studies, they don't get stopped. Like it is a continuation, right? So that with the MS teams, they will be able to communicate with the team. The teachers will be able to communicate with the students, upload the sessions for them. So it's a kind of, we are living with it nowadays.
Yeah, so it's kind of a collaborative platform. So where you can share, you can discuss in terms of what is required more towards your workplace. You could also at times cheekily send emojis, right? In terms of if there is any funny thing which you wanted to share with the team or with your colleague or with your school friends, right? So these are the three core platforms which we are looking today, and we have built a use case typically to work on a demo. And that's where I'll hand it over to Anita, and she would be chiming in wherever required.
Okay, so this is how the integration works. So I have I have used few keywords from the MS Teams, the Microsoft Teams, using a channel, and that would trigger the Logic Apps. So based on the input, whatever the user is giving, it would either enable or disable one of the Logic Apps, because it's a day-to-day situation, right? When a developer is working for the Logic in the Logic Apps, it's often it happens that we forget to disable or enable the session. So in that case, I thought maybe just with the one click from the Teams, it will be easy for the user. He doesn't need to log on to the portal to disable it. So with one click from MS Teams, he will be able to get the job done. And also, so here another feature of pitching in the Chat GPT. So if the user is having any query in the team, so he can directly get it, and the Logic App would get the answer for you. So let us see how it is done. Over to the demo mode.
Yeah, before we switch on to the demo, right? So quickly, just to give where exactly this is heading is, as I've just told you, like Logic App is used for an automated business workflows.
Yeah.
And we do repetitive actions with these workflows, typically in an integration scenario, right?
Yeah.
Best use case is whenever we in a scenario where we wanted to have a downtime, we don't explicitly need to turn off the logic app, one of the other, right? So we have used the technology of Chat GPT and use the collaborative message service as well to integrate with Logic App and see how best we could make use of these three technologies to achieve the desired result. This scenario is more in terms of the day-to-day activity in a developer lifecycle.
Correct. Just to save the price of the execution, because there is no need for any empty runs, and that would add additional cost to the client, right? So in order to avoid such situations, this a single click would help us here. So let me focus on one particular workflow here. Let us assume. So you can leverage it to other workflows as well. So I am planning to disable or enable this particular workflow from just a single message from the teams. So let me show you how do I do it. So my keyword starts with question. So it is disable the logic apps. Okay. And now this triggers my Chat GPT, this one here, where it searches for the keyword here, and then it automatically creates, it goes through all these steps and then checks for whether I have given a keyword as the disable. So based on that, it will identify what has to happen, because I have written a separate step to disable the logic app. So if you go here and refresh it, this would be disabled. Cool, isn't it? And you will also have a adaptive card via Logic Apps, which would give you upon success. So now let us take another example. Simple. I have kept it simple. So let me enable the same Logic Apps. So the process goes through the same step is being called, the same execution is being called. And if you go here, it will be enabled. So it is like a seamless integration. So just I wanted to go through, and if you go to this one here also, you will get a message, Logic Apps is successfully started. It's just an acknowledgement that it has done the work. I will come to the other part where we are bringing the Chat GPT here. But before that, I will just go through the steps, what has been done here. So the trigger point starts with the channel. I have created a channel here, okay, and which searches for the keyword question. And this is the team I have specifically created for this demo purpose. Okay, and this JSON card, this is a simple variable which says about the adaptive JSON card, adaptive card JSON. This will be using it just to acknowledge. So we are getting a acknowledgement here, right? Logic Apps. This is the one. So this is a template for it here, and a for each which scans through all our messages. And here it is checking whether you have a keyword for disable, and this is the logic to call to disable the Logic Apps. At the moment, I have kept it as only one Logic Apps to disable it, but we can leverage it to disable the other Logic Apps as well. So at the moment, I have kept it simple. I am not going to disable all the Logic Apps in my resource group. And the next one is, it is a reply with the adaptive card. So this is where we have used the adaptive card here, the template there. And the next one is also enable the Logic Apps, the same one. This is a Microsoft template, which I found it. I will explain my challenges in the later part of the demo. What are the challenges I have faced when I am doing this enable and disable the workflow? And the next one is, how do I use the Chat GPT here?
Now, before we go there, right, before we get into the Chat GPT, right, just a caveat, right? So this typical example, we've used 3 services trying to achieve a kind of a developer-related scenario, right?
Yeah.
But typically, you might get tomorrow a scenario where your sales team does the approval in an ERP, and they wanted to ensure that if there is a credit check or on a particular document, they need to explicitly approve or reject using Teams. So that is also one of the typical use cases which you see, right? So, so the possibilities are tons, right? So you have different platforms which can combine together to solve a specific business or a user problem. So that's where these services from Microsoft help us, enabling us the solution and driving digital transformation across the organization.
And even we need to speak about the license cost, right? So whenever the user needs to approve, he doesn't need to log on to FNO. Just it is a license saving tips also right here in this case. Okay, now how the Chat GPT is involved here, let me show you. So now the next hot topic here is Microsoft Fabric, right? So let me ask this question to Chat GPT. So this triggers the Chat GPT 1, and in few moments it will be giving us the output. So this is again triggered. As you see, it will be triggered, and here this would reply with the channel, reply with the message in this channel. So if you see, it has very well responded to whatever the question has been asked. So if I go back to...
So here, have you used any kind of services for Chat GPT as part of your Logic App, or is it something which a Logic App drives?
The Logic App itself has a connector to the Chat GPT, so that I have made use of it here.
Oh, okay. So we are utilizing the potential of the Logic App,
yes,
to bring in the Chat GPT connector,
yes,
as well.
true.
Very good.
Okay.
Does it also require any tweaking on the connector, or is it a ready-made kind of a connector which
you need to have a secure key, secure token, so that is based on each user. So at the moment I have created a token for me, and using that token I have access. It is like you will be having an account for yourself, right? Because this Chat GPT is under my account, so a token is necessary. So with that token I have connected to the Chat GPT here.
Okay, great.
And if you see what are all the challenges I have faced, since this one is accessed via Teams, I first created using the private channel, and there I had faced an issue where a private channel cannot be accessed from Logic Apps. So then if you are an admin, then you will be able to give a proper permission for it. But since I am not an admin privilege, I have got. So what I have done, I have made my channel as a public one, and I have added the user to access this channel here.
A question here then. So when you say private channel restriction and a public channel, you were able to do it. Can you be a bit elaborative? What exactly you mean? Do you mean that the organization where the Teams is hosted, you don't have the proper privileges to create the private channel?
If you want to give access to a private channel, you should have the admin permission. But since I am using mine is not, my user doesn't have a admin permission here. So that is the reason. Just to go ahead to unblock myself, I have created a channel which is public, and I have added the users. It is not that everybody will be able to access my channel. It is like on the users whom I have added in this channel will be able to send the messages. So it is like that.
Okay.
And even if you see disabling or enabling the logic flow, also had the issue. It is mainly related to the service principle. And for example, it was unable to, because when I trigger here, the Logic Apps was unable to disable the other Logic Apps, though it is in the same resource group. Then I found out we need to have a service principle issue. Regarding this, I will be detailing the details in my blog. So keep my blog, keep seeing my blog, and I will update it today or tomorrow. And for some reason, even the nested Logic Apps is not available in my subscription. I am not sure. Maybe it is because of the trial subscription. So I had to call a separate HTTPS connector and then call the Logic Apps. Otherwise, if you had a privilege of using the nested Logic Apps, it would have saved one more step.
So what exactly, so when you say you had issues with the nested Logic App, was it more to do with the Azure subscription, because we are running on the free trial?
So. Yes, because when I checked it, my other it depends, maybe it is a free trial, right? So it might be a reason where we don't have the option of the nested Logic Apps. And then, so just to unblock myself, what I did, I just used a HTTP connector and called the other Logic Apps using the HTTP trigger. So that did my work.
So in short, so we are making use of best of both worlds.
Yes.
So we are utilizing on the one side the free services which Microsoft provides.
Yeah.
So typically we get the free credit from the Azure. So we've used that as the start point, and then we've taken 3 of the core services from Microsoft, right, and tried to interact with the automated workflow to see if we are able to get the desired results.
Yes. So just to repeat, so at the moment, I have only given a demo of enabling one Logic Apps with one single message. So we can also tweak this Logic Apps to disable the entire Logic Apps in the particular resource group. So even that is also possible. Just to keep the demo simple, I have only taken one Logic Apps in this case. And thanks for giving us the opportunity to present us what we have explored.
I hope our session was useful. And if there are any queries, please reach out to us. Thank you.
Yeah, thanks a lot. Have a great day, everybody.
All right. Thank you, Anita and Santosh, for that. So looks like we have at least a question in the chat here. Wagner, thank you for putting that up. So it looks like can we ask a follow-up question, or is context lost after every question? Oh, not sure. I'd feel free, and whoever added that question, any
That's
questions,
Yeah,
are
so
welcome.
Vivek, please add questions, and you can answer here. We have like a bit of time before the next session. In the meantime, some kudos for you from Justin. Thanks, Anita and Santosh. You're giving me some great ideas here with Teams and Chat GPT. So
they used the best of the technologies which Microsoft has, and they could build some new ideas which could end of the day solve business problems or problems for the end users.
okay.
No, I think if I
Another
remember,
one
what Vivek
from
J was asking was about the follow-up question in the Chat GPT. I think where we'll be asking a question, the keyword as question, right? So yes, Vivek, it is possible to continue the conversation in the same window, and you'll be able to get the response for it as well.
Yes. So in the end, the questions from Vivek, just for the people that is on the show, is can we ask follow-up questions? Is not follow-up questions on that stream, is follow-up questions with Chat GPT, right? And as you say, can you repeat the answer for that?
Not
Anita?
lost. So in terms of the context is not lost. So it keeps a track of the context what we had, and it continues from there. So it is similar to what a Chat GPT offers as part of the API.
Mhm.
So that's been hooked into the Logic app.
So it keeps that session.
Yeah, so that you have that session continued.
Perfect. Thank you very much. Let's see if there is any other questions. Feel free to add anything else in the session. And while we're waiting for the people to ask any other questions, how was your experience here? Because I think it was the first time that I saw you on the Logic Apps community. So how was your experience doing this presentation and things like that?
Yeah, we both being the first time speakers here. Even this is the first session we are giving here, and the support which we received from your team was seriously, it was we had the communication proper, and they were able to support us wherever we had some issues. So thanks to the Logic Apps Aviator community. And yes, this is with this session, even we are able to learn what are the glitches we will face when we give a presentation for the first time. So thanks all.
For me, at least from my experience, it's been great. Right. So I was onboarded pretty late. To be very frank, it was only my bed half who was supposed to give. Yeah, but I did onboard a bit late, and then from there I kind of took it off. So my view on the Logic app was more in terms of my experience with the Dynamics 365 ERP suites. Right. So I thought that would be the best scenario for us to take it forward. But we thought, let's talk about the latest technology and try to also pitch in where possible the solution which we work on a day-to-day. Right.
Yeah, and thanks for that, because I think a lot of people, as I saw on the feedback, a lot of people got quite interested on that. And Alex, any questions from you?
Oh my, that's a good question. I was prepared to think of a question. Give me a second, I might have one.
Maybe if you want to answer any questions, you can ask our Chat GPT. That would help you.
Right.
Cool. So yeah, I don't see any other questions apart from Vivek thanking you all for the answers. So thanks for taking time for that. And actually, there is one question here from Justin that is No, it's actually that was an answer from Amber from our previous sessions. So I can see that people is watching and coming back and forth on all of that. So we have 3 minutes before, 2 minutes now before our next session start. So we're going to go to a little break and come back at the hour mark with Justin. I'll just add Justin here really quickly to say that hi, while we and then we go to a break and come back with him. And thanks Anita and Alex for hosting that side of the show.
Thanks all for giving us the opportunity.
Cool. So see you all in a minute, and we started with ERP. Justin.
Yeah, thanks very much. Are you breaking now, or we come back?
Yeah, let's do a quick break, and then we come back just to make sure that we don't get too ahead of ourselves.
Okay. See you later.
And I think we're back. Hi, Justin.
Hey, Ragnar.
Just let me take that banner out of the way, and we're back. So tell us a little bit about what we're going to talk today.
Now we're going to talk about some ERP developments. You saw some reference to D365 in some of the previous sessions. So going to give you some of our experience Salesforce to D365, but mainly focusing around like the ERP error handling, some lessons learned. Hopefully it will be practical Won't be waffling too much, but
Okay, awesome.
yeah.
So let's start with the show. And I know that you're going to be on chat for questions, but if you have some time, it will bring you back to answer anything that we still have live.
Okay, thanks, Wagner and team. Appreciate it.
See ya.
Hello, my name is Justin Lovell. Welcome to ERP to Cloud Integration Redundancy Patterns, made possible by the fantastic Azure tools. Let's just jump straight into a session overview. It's going to be fast and furious. There is a total amount of content we're going to get through, so please bear with me. We're just going to do a little bit of an introduction to our journey, look at some project statistics, and then review some different patterns with regards to requirements, the design, error handling, transformations, and then how to manage our solutions going forward. Just a little bit about who we are. DMix, 6 of us, started 2018, do a lot of software dev, but we focused on integrations, ERP integrations, CRM systems to ERP systems, a lot of big data migration projects as well. Why have we shifted to the cloud? Purely because of the enterprise scalability and performance that comes with a click of the button. Truly amazing. In the old days, having a server with a couple of racks and then trying to upgrade that over time, what a nightmare. Now we just drag the slider and we have what we need. Out the box redundancy, 100% serverless. Thinking about zone redundancy and even availability zones that are offered by Azure. But let's face it, when a country goes down, there's bigger problems than just worrying about our integration still running. Think about single organizations having different requirements within them. This is a big issue at times. We're going to look at that. Pay as you go, strong incentive. Think about that picture there. You can see of the fancy car. You go and buy a fancy car, and you drive it maybe once a month. Do you want to spend all that money, or do you just want to call a cab when you're ready to take your trip? And that's pretty much what we're talking about when we go pay as you go, especially the consumption model that we love so much. As your sales increases, so your transactions increase, therefore you need more performance. It needs to increase, but so does the cost. But here's the key. When you're not making those sales, well, you're going to have less transactions. You're going to need less performance. And at the end of the day, it's going to cost you less. You're not just going to pay for something fancy sitting there doing nothing. A key point that we want to bring out is also, how can we recover these integration costs? Typically, integration costs always been bundled in with the IT expenses. But now, maybe we can get to that elusive customer admin or platform fee that we can pass on to the end customer. Just to let you know, our first production go-live project using the full Azure Logic Apps Service Bus functions project was done in June 2018 between Salesforce and AX 2012 R3, customers, vendors, the full shebang. That's what we've done. All right, let's move on to that project statistics. We had a number of different connectors, obviously Salesforce, AX 2012 R3, which didn't have a standard connector in Logic Apps. So what we had to do is we had to write a REST API wrapper to wrap the SOAP services of the on-premise AX solution, and then using our custom connector to hook into that and pass the JSON to convert the XML into AX 2012. D365 FinOps, well, that's great, comes with a standard connector, so we don't have to worry about that. A lot of other third parties, websites, other systems providing us data, other systems online, cloud systems like Zendesk, Jira, SharePoint, Office, and importantly, we'll talk a little bit later about Azure Data Lake and Data Factory, as well as this solution also had some elements of master data services, so using the SQL connectors available in Logic Apps to hook into the back end of that. Just to give you some statistics, the system that we came in to replace used to process a service contract one every 45 minutes. Now, a service contract is not just one thing. It's made up of many different components, customers, vendors, you name it. But that whole process used to take like 45 minutes. Now, we can process 55 every hour. About 40,000 of them are being processed every month. What's nice about in Azure using the dashboards, we can hook into various Logic apps that show us what our processes are doing. We can start to get some insights into things. For example, how many contracts are we processing? And you can see the variations, the different days. You can see the spikes in integrations. Why are they processing 5,000 contracts on that day? Giving us insight, going back to business and finding out what's going on. Also kind of looking at the seasonality of leads and opportunities coming into the organization. Obviously, over the weekend, you can see less than during the week. What does all of this cost us at the end of the day? All of this work, all of this processing, crazy as it sounds, about $200 a month. And that's if they're making a lot of sales. All right, let's jump into the business patterns, business requirements and costs. Very important. The smaller the organization, the easier it is to standardize. But when you start dealing with multinationals, companies that have footprints in different countries, you start coming across the concept of having companies within companies. And then they have different requirements, different systems to integrate, and of course, a multitude of different egos. So we've got to make sure that we realize the reality that as developers, we all try and make things generic. We want to use the same thing over and over again. But one size fits all, and sometimes an integration is not reality. We just got to face the fact, and we've got to address that. So how did we go about trying to segregate, ring fence different business units and environments? Well, we used our resource group per business unit, per environment. For example, Australia, UAT, Australia production. We can now tell you what's running in Australia in production and in UAT because we've got a resource group. All the components in the resource group, ring fencing costs for that business unit in its resource group. Same Logic app, yes, that we may have the same set of integrations. We deploy it into these different environments, may all be the same from the same code base, but if there are different requirements in those areas, we can branch out and host a different version of that Logic app. And then getting to that customer admin fee or platform fee that we've been trying to get to. Now that we have a resource group per business unit, per environment, we know at the end of the month how much it costs us to run Australia or North America in production. Now, if we take that divided by the number of customers, we can now start looking at an average cost that we can start passing back to the customer and recover those integration costs, not just having them all lumped into the IT budget. One thing we always say is please understand why you're going to use a resource group. Don't just view it as a folder to throw random things in. Look at your resource group and think carefully about how it's going to help you achieve your objectives. All right, let's look at decoupled integration design. So this is what we're trying to get here. We're trying to get to a place where all the different integration components run on their own. They don't know about each other. Why is this important? Well, when you have a massive system integrating multiple things, if one component goes down, we don't want the whole integration system to go down and stop. Everything's got to keep on working. And maybe one system's down. When the system comes back up again, all the messages are queued and carry on. So we've got to really try and decouple and have things running on their own. That means different components should do one and one thing only. This is where Azure Service Bus has really helped us. Really, it's helped us here because by means of a queue, we can have Azure components such as the Logic app consume information, process it, and send a message. It sits on a queue. Then you have another Logic app on the other side, grabbing that message, doing what it needs to, and pushing it off. Doing that way, the Logic app can do one thing, and yet your message is still kept in between. One thing we've come to realize, each queue that we create should only be for one type of payload. Don't have a queue with multiple payloads. It just doesn't work at the end of the day. It gets too complex. So queue, message, logic app, read, send it. Dead letters, we enable dead letters on all our queues. Why is this great? Because if anything in the logic app fails, we just automatically dead letter the message that we were doing. So we've got an error queue. Those messages sit waiting for us to eventually reprocess, investigate, and handle. Nothing, no instruction, no event gets lost. And that's so important in a big integrated system. Just to have a look here, for example, the system that I've been talking about, if you have a look here, in 30 days, we're talking about 1 million requests and about 230,000 messages. What's the difference between requests and messages? Well, requests are any actions on the queue message. Messages are actually when you have processed the message and it's been completed. How much does this cost us at the end of the day? As crazy as it sounds, 10 cents. Yeah, 10 cents on the consumption model. Don't forget to use message properties such as correlation ID, label, and message ID. What this is going to help you is, because now we've decoupled all our different processes through different logic apps and different messages, we want to be able to pass through an identifier to track all these different components and how they relate to each other. And that's so valuable in using these properties on the messages to track, and so you can see what is all related to each other. The disadvantage, though, of decoupling everything and having a message in between is that the logic apps have got to read the message, and those messages are based on recurrence. So the connector looks at the queue every second, every minute, every hour. So it's not really event-driven. So for example, if you had a logic app that was triggered by an HTTP request, you could trigger the event immediately. Well, now we're not really doing that. So as close as being to event-driven we can, we want to. Some cases we can do that, but in most cases the pattern is send a message and action the message. One thing we're going to always ask you to keep in mind is your payload size. That's what I'm talking about, is the message size. Now, it is possible in the queues to have a very big message, but remember, your logic app components such as parse, JSON, and your arrays have limitations. This hit me big time. Developed a whole process, and eventually one of the messages that came through were too big for the components to process. Had to throw that solution away and redesign it. Think carefully about your payload sizes and the limitations of components within within logic apps. Service Bus Explorer, thank you so much, Paolo Salvatore. We've been using your desktop client for all these years, these 4 years. What a wonderful tool. But now a lot of that functionality is available in Azure Service Bus. You'll see it there when you go to your Azure Service Bus namespace. On your queues, you'll be able to peek and edit the message, resubmit the message, complete the message, delete the message. Most of that functionality is available in the browser. Okay, I told you it was going to be fast and furious, and truly is. We're looking now at some of the patterns within your Logic app. And when I talk about Logic app, we're talking about the consumption model. We love the consumption model. Why do we love the consumption model? Because it's 100% serverless. It's true, a single Logic app can only have one business process, but that's our design. We want it to do only one thing. One of the things that have been very important to us is naming conventions. I'll tell you why. When you use the Azure search box, if you have named your Logic apps consistently, you can find Logic apps that relate to each other and process that relate to each other by simply just typing in the words. So our convention is, we say business process, source system to target system. So in the case of like this one here, sales order, Salesforce to ASB, Azure Service Bus. Then on the other side of the coin, sales order, Azure Service Bus to D365 FinOps. Easy to understand, easy to find. Some key things you need to please remember when you're designing your Logic apps are these two things: the retry policy on some of the connectors. Now, by default, it is the default setting means that it will try 4 times to action if there's a problem. Now, our policy, our design policy, is always to set it to none. Always to set it to none. And then when we have to change the retry policy to a policy that is going to be resolving an issue. Now, why is this important? Because that we've set it to none. We see when our logic apps fail on bad gateways and timeouts. Yes, we may need to add ways to overcome it, but at least we are notified. At least we understand what's going on. At least we see what we need to fix. Another thing that's important to remember in your logic apps is the loop concurrency control. Now, by default, loops will run in parallel 20 things by default. This is not a bug, as some frustratingly have asked. It's a powerful feature if you know how to use it. But once again, our design policy is that by default, when we come to these loops, especially on the parent, we will always set the concurrency control to 1. And then when we need to, and we understand why, we will increase it to the level of parallelism that we need. One thing to keep in mind, please, always, is that each action in a logic app costs you something. So try as you can to consolidate logic and processing. For example, when using GET requests to look up data in a system, yes, you can maybe do like 5 GET requests to look up the customer, look up the contact number, look up the address, you get what I'm saying. But some of the components, like for example, Salesforce has a component called execute SQL query, where you can actually create this complex query like with joins in it. And then instead of doing all those lookups, you just do the one action. So you can imagine you do 1 action versus 5. And you talk about 40,000 contracts. You can imagine the savings that you get on that and on the processing time. Also, keep in mind that your logic apps only allow a nesting depth of 8. Don't get to the point like it happened to me, where you've developed your whole logic app and it's running, and then you realize you need to add some more logic in, and you try add your next layer and you can't, and then you have to rework that whole thing again. So once again, design before developing. Okay, moving on to error handling. 2 types of errors. We like to classify them. One is a handled error and one is an unhandled error. Handled errors is we know what's going on. We know why it fails, because the email address is not valid, correct? Or there's some processing logic. Whatever the case may be, we always store the errors, the results. We never just delete them. We always keep them. We always try to understand them. And then in most cases, we always broadcast those failures, whether they're broadcasting those failures via email to the support team or to the user. We inform, we communicate. Unhandled errors, things like API rate limits, gateways unavailable. Wow, I can't believe sometimes how many times the gateways are not available. Bad gateway. Maybe you've got some bad code. And for example, like the parse JSON, maybe the payload doesn't adhere to the schema, so it will fail. All these kind of unhandled errors we catch and we generate. And then what we do is we send like I said, we send a message off to the relevant party. Now, I just wanted to show you the kind of an email that we send. Put the logic name in the subject, whether it's successful, failed, even put a little bit of the message of what failed. In this case, the duplicate value was found, and then using the Logic App Run ID as a hyperlink in your messages. So valuable. For one click, it can take you to the instance of that Logic App, and you can see where the failure was. Once again, keep in mind, keep the message until you know the message has been fully actioned. Whether you have to resubmit it manually or have a process that automatically resubmits, it doesn't matter. Keep it. Don't delete anything until you know that you've done what you need to do. Just to show you how we handle unhandled errors here, the try-catch best practice method in all coding. We know how that works. How do we do this? How we implement in Logic App? Simply by using a scope component. That scope component says anything that happens in that scope component can be successful or can fail. And then what we do is once we've got that, then we will use a filter on the result of the scope and get out the actual error. And once we've got the payload errors out of that scope component, you can then process it. In this case, what we do is then we send that error to a generic logic app, which knows how to decompile or process that JSON and then send on the relevant errors and messages to people and systems. Okay, advanced transformations. How do we handle this? Well, by using two tools available to us, Azure Functions and Azure Data Factory. Azure Functions are wonderful. It's wonderful to have this piece of C# code just floating out there in the universe and being able to be called. Really, it's incredible. But think about things like complex XML or custom EDR, electronic data exchange contracts. You'd be amazed when you deal with integration how many different formats are out there. Even some integrations having like hidden characters as delimiters. Now, when you've got C# in your toolbar, you can just code anything. You can do anything. You can create, consume any contract. We love using the C# classes, using data annotations and validations to help us actually validate the payloads that we are passing in. Of course, hooking it into Azure DevOps for version control, and then even being able to do automated unit tests on that. It's true, you can use other tools like liquid templates. But in the case of us, in the consumption model, we realized that those things come at an additional cost. And once again, you're having to provision resources that sit and wait there for you to use them, where we're trying to do everything pay as you go. So for example, you're going to have to, if you want to use liquid templates, you're going to have to upgrade your Logic App pricing tier. And you're going to have to get an integration account, which is essentially gives you access to an Azure Blob storage where you keep your contracts and schemas and all of that kind of thing. There is another tool that's been in preview since April 2023, last month, which is the new Azure Data Logic Apps Data Mapper. So check that out. Unfortunately, it's not yet available for the consumption model, but we'll keep our eye on that and see what we can use that for in the future. I just wanted to show you an example in an Azure function here and how we're using the Azure function here. So here we've got a class, obviously got the different attributes of the payload, but you can see what we're doing. We're using the annotations. So we're saying this is a required field. And if it's not required, and if it's not provided, then send back the error message here. Submission method is required. And then what we have is we've got our methods where we actually go and then generate. In this case, it was a very customized version of an XML document. We had to customize it and put in the various placeholders there. So love using Azure functions for doing some more complex transformations. Talking about Azure Data Factory for advanced transformations. You must say, why do we need Azure Data Factory now with Logic Apps? Well, let's face the facts. Logic Apps are not designed to manage bulk data. It's a process, it's a message, it's an event that the Logic App needs to grab and do something with. So we will rather offload any bulk data transformations into tools that are designed for that. And this is where we use Azure Data Factory. For example, two scenarios, just want to touch base briefly with you. Scenario one, we need to get a whole lot of data into Azure D365 FinOps. So what do? In FinOps, we go and we can generate what we call a package, which is like it's a file schema that tells you how to structure your data and store your data so that it can be imported. So what we do now is we have an Azure pipeline that gets the data, transforms it, and zips it into the correct format, uploads it onto Azure Blob Storage. Build a Logic app that monitors that, grabs the file using the connector, standard connector, upload the file into FinOps, and then FinOps does all the bulk loading, importing, not having the Logic app, having to loop through each and every single record. Scenario two, looking at where users upload their templates, their documents into a SharePoint location, having a Logic app looking at that SharePoint location, grabbing the files, and then sending that file onto an Azure Data Factory pipeline, letting it do its work, and that maybe even writing back to the underlying databases. Just want to show you a quick example of this here. So here we've got, you can see here we've got an Azure Data Factory pipeline. It's reading some files, it's doing some conversions, we pass in some parameters, then we merge some of the files, and then we actually write the files out to a database, the results of it to another database, and then do some cleanups. And then here in the Logic app, we use the Azure Data Factory pipeline connector, connecting to our environment, and then just passing through via parameters reference to where we're storing the file on blob location for the Azure Data Factory pipeline to pick up. Okay, last but not least, we're talking about the patterns for building, testing, and releasing. So this is where we love Azure DevOps, because Azure DevOps allows us to connect into our different Azure environments. And we can code on our laptops, we can code in the browser, we can code wherever we are, we can have it importing, exporting, but our code is all going to be in a repository. That repository is going to be built. It can test the results of the build. And then when we're ready, we can deploy that information, those artifacts, into our different environments. So for example, here we've got our build, and then we push it into our test environment. At the same time, we push it into our UAT environment. When the UAT environment is done, we get an authorization that pushes it through into prod. Sure, you're familiar with these kind of approaches already. But what we do is the way that we define these ARM templates is important for us. We've come to understand and appreciate that each Logic app should be in its own template. And then the rest of the resource group, like the API connectors, service bus definitions, or the storage locations, we can group that into a template. So if I just zoom in here, for example, we'll have a resource group. And in that resource group, we'll have a whole lot of different things like our service plan, function app, all of that managed by this deployment in the resource group. Typically, that doesn't change often. But each Logic app here, each Logic app will be on its own. And then in the deploy release, we will obviously deploy our resource group and our different templates. And what we will do is deploy and release each Logic app individually. Why is this important? Because if the Logic app fails, we know the Logic app failed. We don't have this massive script with 20 Logic apps that fail. Now, which one, and try to find in that script. We handle each one individually. This helps us when we do automated builds and testing, being able to pass the sample payloads to test these Logic apps. And also we can generate pull requests when we work on a specific Logic app for a teammate to action and to update. And then obviously just that piece of code is going to be affected and changed, not a whole massive big deployment script. Those are some of the patterns and concepts that we wanted to share with you today. It was fast, it was furious, and we hope that one or two points have stood out to you, and we look forward to hearing more from you and answering some of your questions. Thanks so much. Hello, my name is Justin Lovell. Welcome to ERP, to Cloud Integration Redundancy Patterns.
I think I was in a loop here. All right. So the thanks, Justin. There was a lot of really interesting patterns there. I'm waiting to see if there is any questions on the audience. Didn't see any yet, but question for you while you're waiting. From those questions, from those patterns, how many of those do you think it could be also applicable for Logic Apps Standard?
I think all of them, really. All of them. It's just the view of standard versus consumption, having a dedicated environment that what's going to cost you so much versus an environment that's going to change all the time. But really, it's exactly the same. I mean, the biggest challenge is that most of the functionality made available is available first in standard, and then only later it's coming through into consumption. So
yeah. We have a gap to close in standard, so prioritizing that and consumption for the things that people is using today is stable. So doing that the balance is interesting one, but it's a really good feedback. Any parting words that I think is people's still processing the amount of information, as you said, was fast and furious. So really good. Right.
For sure.
And any that parting knowledge before I bring in Kent for our next session.
Yeah, I think, just going back to something that Steve said earlier, he mentioned that we've got to take ownership, and there's got to be clear ownership of who's looking after what. Now, with the integration, we've actually got an integration support engineer. That's quite a long title. But this person is monitoring and seeing what's going on and being able to action messages, resubmit, or follow up. It's so important when you have such a massive environment with so many components and messages going on. The reality is there are errors. And when you connect to multiple systems and people go to different versions, APIs change, you never know what's going to break. So you've always got to be ready and have someone eyeballing things,
Okay. Thank you very much for the joining the show. Let me bring the Ken to introduce our next guest. See you later, mate.
Cheers.
Yes, hello everyone. So our next session is from Toon van Hout, who's a Microsoft MVP and very knowledgeable in this space. And so his sessions, he's going to talk about he calls them mistakes. I'll call them learnings, but the 5 biggest learnings that he's had while working with Azure Integration Services. So based upon the type of content that Toon gets involved in, this is going to be a great session. So Wagner, let's go ahead and roll the film. Toon will be available for answering some questions in the chat. So
hello everybody, my name is Toon van Houten and welcome on this session about my 5 biggest Azure integration mistakes I want you to learn from. So I'm Toon van Houten from Belgium. I'm the CTO at Noost. And with Noost, we want to make people's life easier and more efficient. And we do that by crafting digital solutions on the Microsoft stack. I'm the founder of Your Azure Coach, and I've also been awarded as a Microsoft MVP, mostly thanks to my contributions in the Microsoft Azure integration space. So it's about 5 mistakes I want you to learn from, just to be sure that you don't make those mistakes like I did. And the first one is about, maybe you can guess already, but about networking. So we always start with the use case, and this use case was a customer where we needed to build some internal APIs. They might contain some sensitive information, and we had to connect to the on-premises SQL databases. So luckily, the customer had already a network infrastructure, so it was a typical hub and spoke network architecture, where there was a hub network and we got our own spoke, so that was already fine. And we wanted to use Logic Apps because it was a perfect use case, a perfect fit for our use case. And the Logic App would have been secured with Azure Active Directory, just to increase the security. This is a Logic App standard because Logic App standard can integrate in the network, and that's what we will need. We were also lucky because there was already a VPN gateway in place that connected over the express route to the SQL Server on premises, so we didn't have to take care of that. Of course, our Logic App, it was deployed on an app service, so it had to integrate through VNet integration into the network, so it could outbound connect to the SQL database, so that was no problem. And we also gave it a private endpoint, because thanks to the private endpoint, Logic App became available inside the private network, so it got a private IP address assigned. So, because our goal was, you should not be able to connect to the Logic App from public internet, you can only connect to it if you're inside the network. So our API management was inside the network, and the local internal application that needed that data connected through API management over the private endpoint to the Logic App. So that was the design. There were 2 problems with this. The first one was more a business priority problem. The Azure AD, role-based access control that was on top of the Logic App was deprioritized. So all the priorities, I don't like it, of course, that security gets pushed to the back. But in the end, it was deprioritized because they said, okay, you still have network security. So for the content that we are currently exchanging over the APIs, this is sufficient. But unfortunately, public access was also still enabled on the Logic App. So that's It's not because you enable a private endpoint, so that you enable private endpoints, that you automatically disable the public access. So disabling the public access is actually an extra setting, an extra boolean that you need to set on your Logic App, your Logic App standard, and that was something that we forgot. So as a result, our Logic App was on public internet without any application security, so we had a data breach. Luckily, we found it pretty fast, but of course, how could we avoid that in the future? Because making mistakes is one thing, but making sure that you don't make them over and over again is even more important. So the old way to solve this would be to say, okay, the development teams and so on, they are not allowed anymore to provision the infrastructure themselves. Everything will be provisioned by the central infrastructure team. A little bit like it was in the old days on premises, where one team creates all the virtual machines for you and provisions the SQL databases and so on. That's of course very good for consistency, because one team is taking care of everything, but you lose one big advantage of the cloud, and that's the velocity, the speed that you want to make. So in the new way of working, it's better that there's indeed still one central infrastructure team, or call it a cloud center of excellence, or call it whatever you want, but a central team that provisions landing zones with guardrails. So landing zones are subscriptions typically with a lot of policies enabled to ensure that everything you do is still in the guidelines of the organization. And one of these policies could be to say, hey, it's not allowed to enable public access on your app services, for example. So with that, you still have an infrastructure team that has full control on the environment and that can guarantee the consistency. But on the other hand, you still have the velocity because the development teams can still create resources. That's where really Azure policy becomes very valuable, to have those guidelines and those rules, which are typically just documented, that you really can enforce them on a large scale within your Azure environment. To make sure that the rules of the game are limited within the Azure environment, but you still give the keys of the kingdom to the development teams. That was the first mistake I want you to learn from. The second one has also to do with security. Use case here was actually a customer that had a strategic goal to share data with their own customers or even with their suppliers in a self-service manner. So they didn't want to have many support tickets, and they didn't want to have a project for every integration. No, they wanted self-service. So if I hear that, that's typically a use case for APIs. And if you do APIs with the external world, it's a good practice to use API management. And in our case, of course, Azure API management. So Azure API management is an abstraction layer, a gateway between your backend APIs that you see here at the bottom and your API consumers, the people, the applications, maybe the machines that are consuming your APIs. What role does it play? The most important role is to have security. You don't want an API consumer to connect through 5 different security mechanisms. No, you typically want to have one unified security layer on top of your API management. And then under the hood, you can do the translation to the different backend APIs. Another one is the routing. So for example, if you have 2 APIs, but you want to expose them to your consumer as one single unified API, you could do that with API management. And the same with transformations. A good example is, for example, transforming a REST API into a GraphQL endpoint, or even the other way around. If you have a GraphQL endpoint, but you want to expose it as REST, you can do that easily with Azure API management. It can also be used to optimize your APIs. I'm just thinking about consistent error handling, about versioning that you can include, and maybe even caching. And of course, because all the traffic goes through your API gateway, you have one central place where you can monitor the usage of your APIs. So what's the most popular API that you are using? Where do you, let's say, see the most issues on the APIs? Which APIs are throwing the most exceptions? What's the performance of the APIs and so on? So you can really get valuable business and technical data out of that central monitoring. And last but not least, let's think about the self-service manner. If you want to do self-service, a kind of a developer portal is also very important, that you can engage with your API community, that you don't always need a lot of interaction to get started so that they can get onboarded to your API program very quickly. So we used API management. The customers and the suppliers, they were using Azure API management, and they were connecting to our backend APIs. Some RESTful APIs, some GraphQL APIs. And API management works with policies. And a policy is actually an XML file that changes the behavior, the configuration, the behavior of your API through configuration. So you can have such a policy on the operation level. So that's a policy that's applicable for only one operation, for the get order operation, for example. So there you can, for example, say, okay, we do a transform operation, or we introduce caching on that one. If you look at that XML file, it contains a base element. You see it 4 times. In every section, you see the base element. What is the purpose of that base element? It actually refers to the policy of a level higher. So if the base element of the operation policy actually refers to the policy on the API level. And again, that policy, you can configure whatever you want. You can do some routing, some rate limiting if you want to. And that XML file will again contain a base element that then refers to the global policy. And that global policy is, of course, a very important one, because there you typically have your global security that is applicable for all your APIs. So what did we do? We had our APIs. Some of the APIs were Azure Functions, others were Logic Apps. But I forgot in one of the APIs, the base elements. So I changed the policies and I removed the base element. That's something that can happen to everybody. Even some people don't know actually the full meaning of that base element. But because I did that, we didn't actually have a global policy on that API. So that means that that single API was on public internet because it was an external API without security again. Just because I, as a developer, just by accident removed that base element. So you see, such a simple mistake that everybody can make can lead to a data leak. So how can you resolve that and make sure that you don't get in such a situation? There are 2 ways. One is proactive, the other one is reactive. So the proactive way is to make sure that inside your CI/CD pipelines, preferably in your CI pipeline, that you validate your API management policies, XMLs. And so that you go through these files, that you scan them, and that you ensure that the base element is present. As in that way, you always ensure that the parent level policy is available. Another thing you can do, I have it also on my blog, is running a script against your API management and doing the same functionality over there. But of course, that's more a reactive way because you only find the problem when it's already there and when it's already activated. So maybe a combination of the 2 might be even the best option. The third mistake I want you to learn from is about integration, of course. So we had a customer that had a buy before build strategy. So they want to buy applications and only build them if they don't find a solution out there. But of course, that means that they had quite some applications, and not one big monolith, but one application for their HR stuff, one for the sales, one for the ERP and so on. And these applications, of course, need to integrate in a near real-time fashion and communicate with each other. So that was a challenge. So that's a perfect use case for integration. So that's where Logic Apps comes into play. And this was a very simple design that we had. A little bit for the people who come from a BizTalk background. This is a little bit, the BizTalk architecture where you have your publish subscribe engine in the middle, and you have your Logic app connecting to the source, publishing a message on the event grids in this case, and one or multiple receivers can subscribe on the message to get eventually the synchronization, the data synchronized towards that destination system. So it's common design that you often see. What was now the problem? One of our destinations was SAP, and they had a maintenance window. So they wanted us to stop the integrations for a while and then resume afterwards. So we stopped the Logic app, but because Event Grid is a push-push system, so it pushes events with a webhook to Logic Apps, it started failing. And luckily, Event Grid is, of course, a reliable engine, so it will start retrying. But we actually wanted to have a graceful shutdown of our integration, but we were actually not able to do that just because Event Grid uses that push mechanism. So no graceful way to pause integrations. That was actually quite a mistake from my side. So we were able to solve it by introducing service bus. So same, it's also a pub/sub engine, but it's in a push-pull model, where the receiving side determines when they peek a message and when not. So that's why for integrations, for reliable integrations, it's always good to consider service bus over event grids. And that's what I mostly do. Why do I prefer, in most cases, service bus? It's because you can control the processing speed. If you get certainly hundreds of messages at the same time on the service bus, you as a consumer, you still choose the pace at which you will process those messages. So that's a big advantage. It's also more firewall friendly because the push mechanisms of event grids, they really go with a webhook. So that's an inbound HTTP connection, which is not that firewall friendly, while the pull mechanism of Azure Service Bus really ensures that you have an outbound connectivity, which is more firewall friendly. It's also more reliable, the service bus, because you really have the peak lock pattern. You peak a message from the queue, it's locked for everybody, and then you can really complete the message from the queue. So you have a two-phase commit, which makes sure that you have at least once reliability. Event Grid doesn't have that. They have retry mechanisms, but it's purely retrying, which is not that reliable. And Service Bus is also good because the messages are stored over there. You can look at them, you can inspect them, you can even peek them without removing them from the queue. Also from a monitoring perspective, it's sometimes good to see, what are my messages, what messages are on the queue. And then the last one, in integration, we often need FIFO, first in, first out, or also order to delivery sometimes is that named like that. If you want that, you can use Service Bus sessions to make sure that within a certain scope, if, for example, the patient information of one certain patient, that you can process that data in FIFO in the right order. So it's good to mention that at the latest Build conference, Event Grids announced support for pool delivery. So that will make sure that the gap, the differences between Service Bus and Event Grids will be even lower. So in that case, I think Service Bus and Event Grid are both good options. It's still a preview feature, so we'll need to wait a few months for that. My fourth mistake, maybe you can guess already what it is, but let's wait a little bit for that. Let's first go to the use case, and it's about documents that were uploaded, but they had to be processed as soon as possible. So we had to scan those documents to make sure that all the data was valid inside those documents, to make sure that the good customer service was there. So it had to go fast and scalable. That was the solution. So we could choose between polling and webhooks. So with polling, the client interrogates the server, hey, do you have new documents? Do you have new documents? And yeah, you just need to poll every time and you lose resources and you're not always that fast. For this use case, we prefer to go with webhooks. And with a webhook, the client just says, hey, if a new document is uploaded, please let me know. And the server says, okay. And when the document gets uploaded, it will push a message to the client. And so that's faster, and we don't spend that many resources. So in our design, we use that, and we used Event Grid for that, because Event Grid is the webhook system that is natively in Azure. And it has also native support for letting you know that a file got uploaded on blob storage. So a document was uploaded on blob storage that triggered the Event Grid, and based on that trigger, our Logic App fired. So the Logic App did the work and everything worked fine. But sometimes there was a problem with the document that we processed and we had to reprocess it. So what I did, I added an archive folder. That's a good practice that I used often in the past, where we say, okay, when we process a document, we move it in the archive folder on that same storage account. So if you need to reprocess it later on, we can just move it and it gets processed again. But unfortunately, that archive folder was a subfolder of the storage account where Event Grid was triggered, and I didn't have a filter in place. So you see what happens. The problem, we had an endless loop. So my one document that got uploaded got again uploaded and triggered again and again and again. So we had an endless loop, and it costed us quite a bit because it's all serverless technology. So the loop became only bigger, and we only discovered it quite late. So we could solve this by adding just a filter on the event grid to say, dear event grid, only look in the folder and not in the subfolders. And of course, that was a solution, but maybe we also had have another solution for this, because a lot of money was spent. And this mistake was more than 5K that it costed us. So it was quite an expensive mistake. So that's why a second solution, a more proactive solution, is of course that you need to make sure that you have budget alerts. You can have budget alerts on a resource group level or on subscription and even management group level, if I'm not mistaken. So please set these alerts up front. Do a little price calculation on what you expect to be the, let's say, the future cost of your Azure environment. Maybe take a little margin on top of that and just make sure that you get notified. Not too much, so don't put your budget too low. Otherwise, you get every month a notification and you don't look at it anymore. So just make sure that you have a good balance there, because too many notifications, you don't look at that. I also saw in one presentation earlier that there is also peak, so detection for peaks coming in cost management in Azure. So also discovering those peaks would be nice in my scenario here, because of course that endless loop created quite some noise at a short amount of time. So just make sure that you get warned upfront and not 1 month later when you get a bill. And that's a very important one. And then the last mistake I want you to learn from is about monitoring. And that's a very important one. So we had a customer using Azure integration services, mostly Logic Apps, to run their mission critical enterprise integrations. And of course, those are jobs that are running in the background. So you need to have detailed insights in which jobs went fine, which jobs were having issues, so you can maybe intervene if needed. So monitoring and getting detailed insights in the processes was very important. So we needed to have a good solution, so we went for the diagnostic settings. So the diagnostic settings is a default solution that every Azure resource has, so also Azure Logic Apps. And we chosen the option to stream to event hubs because that's a real-time ingestion platform. So we assumed that it would be faster. So all those Logic Apps stream to event hubs, their diagnostic settings. And then we had an Azure function, serverless function, so it could scale to read those events, to maybe do some correlation, to transform them, and to put them in a SQL database. So that was the design. It worked well in a proof of concept, but then we started to scaling the solution, and then we had some problems. The first one was, the setting was forgotten. So every developer had to enable the diagnostic settings, but we always tend to forget those things. So it was only in 60% of the cases that the diagnostic settings were enabled. The second one was that, the throttling started to happen. So the Azure function did quite some work. There was quite some load on the event hub. But of course, the SQL database started to have resource limits, and we need to scale up the SQL database, and then the serverless function throttled again. So actually, Houston, we had quite a scalability problem. So we solved that by not using event hubs, but log analytics. Because in the first place, we used event hubs because we thought it's a real-time platform, so the logs will arrive sooner there. But in the end, there was still a delay of about 1, maximum 2 minutes before the events arrived on that event hub. Because all that logging, all that log analytics, it's an asynchronous process in Azure. So it takes the same amount of time to get your data into event hubs or to get your data into log analytics. So that was the first issue that we solved. The second one is, developers always forgot the diagnostic settings. So we used Azure Policy to enforce to automatically set that setting, so nobody could forget anymore, and the developers could focus on what really matters, and that was making sure that the integrations did their job. And then actually, on top of that, log analytics, we could write our API that was the basis of our monitoring dashboard. So you see, much more out-of-the-box functionality and a much more scalable solution, because log analytics is built on an extremely scalable engine. So that's very nice. If you would use the Event Hubs solution, then I would advise you to ingest it in Azure Data Explorer and build your logging on top of that, because Azure Data Explorer and Log Analytics, it's built on top of the same foundation, and you can query it also with the same language, the custom query language that you also see in Application Insights. So those were my 5 biggest mistakes in the Azure integration space. I hope the main purpose of this session is to make sure that you don't make those mistakes like I did. And as a conclusion, I want to give you 2 takeaways. You've seen that a lot of the issues could have been resolved by having a good governance. So a governance makes sure that you have the foundation set right, that you have those policies in place to make sure that people, even people with good intentions, make mistakes, that they don't ensure that there are security bridges, that the naming convention is not followed, that the availability is not set right. So think about resource consistency, cost management, security and identity, very important. Definitely your identity, because it's often your only security perimeter that you have. Release management, and make sure that everything gets in an automated way into production, and business continuity. And next to that, cloud development is different than developing on premises where everything is on a single machine and everything is connected. Sometimes in the cloud, network will drop, some components will restart. You need to make sure that your code can deal with that. So think about idempotence, think about the read mechanisms, and so on. So if you want to learn more about that, Microsoft has the well-architected framework that can help you with that. So with this, I want to conclude the session. Thanks a lot for attending. Enjoy the rest of the events, and hope to see you later. Bye-bye.
Hey everyone. So I saw that Toon answered some questions on the chat. You're going to continue doing that. So if you have any other questions, please add there. Unfortunately, he was not able to join us today live. We have 3 minutes for the next meeting, so we're going to bring Alex and Adnani at the top of the hour for us to talk about the 365. Since Adnani is around, let's bring him quite quickly just to say hi, like we did with.
Hello, hi Wagner. Can you hear me?
Yes, I can hear you. Okay, so we do like a 3-minute break, and then Alex and you can talk a little bit, and we start the session.
Okay, perfect. Yes,
thanks
perfect.
for joining.
Thank you.
And we're back. So again, thank you very much for joining, Adnani. And anything that you wanted to say before we start the show?
First of all, I'm very pleased to be present with you today at this first edition of Logic Apps Community Day. I would like to thank you and thanks the Microsoft leadership for this new initiative.
Thank you very much.
So I would like to congratulate you and congratulate all the organization team.
Thank you so much. I think it's first time that
yeah.
you're presenting on with us, right?
With Logic App Community Day, yes, this is the first time. So I'm very pleased to be present with you today. Briefly, what we're going to talk today, I'm going to talk about data integration concept with D365 FinOps. So let's discover subjects together.
Probably looking forward to that. So let's start the show. And I know that you're going to be on the chat. If we have time, we bring you back to answer some questions at the live.
Sure, perfect.
Thank you.
Yes, thank you.
See you on the other side.
Hello, everyone. First of all, I'm very pleased and honored to be present with you today at this first edition of Logic Apps Community Day, which is organized by Microsoft. I'm super excited to be present with you today. I'm going to talk about a subject that I found always interesting, which is related to data integration in D365 FinOps with Azure Logic Apps. For those who don't know what is exactly Azure Logic App, it's like Power Automate, but we're not talking about the same products, but they have the same objective. It can help you to automate tasks, automate flows, and synchronize data between different systems. I will start first by talking a little bit about data integration concept, because as we say always data integration, but do we really know what is exactly data integration concept? So I will talk a little bit about this concept, and after that I will show you how we can integrate data in D365 via using Azure Logic App. But first, let me introduce myself. My name is Adnan Dali. I'm a D365 FinOps technical architect. I'm working with Agile Consulting. We are one of the gold partners based in Paris. We are a cloud expert and D365 deployment expert as well. We are based in Paris. I have, during my experience, I had the opportunity to work on different international projects between Europe and Africa as well. I'm super excited about everything related to enterprise architectures, multi-cloud, Microsoft, and even other technological stacks. Also, I'm a blogger, so I have a blog, theinvision365.com, so don't hesitate to visit my blog. Sometimes I'm sharing some nice articles about data integration subjects with D365 FinOps and other tools as well. In parallel of my job as a technical architect, I'm preparing my PhD, so on big data management and smart cities application. And so yeah, this is my first time being with you here in this version of Azure Logic App Aviators Day. So yeah. The agenda for today, we're going to start by a quick introduction about Azure Logic, about our data integration concept. Because we say always data integration, but in this slide, I will show you why it matters, why it's important to have a data integration strategy at the enterprise level, and how we can achieve a successful data integration scenario in D365. After that, I will start give a quick introduction about Azure Logic App and why we have to consider it as a real data integration tool, as a strategic lever at the enterprise level. After that, I will show you some data integration capabilities of Azure Logic App and how you can integrate data in D365 FinOps via using Azure Logic App. And I will show with you some use cases if you are maybe you are using or facing one of those scenarios in D365 FinOps. So don't hesitate to use Azure Logic App. It can help you to achieve this kind of scenario to integrate and exchange data with FinOps and any other systems. After that, I will end my presentation with a quick technical demonstration. I will show you how we can build a data integration flow scenario for D365 FinOps. I will show you how we can export expenses data from D365 FinOps into an Azure Blob storage via using Azure Logic App. And finally, we will conclude by some key benefits on some best practices and quick recommendations that you have to respect if you are working on a data integration scenario with D365 FinOps. So data integration, let me start by this slide by a quick statistic that I found really, really important. There is a study that have been released last year's talking about data integration tools. This study have been realized by McKinsey & Co. And they say that the companies that have a data integration strategy deployed inside their information system in their company, the study says that those companies who have developed also this cultural shift, this awareness inside their company, they say that those companies are 64% more efficient than any other companies who don't have this, who don't have a data integration strategy deployed inside their company. So why I'm sharing with you this statistic, because it's really important to show why it's matter really to have this cultural shift, this data integration awareness inside our companies. So the first point, data integration equals unified financial data, especially when we talk about D365 FinOps, which is considered as a hub of financial data, when and especially when we say FinOps, when the data is playing here a crucial role, a major role to define the progress of our information system. The second point, why we are taking those, why we need those information, because in my opinion, the ERP is not an isolated tool. It's a tool that making part of a whole framework of data, and it's the ERP have to share with data in a daily manner with different systems such as sales, procurement. Data are coming from various sources. So why we are taking, where we have to store this data to, one main goal is to take strategic decisions. So that's why it's very, very important to have an automated flows that can help us to exchange data in a daily manner between D365 FinOps and any other different system. The third point, we are facing a huge market opportunity. There is a study that have been realized by Throttling that expects the market of data integration tools expected to reach $90 billion in 2026 and about $40 billion in less than 10 hours. So this really shows why it is important to have this cultural shift inside our company to develop a data integration strategy, and also show that all big IT companies with Microsoft as well, they continue introducing and make our life more easy to integrate data and exchange with different systems by introducing, for example, Microsoft Copilot, more artificial intelligence tool in the 365 products. So all these points make us convinced to choose Azure Logic App as a real data integration tool, as a strategic level and enterprise level, which is a full cloud tool, an integration service, fully hosted in cloud, in Azure cloud. For me, the strong point of Azure Logic App, it's extensive connectors. Here we are talking about more than 800 data connectors pre-built in the tools. You don't need to install any add-ons, so everything is included in the system. Also, it's very another strong point, which is it's offering a rich visual designer. It's like Power Automate. Easy to use, a user-friendly interface, so you can easily start creating your data flow, drag and drop actions, design your data flow easily. Another important point is version control, because as his name indicates, so Azure Logic App, so Azure Logic App is making part of the whole Azure services, so you can create an Azure DevOps pipelines, release pipelines to build your Azure Logic App and deploy it into different Azure subscriptions or even different Azure tenants. The good thing also with Azure Logic App, Microsoft actually is offering this Azure Logic App via 2 model, so you can create consumption Azure Logic Apps or standard Logic App to ensure maximum of flexibility and features. For example, if you need more features, advanced features, prioritize to use Azure Logic App Standard. And in like the power of data integration, this is very important. And personally, I'm using Azure Logic App for data migration project. For example, as you know, in D365 FinOps, we need to export data, expenses data, data entities. So Azure Logic App can help you to achieve this kind of scenario and achieve real-time data integration and synchronization between different systems. A new announcement, Microsoft has added a new tool. As you know, Azure Logic App is designed to automate actions, the data flows, but Microsoft have introduced a new tool, which is still in preview. Azure Logic App new data mapper tool. If you are working, for example, we want to exchange the source of your data. If you have, for example, source file as an XML and you want the target file to be another different format, so you can use data mapper to create data transform data mapping tool in your data integration scenarios. So data integration capabilities, as you know, in D365 FinOps, Microsoft have created recently, I think about 2 years now, or 3 years, have introduced the business events. So for those who don't know what is business events, it's like business actions that happen inside D365 FinOps, and you can call them externally from third-party applications as Logic App or any other external application. The good thing that you can use those business events in Azure Logic App. In Azure Logic App, you have a dedicated data connector pre-built in the tool, so you can use it. You really don't need to any extra setup. So you can just drag and drop it and use it via, and it supports auto authentication to connect directly to all your D365 instance. This data connector can be used as a business event if you are, for example, approved a new, for example, created a new payment journal and approved this journal. So you can create a Logic App that can be triggered just after a business event occurred in the system, triggered in the system. Or you can use it as an action, if you want to execute, for example, or to call an API action. It supports also CRUD, create, update, delete actions. For the use cases for D365 FinOps, as you know, Microsoft have introduced business events. The good thing is all these business events exist on all D365 modules. You can find us in sales, purchase, vendor, customer. So you can call those business events in your Azure Logic App. It supports create, update, delete operations. Just one point is this list is not really a final list. It's just not exhaustive list. This is just kind of sharing with you some most frequently scenarios that you can some use cases that you can use if you are working on Azure Logic App. Import data and export data, those are one of the most common used data integration scenarios. Because as you know, FinOps is we need to continue to share data with sales or any procurement tool. So we can achieve this kind of scenario in D365 FinOps to import and export our data entities. Just after this slide, I will show you how we can export expenses data entity from D365 into Azure Blob Storage via using Azure Logic App. Azure Logic App, for example, can help you to achieve the scenario of data synchronization between D365 and any other systems. For example, if you are working on a scenario that you have, for example, D365 FinOps, and you have, I don't know, Salesforce or any other different technological tool, and you want to exchange or synchronize data between these two systems. So Azure Logic App is there for you and can help you to achieve this kind of scenarios. So let's go for a quick technical demonstration. I will show you. So the demonstration, it will be about how we can export data entities from D365 into blob storage via using Azure Logic App. The first thing that you have to start with is you have to create a data import in your D365 environments. Let me just share with you the data import that I've created here in data imports project. Okay. Data management. So here I've created a data export project. So it's classical task. You can create. You have to start by creating a data export project. Here in my project your project have to support generating data package. So you have to check this this option. And here I'm trying to export. I'm exporting expenses data. And the source of my data, or the final result of my export, is going to be an CSV file. So it's a classical step that you have to start with. So here I'm creating my export project. So now here I will back to my Azure Logic App. As you know, Azure Logic App, there is two type of actions. The first one, which is trigger events. This is the first step that can trigger your data flow, your workflow. So here I'm using a recurrence, so that I want, for example, that my data flow going to be executed 1 time per day. After that, here I'm trying initializing a new variable because, as you know, the goal of this scenario is to call an import. To call an export data project, but when we start an export or an import, there is a data job batch behind, and this data batch have an execution ID. So here I'm creating, initializing a new variable, DMF execution ID, and giving this variable an automated generated value. So here I'm affecting this value into this variable. Just after that, I'm exporting my data package. Sorry, my data package. I'm calling my, I'm using here the D365 FinOps data management definition group API, and using export to package API. This option is taking this two information. You have to call your data export project. This is the name of my export project, and execution ID, which contain the value of ID that I've initialized here. After that, I'm making a condition. So when the result of the output of this action is going to be an ID, and here I'm checking if this ID have been initialized or not. So after that, I'm checking if it is true. That's what I want. That the value have been initialized and the data job have been created with the ID that they have assigned it to the DMF execution ID. And here I'm starting. I will start. The result of this step is getting me is to get an export package URL. And after that, I will download this package URL here via HTTP GET method. And the output of this method is going to be a zip file. And here I'm creating the zip file. I'm creating the zip file in my Azure blob storage with the contents of my the contents of my blob is going to be the output of the HTTP action. And after that, I'm sending an email. Hello, the expense export have been succeeded or not. So I can run the trigger, and the result of this trigger is going to be an email, succeeded or not succeeded. It's going to take a little bit, some few minutes, but we can continue the slide. The result is going to be an email like this. So I've already prepared this for you. I'm going to receive an email like this. It's expense export have been succeeded. Okay, so that was a quick technical demonstration. Let's go back to our slide. Some key benefits that you have to consider if you are using Azure Logic App as a data integration tool with D365 FinOps. For me, the strong point is seamless integration with D365 FinOps, because really you don't need any to install any add-on on extra add-on in your Azure Logic App to use the data integration. The D365 data connector in your Azure Logic App. It's fully integrated with the tool, pre-built in the tool. It supports. It can be used as a trigger event or data or an action in your Azure Logic App. Another, for me, I repeat it again, the strong point is extensive data connectors. We can use Azure Logic App for a data migration project. If you are, for example, want to migrate data from an on-premise, for example, EX 2012 system, and you want to migrate data into D365, so you can use Azure Logic App in this kind of scenarios. Synchronize data between CRM, for example, or customer engagements, or D365 FinOps. So really it's designed for this kind of scenario. Business events as well. So it's connected to all D365 FinOps business events. Microsoft is continuing improving, adding new business event. This is very important. Another good important point is scalability. So Microsoft is offering Azure Logic App via two different models, consumption or standard. If you want, for example, if your scenario, you are having, for example, big data scenarios, and you want to exchange data with different technological stacks, different tools. So Azure Logic App is here for you and support this kind of scenarios. The last slide, some key best practices. For example, if you are working on a data integration scenario with D365 with FinOps, with Azure Logic App, the first point or the first recommendation is try to give more time to understand your data model requirements, because I think most of clients think directly about the technological tool, the technological challenges, which I think it's normal. But for me, the most important thing is try to understand your data model, try to understand and give more time to know about what is your data source and data target. Try to search, for example, if there is any standard data entity exists in D365 FinOps before using a custom one. Things that you have to respect when you are trying to import or export via using data entities in FinOps, that you have to respect the data format, the source data format have to respect the target format. You have to have validated data, the same type, the same mapped data, so you don't have to map, for example, I don't know, field A with field B. So if you are not really respecting those things, you're gonna receive an error if you are while exporting or importing data in Azure Logic App. So this is very, very important. The second point, try to think about data frequency, because here we are talking about pay-as-you-go as Logic App. So you pay only the executed actions that you have already in your Azure Logic App. Think about data frequency, because you have to choose the correct event trigger of your data flow. Try to ask questions with your clients if you need a business event, if you need a manual trigger event, if you need which type of event trigger you want to implement in your Azure Logic App. The third point, implement CI/CD. This is very important, and one of the best practices is try to create different type of Azure Logic App. Well, as any D365 development, we have three types, for example, of environments: dev, test, and production. Try to do the same thing with your Azure Logic App. Create three types of Azure Logic App. Each type is hosted in different Azure resource group, and after that, it's going to be easy to you to later to have an idea about the cost and if you want, for example, to deploy your Azure Logic App, it's going to be more easy to deploy it in a different type of environment. So don't hesitate to create build pipelines, release pipelines to deploy your IRM templates behind your Azure Logic App. The last point, prioritize standard Logic Apps. For example, if you have a scenario you want to connect with on-premise systems, so try to use Azure Logic App. It's standard Azure Logic App, which offer more features, advanced features. If you want, for example, to communicate with bank server files, and we know that, for example, this kind of systems are secured, and in this case, it's recommended to create or to use standard Logic App, which give you the opportunity to create and to have, for example, a private IP addresses. And after that, the IT bank team can whitelist those addresses and exchange data in a secure manner. This is just an example of many other features that Azure Logic App Standard can give you the opportunity to achieve. It's designed also to handle higher volume of data and transactions with more advanced capabilities. So thank you for your attention. If you have any questions, so don't hesitate to ask me, and we will be more happy to answer your questions. Thank you.
And we're back.
Yes.
So I think first thing is, seems like people find it quite interesting, right? I think Synapse and thank you. It's very interesting overall. And she has a question which I'm not sure if it's specific for you or for Logic Apps in general. So I'll just add here, you can try to answer from the 365 point of view, or try to answer from the other side. She was asking, like, which schemas format was supported for my Logic Apps. There is anything specific for the 365 and FinOps in that?
Yeah, I thank you for your question. I think it's Zainab who asked this question. Well, to import data in D365, really we don't have any to use Azure Logic App. All data type are supported, so XML, CSV. So there is no restriction in terms of importing type of data or any type or other. But I don't know if she's asking about mapping on transformation data. So I think now Microsoft has released the new tool, Azure Logic App Data Mapper, to support mapping and transformation scenarios. So I think this is a good news, and yes. But to answer your question, all type of data are supported in export or import in D365.
Yeah, and from a Logic Apps point of view, we have native support from JSON, but we also support the other formats like the CSV, XML, binaries can be passed to the Logic Apps, and we treat that as a process. We have some functionality to allow you to convert, for example, XML or CSV into the JSON that is in native format if you wanted the token pickers. But in summary, we should be able to process any kind of message. Okay. There is another question here from Graham. Should Service Bus be the normal backbone for Logic Apps design in a space of complex triggers and events organically developing a business? What's your opinion on that one?
Well, it's really depend on which type of scenario, which type of because I totally agree. There is a lot of tools that we can use. There is Service Bus. There is event trigger. There is a lot of tools that we can use that are considered as data integration tools. But to answer your question, it's really depend on which type of scenario you guys using, because before start designing any data integration scenarios with all clients, I'm always asking three types of questions. The data frequency. So this is the first question that we have to ask, because there is some tools that support a huge amount of data. Some tools are not. For example, you can't use OData, for example, if you are, I don't know, if you have big data integration scenario. So there is some specific tools we can use. So data frequency, data volume as well. So you have to ask your clients the volume, to understand the volume of data that he wants to export or import. And another point is understand also the data model. So because understand the data, the source data format and the target data format. And I think those type of questions can help you to choose the right tool, because if you, for example, in your scenario, you want to do some transformation, so you have to use, for example, I don't know, Azure Data Factory with Azure Logic App before pushing them into Azure Logic App, so you have to do some transformation or not. So it's, to answer your question, Graham, it's really dependent on which scenario you have to use. It's
seems like an architect answer, but I think is the right answer on this thing. And it's interesting that you touching some points like the data volumes, the frequency, and things like that, because that is the perfect segue for our friend Dan Probert that I'm just going to add to the stream now. That is going to be talking a little bit about the throttling patterns, and I think you're going to be touching on some of those items. So just before talking a little bit with Dan, I would like to thank you so much, Danny, for joining us, and thanks for that session.
Thank you. Bye-bye.
See you later. Hello, Dan.
Hey, Wagner, how are you?
Good, man. So I think it's like lots of people is waiting for that session from you talking about throttling patterns. Can you you introduce yourself on the video? Because I know that
yes.
session is a large one.
Yes, so it's a recorded one, but I'll be here to answer questions as we go. And the one thing I would say is throttling is a massive subject, and we have limited time, so we were only able to cover a small amount, and I'd love to do more sessions on it.
Top of the iceberg. Wow, you can come back on some other community stand-ups. With that in mind, let's start the recording. And again, if anyone have any questions, drop it on the chat that you'll try to answer that while the stream is running.
Hi everyone, and welcome to another Logic Apps Aviators Day session. My name is Dan Probert, and I am the CTO of Aptness Limited, a company based in the UK. We specialize in Azure Integration Services solutions and have been doing so for many, many years. Today's exciting topic is throttling patterns. Specifically, how do we handle thousands of concurrent requests in Logic Apps? So let's get going. I wanted to start off just talking a little bit about what throttling is. I assume that most people will understand this, but throttling is the practice of artificially reducing the number of transactions that we're processing over a given period of time. So we do that because we're trying to stop some sort of a limit being reached or overrun. The reason we will do throttling or implement throttling is to prevent overload. For example, if we have too many requests being processed, we might find that the system's unable to take on any more requests or even process the requests it's got. Or if you're in a situation where you have multiple tenants with lots of consumers, you don't want one consumer sending so many requests that it prevents other consumers from being able to use the service as well. That might be more apparent, say, in a shared cloud service. So let's say I'm using Dynamics 365, and I'm using a Logic app to connect to it. There's going to be some sort of rate limiting on or throttling put on to prevent me consuming all the resources for Dynamics and therefore preventing other people from accessing Dynamics as well. The types of limits that we might introduce or might find could be things like the maximum number of messages that are in memory at any one time, or maybe the number of connections we have over a protocol. So over HTTP, how many requests can we have to a given resource over a given period? There's also limitations on, say, the hardware or the software that we're running on. Logic Apps, for example, is running on virtual machines. So there might be a limit in terms of the amount of memory that's available or CPU power that's available at any given time. So we might want to throttle to make sure that we're not exceeding our limits. I'm going to use sort of trampolines as a metaphor here, but imagine you've got a trampoline and you've got a queue of adults trying to get onto that trampoline. I did start this using children, and I thought that's just going to go weird if children are jumping off the trampoline suddenly. But if the trampoline can hold 5 adults safely, and each adult is allowed 10 minutes on the trampoline, and then they have to get off, we have a limit of 5 adults every 10 minutes, which is another way of saying 30 adults an hour. So that's our limit. We have a limit of 30 adults per hour. Otherwise, we're exceeding the limits of we're exceeding the maximum number of adults that we can have safely on that trampoline. But what happens if adults are slow to get off? If we don't start throttling the way adults are getting on and have someone saying, right, we've got 5 adults on the trampoline, you can't have another one getting on until someone's got off. If we don't do that, then we'll get a 6th adult on the trampoline, 7th, 8th, 9th. And we could end up with 15 adults suddenly on this trampoline, and the trampoline could break. And that's why we have throttling. Throttling is to try and prevent a situation where we break a system. And it's really, really important in the cloud, because the cloud is all about maximum scalability. With the cloud, we don't have to think about the VMs we're running on or the CPUs or anything like that. The idea is it scales up for us. If you've come from a background of Logic Apps consumption, you know that as a Logic App receives more and more requests, more instances of that Logic App will be spun up to handle those requests. So as a developer, you don't have to think about the infrastructure that's going on behind that. It's kind of magic. Microsoft look after it for you. You obviously pay for the number of Logic Apps that are running. But when we start talking about Logic Apps Standard, which is what we'll be focusing on today, there are limits, because now you're running in a VM. It's a single tenant. So all your workflows run on a VM, and the size of that VM is dictated by your app service plan. So once you start hitting those limits, things will slow down. You'll start getting exceptions or retries or something like that. So you need some way of controlling how many messages are getting into your workflows at any given time. There are multiple ways of throttling inside AIS. And I'm not going to cover all of those today. I want to talk about a particular scenario you might come across and a couple of ways to solve that. But one of the first ways is controlling the number of messages that are coming into your workflow. So the size of your batch, for example, and there are lots of ways we can look at doing that. So if I've got 50 messages coming in, then I can choose to use the split on command in my trigger. And if I do that, I'll get 50 separate workflow instances running to process it. And that might exceed my limit. If each of those is calling a third-party service and it can't have more than 50 concurrent requests, then that's not going to work. What I could do then is take that batch of 50 and use 4 each, and then put concurrency limits on 4 each and say I only want 25 of those processing at a time. So that's the other way you can do it. You can control the number of messages you're processing in that batch. There's another thing to talk about, and some of you may have hit this, which is if you are hitting a system downstream and you're sending too many messages, ideally that system should send you back an HTTP 429 status code, which means too many requests. So it's basically saying you've sent me too many requests and I'd like you to retry them. And when the Logic Apps execution engine gets a 429, it implements its retry pattern. So if you've got a retry policy turned on, it will automatically start retrying that request in the hope that subsequent requests will succeed. But it does it the certain number of times that you've got in your retry policy and then gives up. There's another way we can manage throttling, and that's move the messages off your input stream and then batch select them from somewhere else. And that's kind of what we're going to be looking at today. It'll make more sense when we get to the demo. Don't worry, I won't keep talking for too long. This session today is all about demos. So let's look at an example of where we might overload AIS. And I've done this multiple times by accident, and it always happens with Service Bus. But imagine we have so we have a workflow using the Service Bus connector, built-in or managed, doesn't matter, but for our case, let's assume built-in. And we want to write each message to a table. Now that could be a storage table, SQL table, doesn't matter. But if we've only got 5 messages in it, and that workflow is set to use split on, what will happen is when we enable the workflow, it will connect to Service Bus and it will select all 5 messages, and it will spin up a separate workflow instance for each of those 5 messages. So what that means is we have 5 concurrent instances running at the same time. That's fine, we're not at risk of overloading anything. But what if we've got 1,000 messages in our Service Bus topic? What the Service Bus connector will actually do is it will spin up 1,000 separate instances of that workflow and try and process them all concurrently. And if your downstream system can't handle 1,000 concurrent instances, you'll start getting errors. And if your downstream system is using 49 errors to request throttling, then you'll start getting retries all over the place. And I want to give an example of this. So let's look at a sample setup I've got in Azure Integration Services and look at what happens. So we've got a Service Bus topic I've created to hold our messages. I've got an Azure storage table, which is representing our downstream system. I've got an API management instance with a policy that we can call from our workflow that will write to the Azure storage table. And then I've got a Logic app with a workflow in it. So what will happen is our workflow will subscribe to the Service Bus topic, and we're using split on, so we'll get a separate workflow instance for every message. And each of those workflow instances will call APIM, and that APIM instance or APIM call will write to the storage table inside the policy. Right, let's go and have a look at this in the browser. So first of all, I'll show what we've got here. We've got an employees topic, and this is as simple as possible. So if I come down here, I've got a single subscription, and I've just got the default filter on there. And you can see there's no messages in our subscription at the moment. Okay. I've set up Azure Storage, a table storage in Azure Storage called employees, with a partition, a row key, and it's got some other properties on it as well that you'll see as soon as we start getting data in there. I've created a API management instance, and I've created a single API in here, the employee API, and it has one operation, upsert employee. And I can take you through what this does, but if I can expand it, I'm in the wrong place actually. Let's come back out again. And from here, right, there we go. That's what I want. This policy here, what that is doing is it is writing directly to the table. So it takes whatever we pass in, it pulls out some values from the JSON data, and it's writing directly to that storage table. And it's got a bit of error handling going on down here as well. And then I have a number of Logic Apps. I've got one Logic App which is going to populate Service Bus. So I call that and say how many messages I want. And again, that is very simple. It's got some surnames and first names, and it's going to use a for each using debatching and concurrency to write to the Service Bus topic. And then separately, I've got one using split on. So this will subscribe. It's very, very simple. So all it's going to do is it is going to subscribe to a message and a topic, and it is going to make a call to API management. You'll notice I'm not using the brand new API management action just yet. I'm using the HTTP action. I had a problem using the new APIM action. But I'm not using peak lock. This is autocomplete. So it reads the message off the queue. It also has split on turned on as well. And split on means that if there are 15 messages available, I'll get 15 instances of this Logic app spun up. I don't have any other control over sizing or anything like that from this. Okay, this Logic app is currently disabled. And what we're going to do is we're going to kick off the populate Logic app here, and we're going to test it by just doing 5. So this is going to create 5 entries in Service Bus, and it's done. And now if we come back to Service Bus and refresh, we should see, there we go, 5 messages. Now, if I come back to my subscribe and send here, and I run it, or enable it, in a second, so these are from earlier today, but if I refresh this, we should get a number of entries pop up. So we'll get 1 entry for each of the messages that have arrived. And we'll start seeing those appearing here. Now, one thing I've noticed with the Service Bus trigger, it doesn't immediately start running. So what is going on here? There we go. So we have 5 entries that have just run. or five entries in the run history. And if we come back over here, we should see, there we go, here are our 5 employees. So the test data, the populate service bus is just generating test data here for us. So it's giving it a random role and then a unique ID for that. And then we've actually got an employee message here with a made up name and everything else like that in it. So cool. All right, so 5, and that went through without any problems. Now, what happens if we do 1,000? Well, let's have a look. Let's send 1,000 through. Now, remember, there's no rate limiting on at the moment. So API management should accept 1,000 concurrent requests. But I'm running my Logic app in an app service plan with nothing else in there, but it's a WS1, which means single core. And I think it's 2 or 4 meg of RAM, maybe 3 meg of RAM. It's not a lot anyway. So let's do 1,000. And it's going to start doing that. And what I want to do while this is happening is I'm actually going to disable this so that the messages build up in Service Bus. But you can see it's already starting to run. And what we'll see, there we go. I didn't disable it fast enough, so it's gone through and it's actually processed almost all of them. And what you'll see here is that the portal locks up. In fact, I can't really get much out of this workflow. If I come back again, I'll come back to run history. And that's because it's doing a lot at the same time. So here we go. It's now executed, hopefully, everything. I've got 40 runs there. I can come down and see more. None of them have taken very long. And if I come back to my storage here and refresh, I should see 382 items. Where are all the rest, you ask? Well, that's a really good question because I don't have 1,000 items. I should have 1,000 items in here. And what's going on is I'm overloading Logic Apps. I'm overloading the total number of workflows that can run in parallel. And I can see that because I can turn on rate limiting in API management and see what starts happening. But at the moment, here, with all these that are running, if we go back to our subscription here, we'll see that there's still only 11 messages left. So the other 889, where have they gone? We could try this again. I've disabled this. Let's run this again and see what happens. So I'm going to send 1,000 messages, and now we should end up with 1,011 sitting in our Service Bus queue. And in fact, as we come back to here and start refreshing, we should see the count going up. Now, I've got to say, I came across this problem with a client who asked us to stop processing. So disable the Logic app that is subscribing to Service Bus. And in the meantime, things are queuing up in Service Bus. And we had thousands of messages in there, 70, 80,000. And when I turned on, when I enabled the workflow, it spun up, well, it tried to spin up about 70 or 80,000. There is actually a limit. I think it's something like 5,000 workflow instances all at the same time, which was not what I wanted, because that then completely bogged down that workflow and that Logic app, and it adversely affected the app service plan and therefore all other Logic apps that were running in there as well. All right, so now we've got 1,011 messages there. Let's turn this on and watch what happens. All right, it's on. We currently have let's delete all these. Shall we delete all these? No, let's not delete all them. Could do. But if I refresh that, let's see what it's doing. It's still only got 382 on here. I'm just going to delete those 382 and we'll see how many we get. We're expecting 1,011 if everything's working. All right, so we've got more coming in. We've got 41 so far, 84. So it's building up. You can see it's running. And if we come back here, we'll see it is processing, but it's actually running a lot of Logic apps all at the same time. It's spun one up for every single message it's found in the topic, which at the moment is 1,011. So all of these are running at the same time. And because we have so many of these running, it means the overall runtime for all of them takes longer. So you can see the times here. We've got them running at 11 seconds, 13 seconds, whereas they really should be around about the 1 second mark for a stateful logic app. That's because we've got so many running in parallel. Did any fail? Let's go and have a look. And we're looking for ones that failed. And none today. So these are the ones that from testing I was doing. So far, they've all succeeded, which is great. We'll turn that off. Okay, let's come back over here and refresh this again. First 100 items, we've got 1,005 items. Brilliant. So we're 6 down, and it could be that those are still processing and still on their way. And if we come back here to running, we might see, nope, nothing's in a state of running. And how about waiting? Nothing's waiting. Alrighty. Okay, so I've only got 1,005 items. So I'm missing 6 of the items that I would expect to have. That's not too much of an issue for us, because one of the things I neglected to mention is that when I start a run again, I'm overwriting the row key. So 5 of those entries are already written in here, so they've become an upsert as opposed to an add. So we've actually got all of our 1,010, 1,011, if you start at 0, items in our table. Brilliant. Okay. Now what I want to do is I want to artificially show what happens when we introduce throttling. So what I'm going to do is I'm going to come back to API management, and I'm going to add a policy element which will start throttling when we hit, say, 100 requests every minute. And we can do that. We're going to all operations here, and I can go to policies. And I've already got it in here. I just happen to have commented out to make it easier for this demo. But this is the, give me a second just to move this over so we can see it properly. This is a policy element that says I would like to restrict or limit the calls to my, well, in this case, all operations. And I'm saying here that what I want to do is I want to rate limit it by key. I want to limit it to 100 calls every 60 seconds, renewal period of seconds. And I'm going to do it by IP address. So my IP address will be limited to 100 calls per second. Because this is being called by a Logic App, it's any workflow in that Logic App that shares the same IP address. I only want to count ones that are ACP 200. So if I get a 500 or 400 error, don't include those in the counting. Yeah. So that's all I need to do. And if I save that, that has implemented that policy. Now, if I do 1,000 again, what we should see is, I'm just going to remember to disable this. Excellent. And then we will generate 1,000. And we'll come back here, and we are waiting for those messages to start appearing. So there's not many yet. It should be, okay, sending the request to generate another 1,000 messages. And we'll see this start to go up, I hope. In a moment, something's going on. What's happening? Okay, so the workflow failed. Let's try it again. I don't know why it failed. Okay, so we're going to call that workflow and generate 1,000 requests. And hopefully we will see them in here. Here they come. So gradually this will go up to 1,000. And what we're going to do is we're going to turn on the workflow that subscribes and writes out to APIM, but this time we're going to get some throttling. So every time we hit 100 requests, we'll end up in a retry. Now that workflow is just using default options. I haven't changed anything. So this here, the retry on it here is the default. Oh, networking, here it is here. Retry policy is default, which is exponential. I think it's 3, something like exponential intervals. I think it's 3 retries with like a minute between or something like that. I can't remember the exact options for it. But if we enable this now, because we should be up to 1,009 messages. So now if we enable this and watch what happens, because what will happen is we'll probably get the first 100 running, and then we'll start getting rate limits. So we'll start getting 429 sent back, which will mean those workflows will go into a retry, and they'll keep retrying. But everything's running all at the same time. So we're kind of going to be consuming a lot of Logic App resources while we wait. So the entire run will take quite some time to finish. If I come back to here and refresh here, this was when we had the earlier items in. So let's delete those. Okay, brilliant. All right, it's already sticking some in. So that's the first 100, 104 items. So right now it is running through and trying to process all those. And if we refresh in here, we should start seeing lots running. And we should see a whole lot here in a status of running. And if we come down and look into them, we'll see too many requests. So it's retrying at the moment, and it will keep retrying until it hits that 3 retries and then stop. It'll give up. Now this is something really important. We've done an autocomplete. So we've pulled the message off the topic, and it's now in our care. So if this times out, because it can't call it, we've lost the message. Well, we've got it in the run history, but we haven't done anything with it. Just something to remember if you're using Service Bus topics or queues. Be very careful about whether you're using peak lock or autocomplete. Peak lock doesn't necessarily solve the problem either, because peak lock has a maximum timeout of 5 minutes. So if you pull something off Service Bus and your processing takes more than 5 minutes because it's retrying or something, it will be made available back to that queue or topic again, and you run the risk of duplicates, depending on whether this eventually goes through. So right now, what's going on is we have a lot of entries all running at the same time, yeah? And they're going to be running for some time. So what we will see as these start to complete is the amount of time taken to complete each individual workflow goes higher and higher and higher. And some will start timing out. So we're looking at a minute at the moment for some of these. So that's because it's going through and doing a retry. And your hope is that eventually they will succeed. And I think a lot of developers rely upon this default retry without thinking about it and just hope that in a high load situation they will get through. But that's not always the case. If what was calling your workflow is, say, an HTTP action, it has a timeout on it. Maybe it's 2 minutes, and now suddenly the caller has timed out, and maybe it resubmits the message again. It's a lot of complexity in here in terms of how we handle these scenarios. But at the moment, we're waiting a long time, not 2 minutes now, for this one to run before it completed. And if we come back here and see how it's getting on, where are we up to? 306 items. So it's taking quite a while to do all of them. And what I've discovered with my testing is it never gets to 1,000. We never complete it all. We don't end up with all 1,000 items. If you were a bank and each of these messages is a transaction, you'd be rather unhappy if you'd lost some of these messages just because there's load going on. What this means is that throttling is vitally important, and we really have to think about the systems we're calling and how many messages we can process and how we control the number of messages we're processing at any given time. So one of the solutions that I want to show, and this is just an example of how you could solve the problem. I'm aware of time at the moment. If I come back to here, one of the things we can do is change what we're doing. So instead of going from Service Bus to a workflow directly to APIM, we can go out to SQL. It doesn't have to be SQL, but I've chosen SQL for a very good reason. And then we can go from SQL to workflow out to APIM. So we're offloading things into SQL. Now let's give an example of this working. I need to come back to here, and I need to disable this workflow, and I'm going to create a new workflow. And righty, so I want a new workflow, and this workflow is going to be something that's going to subscribe to messages, and it is going to be, so Service Bus subscribe, and then it's going to write to DB. Yeah, and stateful's fine for this. Okay, so it's going to write to DB. So first thing I'm going to do is I am going to disable this workflow because I don't want it running straight away. And I already have the code. Paste it in, save that. And all it's going to do is, if we look in the designer, it's going to subscribe to messages, and then it's going to write them out to SQL. I think I hit the designer too soon before it had finished compiling. There we go. So when the message is available, it's going to call a stored procedure. And that stored procedure is just going to insert the data into SQL Server. Brilliant. So I'm going to enable this. And I'm going to kick off my workflow and do another 1,000 messages. And what we should see is things should start appearing in SQL. In the meantime, we only ended up with 511 items here. Now, if we go back and look in here, we'll see 0 messages inside here. So we've consumed all those messages, but we only wrote just over 500. So the other 480 odd have disappeared. Where did they end up going? Good question. All right, so this has failed. I often see this when Logic Apps is busy. So it's really busy working on something. I'll get an error, but I'm just going to try again. And we should start seeing the numbers here going up. Here we go. Now you'll see them going down again because I've enabled this SB subscribe and write. So it's currently going through and receiving them and processing them. There we go, see it's running. And I come out to SQL, and if we have a look at what we've done in SQL, we have got an employees database, and we've got a table called employees. And in there, I'm just storing a unique ID and a control status. Yeah. So as I write these out here, you'll see that they have a control status of new. I've got the actual message and a tracking ID. And it's the control status that helps me control what I'm doing with them. So these haven't been processed yet. And I can tell that because it says new. But this is the actual message we want to process. Brilliant. So now we're logging all these out, and we've got 911 rows, and we should end up with 1,000 rows. There we go. So everything has been logged into SQL. Now all I need is a way of getting them out of SQL and back into API management. And I can do that by having another Logic app. And this one's going to be database subscribe, call APIM, stateful. And again, I'm going to paste this in. Now, what this is really doing is it's just calling a stored procedure. And that's where the power of what we're doing is. We're writing all our rows from Service Bus into SQL, and then we're calling a stored procedure. And that stored procedure is saying, get me a batch of these messages. And it's saying, get me, I don't know, 50 of these messages. And it sets the control status to processing as it does so. As it selects them, it sets the control status to processing. And we know those are the ones we're doing. So, and then when those have finished, it will go again and say, get me another set of 50 that aren't in a state of processing. One of the advantages we have here over, say, doing it throttling via Service Bus is I can use SQL to control which messages I select. So I could say, only select one clerical record at a time in my SQL procedure. So it will say, if there's any other clerical records that have a control status of processing, it won't select them. So it's quite powerful what you can do here. You can do this with Service Bus as well using sessions, but you hit the same problem that the Logic App connector for Service Bus will try and drain the queue or try and get everything out of it because that's what it's trying to do. But in our case, we just want to throttle. So I can add in another Logic App here, another workflow here. And what I'm going to say with this one is this I'm running just for this demo. It's running on a recurrence trigger. So every 15 seconds it will run, and it will call my batch store procedure to say, get me a batch of messages. And then it will select the message. Because what this is doing is it's like a claim check pattern. It's giving me just the ID of the messages to process, and it's looping through those IDs. And this is happening concurrently. And so this is saying, get the message from SQL, and then call APIM, and then update the message in SQL. So if I enable this workflow, what I should see is it will start doing about 50 of them at a time. Now, I've already enabled it because I forgot to disable it when I saved it. So it's running at the moment. So it's looping through. So if we come back to our database here, we should start seeing that some of these messages will be in a state of processing. I'll probably see them down towards the bottom. Here we go. They're completing as they run through. And these ones with processing are currently running. And if I look at the store procedure that I have, which is here, the DQ store procedure, I have some defaults in there, and I say basically select 50 at a time. So every 15 seconds or so, whatever the recurrence trigger is, it's going to get another 50. But there's a high watermark. So it's saying that once I'm processing 80, don't get any more. So that's a maximum I'm allowed to be processing at any given time. So it will wait till that drops down below 50 and then get another X number to take it up to this number again. So let's say, for example, I hit 80. It will wait till it gets to 30 before it selects another 50 again. So it's got a low watermark as well, which is this minus this. And this is quite powerful. It's something that is hard to do with Service Bus when you're using Logic Apps. You can do it if you're writing your own service processes for Service Bus, but not with Logic Apps. So this is quite a powerful pattern that we can use. If we come back here, and I don't think I remembered to clear this table. So we had 511 originally, and we should see this going up. And I'd like to see 691 in there at the moment. If we come back to SQL, we'll see it's still chunking through and processing. So it is processing them slower. If I come down here, I can see that many are completed. And in fact, very quickly, I can do a count. So I can say select count star. Oh, excuse me. From employees, where control status equals completed. All right, so it's done 413 at the moment. And if I keep running that, that number will keep going up as it finishes processing each one. Alrighty, so that's it. I'm hoping that gave you a great overview of some of the throttling patterns and problems we've got. This is a solution that we've used with clients and it's worked really well. It might not work for you, but at least it's another tool in your toolkit. Thank you very much for watching, and I hope you enjoy the rest of the sessions. Thank you.
All righty. All yours, Kent. Hey,
Sounds
Mike.
good.
Hey, guys.
Hey, Mike. So I'm here to announce the next session. Obviously, it's Michael Stevenson, who's going to talk about a very important topic. We get this a lot, and so we really appreciate this session. It's around automated testing, and I think just all in all, just good practices about software development lifecycle. So, Mike, we're going to roll the recording. People, if you have questions, feel free to drop them in chat as we work through the session, and Mike will address them. But thanks, Mike, for being here.
Cheers. Thanks, guys. Hi, everybody. It's Mike Stevenson here. Welcome to Logic App Community Day. Today, we're going to talk about automated testing for Logic Apps. I'm based over in the UK in Newcastle. I'm a Microsoft MVP for 14 years, and I also do freelance cloud architecture, development, DevOps type work. Couple of links to my blog, and the bottom links for something called the Integration Playbook, which is where you can find a lot of information about the topic we're going to talk about today, which is testing Logic Apps. The agenda really quickly is we're going to look at how can I generate a test for my Logic app? What does a real world test look like? And then we're going to go into some more advanced topics like checking the data and testing it from a DevOps pipeline. So if we have a quick overview of what does it look like when we're testing a Logic app. So here in the middle, we've got our workflow. We then have some C# code, which is going to trigger our workflow. C# code and the test's going to then go and get the run history from the workflow. And we're going to make assertions to check the different actions executed successfully or to check that they failed. That basic principle will be repeated regardless of how you actually run the Logic app and test it. So it's, trigger, get the history, check what executed. Now, in the framework that's on NuGet and GitHub for testing Logic apps, there's two flavors of it. So you can either deploy your Logic app to Azure and then you can test it while it's deployed to the cloud, or you can run it locally in the functions runtime on your dev machine, and you can trigger it and run it again there. So the idea of the framework is to give you the same code or very few modifications to be able to test those logic apps regardless of where they're deployed. Now, there are a couple of limitations just mentioned on the screen here. For example, the cloud connectors can't easily be mocked out when you deploy into the cloud. There's a couple of challenges with certain connectors as well, even if you're on premise. Today in the session, we're going to focus more on testing once it's deployed to Azure, and we're going to look at some of the topics. But as I mentioned, the integration playbook has a whole bunch of resources that you could go and check out, where it'll go into those lower level features and talk more about testing locally. So question one is, how do we generate a test for my Logic app? Okay, so here we've got in the Azure portal a real-world Logic app called Ship Instruction Processor. And you can see if I open it up, the run history will display showing us what happened in our Logic app. So you can see we've got all the actions that executed, and you can see we're doing some HTTP lookups here. We've got some transformations, some encoding of data, and a few other kind of common real-world type steps in your typical Logic app. Now, what we can do in the sample solution, so this code sample is available on GitHub. So again, you can get the link for this from the integration playbook. But in my acceptance tests here, I've got a sample class called generate a test. And what I'm basically doing here is, because I'm a lazy developer who doesn't like writing loads of tests by hand, I want to generate them instead. So I can go to my Logic app. So this one here, I could grab the run ID. So if you saw back here, we've got the run ID. I could use that ID, and I can just use these 2 lines of code here, tell it which Logic app that I want to run, and then I can say, generate me a sample test, and then I've just got some debug lines that'll just go and do that. So I'm going to just run that test here, if you bear with me 1 second. So that's going to go and run that test, and we should see in the console window here, it's generated a whole bunch of code for us. So I can now copy that, and I can just paste that into this class. So I'll just reformat that slightly. So this test here, what it's doing is it's saying, here's the Logic App Test Manager. We're going to read a file, so we're going to have to set this sample file up in a moment. And we're basically going to trigger the Logic app. And then after that, I'm going to, with this operation here, we load the run history, and then we've got these assertions down here. So an example would be this line here, which I'll just correct that. So here I'm going, go to the run history, find an action called compose convert to JSON, and then we're going to check that that action was successful, which is what this line down here is. Now, to get this test running, I've already previously got the sample message. So in the Azure portal, I could have went and got the message that triggered the Logic app right at the start. So just give that a second to load up. Okay, so we can see from the run history here, this would be the trigger message down on the right-hand side here. So that would be the message I need to trigger my Logic app with. Now, over in my VS Code, I've just put this sample message here, which is taken from that Logic app. And then I'm just going to update the test. So here I'm just going to say, this is the file I want you to read for the test input. Just put a sign at the start there. And then I think we need to change the type to text XML. So now here, we've now got a test that we should be able to just run that would test that that Logic app worked. So I'm just going to grab a snippet to run the test. Which we'll see here. So here you can see we've just copied in the path for the test that the sample input file here. So now we've got a test that we can kind of run, and it'll go and test our Logic apps. So if I trigger that test, So that's going to run the test here, and you can see as we let this run through. So here we've got a test that passed, and we should be able to go into our Azure portal here, and we should see that we've just had a run execute just now, and that would have executed our test, and we would have done all the checks here to see all these different actions were successful. So you can see really with just a few lines of code here, we generated a test based on a run that we've executed previously, and then we can just repeat that run over and over again, and we've got a nice, easy to use automated test. So the next question is, what does a real test look like? So in the test we've just ran there was a simple .NET based test, but in the real world, I also like to use SpecFlow, which adds another layer on top of my my test, which makes it easy to understand the kind of the context around what your test's doing. So if we take a look back at the code here, okay, so here in the same area in the ship instruction, we've got the SpecFlow tests, and again, in the integration playbook, there's a lot of additional information about how to use SpecFlow, but what we basically do is we separate the intention of the test, which we document in a feature file, and then the code behind for the test, which will go in a C# class. So here, you can see that I'm describing the feature that we're building. So we've got a ship instruction where the transport manager wants us to have a system that would notify that there's a rail car going to be dispatched. We'd get a notification to the Logic app. It would transform the data, look up some data, and deliver a file to the end system. So this here really allows me to describe what this test actually does. So the the feature here is describing an overall set of tests, and then each different scenario would be described with a keyword here. So you can see we've got additional description about what's happened, and then we use the syntax of given, when, and then to sort of simulate the things that are going to set up before we execute the test would fall under the given. When's really the trigger about we send a message to the Logic app, and then steps are a bunch of assertions we're going to make to check what's happening with that Logic app. So really all we're doing is we're just putting a human description on top of the C# code to help you understand what's going on. So some really good tests in this sample project that people can take a look at in their own time if you like. But really what's happening is when you execute this step here, it makes some code behind over here would execute. So they're given I've got to request a dispatch an order. So here I'm dynamically building an XML document that we'd use to trigger the Logic app. The step where it says when we send a message to the Logic app. So here I'm just sending this message with the Logic App Test Manager, so it just triggers the Logic app that you want to test. And then again, you've just got the bit where we do the assertions. You can see it's the same code from that test we generated before the really simple test, but we've just structured it slightly differently, so it falls within the SpecFlow framework, and you get that layer on top, which makes it easy to explain to people how it works. The key difference really is that when I'm looking at the original test here, you need to be a developer to understand what's going on. You do a little bit more work and add SpecFlow, and then you can sit down with your business analyst and actually spec out exactly what it is that you want to do, and then you can use this test scenario to drive the development that you're going to do. Okay, so the next question we have when it comes to testing is, can I test the data within my Logic app? So we're going to use the test framework in an example here to show how you could look up the run history and find an action and find the data that was in that action to be able to check it as you expect it is. So when we do a test, we can trigger a Logic app and we can check, did step 1 run, did step 2 run, and that's great. We get an idea of did the flow go the way we expect. But what happens if you want to go a little bit further and check, does the data look like you expect it to in each of these actions? So how we would do this would be over in the code. Okay, so here you can see in the steps in SpecFlow, we've got things like we test it was converted to the flat file format. So what I'll do, I'm just going to go and find that in the code. I missed a bit here. Well, here's an example of it here. So we're checking the destination format here. So if you notice the little keyword at the top, the logic app will transform the data to the destination format. So here we've got the steps that we've usually done previously. So we've got an action called transform JSON to text. If we go over here, you can see this is what the action we're looking for is. So we can say, you know, if you look in the run history, we've got the input here, which is a JSON message, and then we've got the output, which is an XML message. So what we're going to do here is we're going to test firstly, was that action successful? So that's the same as what we've done previously. But now what we can do with the test manager here, we can also get the input and output messages. So if you see this line 134, we get the input message. 137, we get the output message. And there's a couple of helpers here if we want to convert it to JSON or some other format. But what I can do here is once we've got the message body from either the input or the output of the action, we can start checking what's going on with that message. So here you can see I'm just looking for a specific keyword in that message, which tells me that data's in the format I expect it to be. I think further down here, we've got an example where I'm checking the flat file encoding action. So here you can see I'm expecting, you know, if we go back to the portal for a moment, you see this flat file encoding action. It's quite a sort of old school flat file where it's a positional file, delimited file type format. And here I'm just sort of saying, we expect the message starts with this BOF keyword. We expect it ends with EUF and a character to a new line. And I could also do other things with that message. I've got the body so I can parse the string and start checking that it's in a good format. So really what we're trying to do is make our test be thorough, which will lower the risk of maintaining those logic apps and changing them in the future. Okay, so the next question is about DevOps pipelines. So we can run tests in Visual Studio Code. We can run them nice and easily with either the terminal window to just use a .NET test, or we can use there's a couple of test add-ins where you can execute them from the Visual Designer on the left of the VS Code windows. Most people are going to then want to run these tests inside a pipeline for Azure DevOps. So in the sample project, you can see up at the top here, we've got a YAML file which has all of the code for running a DevOps pipeline. So we've got two jobs in this pipeline. The first one's build, package, and unit tests. So this one's about packaging up the code, and we're going to run it locally on the build agent using the function runtime locally to run those tests. So that really would run the tests in this unit test project here. You can see there's a few steps about setting up Azure right, installing the functions, core tools, and a few other things. But the step I want to look at today is the second one. So this is the one where we're going to deploy the Logic app to Azure and run the acceptance tests. So this is the one where we're going to execute the tests against the deployed Logic app. So here I'm going to download my build artifact, which contains the Logic app zip package. And then there's a couple of other things we need to do here, which you can see they're all documented as to what we're doing and why we're doing it. But the key step is we get to this one down here, and this is going to deploy the Logic app to Azure. So we've got this zip file. So you can see this is going to be a zip file here. We push it with a functions task to an app service, and it gets deployed and spins up your Logic app. And then because we've had the code on the build agent by this point, I can then do a .NET test here, which is going to run the acceptance tests in this folder up on the left here. And that'll basically run all of the tests within this project. So you can see there's quite a few of them. And they'll all run against the deployed Logic app and basically check that it's working properly. And then we get the test results published down here. So they'll appear in Azure DevOps. Now, if I just drag over for a minute, another window. So here I've got the pipeline that I've actually ran. So you can see this is my pipeline in Azure DevOps. And see here's the two jobs. So we've got build, package, and run tests, and then deploy and acceptance tests. So here You can see the steps that I've talked about in that YAML file where we've built the solution, we've deployed the logic apps, we execute the tests here. So you can see this is the result of each of those tests that got executed. Then we can see the publish bit here, which will end up. So over here, we should see test runs. You can see here's the runs from my acceptance test, so I can see the output, I can see the results of each individual test. So it's quite easy. Azure DevOps is doing a lot of the work for us. We're just telling it to run the tests and save them, and you get all these good good things you would want to happen for your ALM process. Next up, we would like to know, can we generate documentation from my unit tests? So if you saw in the SpecFlow example, we had all this good documentation in that feature file. And the idea of taking the test a bit further than just the raw C# test and doing SpecFlow on top is that we can use that to drive some of the documentation that we're going to use. So back here, you can see we had the documentation at the top for the feature. Here I've put in a link to a markup file so I can link from that test to where there's more documentation if you want to go lower level. This bit up here, when we generate this documentation we're going to look at in a moment, this bit would actually link to a work item in DevOps. So just by putting an attribute on the test, we can actually generate links that you could click through to go into DevOps work items. And what happens is in the build pipeline, you would notice at the bottom here, I've got this SpecFlow live and document task. So what this actually does, I'm pointing at my acceptance tests folder, and because I've got the live and document NuGet packages in there, it's going to generate a file that would get published by DevOps' build process into Azure DevOps. And then if I go into my DevOps project up here, you can see I've got this SpecFlow live and document section. Just takes a second to load up there. And that's going to look up from my last run of my tests. You can see here I can go, right, here's my ship instruction, and then the ship instruction processor test. Let's look at the green path one. So you can see over here, you've got this documentation from that SpecFlow file in a more readable format. This is the link to the MD file. So I can click on here to go and look for more info. I can click on these links. So that would open up the user story here about that particular feature. And then I can see here, you know, it's easy for somebody, say a business analyst, to look at this documentation, see what's going on, see all of these steps, but then I can also show the test output and what I've been able to do in the code. So you would notice back in this test, so here where I've got the SpecFlow helper writing to its kind of debug write, that'll actually appear here when you go into the detailed test output. I can actually show test messages within the documentation. So the business analyst comes and looks at this and says, right, when we send the message to the Logic app, this is what the message actually looks like. Here we've got the map, so we can see the input message, that JSON message, and we can see the XML that came out. Then finally the flat file encoder, you see the input for it, and then this was the final output message from that encoder, which is the flat file we're going to deliver to the business partner. So you can see here with once we've done SpecFlow, with very little extra work, we can get this pretty documentation that can help the team sort of see how these interfaces are built and what they're doing based on a test-driven approach. Okay, so in the short amount of time we've got today, I'll give an overview of some of the cooler areas of Logic App testing approach that we've been using. Hopefully that encourages people to want to go and learn more. And I said earlier, we've got the integration playbook where there's loads of videos, which I've done previously and available on YouTube. There's documentation about how to use the framework. One of the things that I often find is because it's something a bit different to what a lot of people have done, there's like this apprehension about doing automated testing. So one of the one of the guys on our team, I asked him to give me some feedback on how his experience of getting up and running with automated testing was. So the guy here has come through the grad program. He's a very new developer, hasn't done Logic Apps for very long, but he's had to learn not just Logic Apps, he's learned things like functions, integration accounts, Terraform, and he's also had to learn all the automated testing. So here's a couple of bits of feedback of his experience. So for example, after understanding the basics, he can get, he finds that the tests give the context of what the application's doing. So the key thing is he can pick up some code that he's never looked at before. It's been developed by another developer, and he can go and look at them tests, and it helps him learn what the code's actually doing and what the intention of it is. Likewise, it's a great way to communicate between developers about how the code's working, and also it's really just giving you that confidence that when you've picked up a bit of code somebody else has wrote, or you've changed some code, you can run these tests, and it's helpful to see, not just it hasn't been run for 6 months, how do we test it, but also I've made some changes, has it broken anything? So that kind of de-risking and that communication about how the code works, I think is really important. So next steps from here, if you want to learn more, here's a bunch of links to the integration playbook. So there's info about testing Logic App Standard. There's also a bit of info about how you might do Logic App consumption if you're doing that instead. And the sample project that I showed earlier is available on GitHub on the link here. And I hope everybody finds that really handy and would love to know more. And feel free to reach out on LinkedIn and Twitter if you'd like to chat about Logic App testing. So thanks for watching my presentation today, everybody. I hope you enjoyed Logic App testing. I hope everybody's having a really great day on the rest of Logic App Community Day. And tell us all which sessions you've enjoyed, which ones you want to see more about. I'm sure community members in the Logic App product group would love to know what things people would love to hear more about. Take care, everybody.
Thanks, Mike. Because we're running on time, I'm not going to be bringing Mike for live questions, but there was a lot of interactions on the chat. Ask more questions there if you want. I hope that Mike will be able to stay for a little bit more. And we're going straight to a session from Alessandro talking about bicep and Azure DevOps and how can you use that to help you deploy Logic Apps Standard.
My name is Alessandro. I work and live in New Zealand. I'm in Auckland, New Zealand. I am originally from Brazil. So thanks for inviting me, or actually I applied for that, but thanks for choosing me to do a presentation on this Logic Apps Aviators Day. Very happy to be here, with a bunch of experts from the field. As I mentioned, Alessandro, I work here. I'm the integration platform lead for Fisher and Pico. We've been doing lately a lot of work with AIS in general, but our main engine is Logic Apps Standard, so that's what we use to do all the logic of our integrations. This is just a sneak peek of the city that I live. So this is Auckland, New Zealand. So, if you guys are ever around here, if you want to, tips about what are the best places to choose and to go, just let me know. I can give you a few tips about that. This is a volcano, by the way. So this was, I think, explored about 500 years or so. So anyway, we are safe here, so not a problem at all. Okay, so the agenda for today is going to be around 3 major, topics. So I want to talk about Logic Apps project structure and how we do that. In general, but also what I've been doing in the company that I work today. Then we are going to do a little bit of how we set up and organize DevOps pipelines, and how we make our life easier by using biceps modules and YAML templates. So the main work that we do is around Azure DevOps. We are not using GitHub yet, so it's going to be around Azure DevOps and biceps templates to deploy everything that we need. Okay, so this is this is how I'm going to do the presentation for you guys today. So the first thing is about how we organize the work that we do. So our logicapps structure is going to be that we might have like lots of workflows, lots of code that we want to organize. And the way we do that is going to be one logicap for one or more workflows, as long as they are on the same business process domain. So that's how we do the organization. So let's say that I have, I'll just give the example of my company, right? So I have sales orders process, I have inventory process, I have stock management process. So all of these, we organize them to be all together in a single logicap. So it's going to be one logicapps to handle things related to the sales order process. There's going to be another logicap to handle all the inventory business process, and so on and so forth. So that's normally how we organize the project structure. And we are going to be hosting all of those logicapps in one service plan, we can select one or more service plans. Right now, I think we have around 10 to 12 logicapps running the same service plan, and we've been able to use a single service plan for all of those. If we ever see a need based on the execution volume for a particular logicap or particular logicapps, we can have a second service plan to spread the workloads. But so far, we've been, I guess, quite successful managing everything in a single service plan. Our service plan is we configure to be scalable up to 3 instances. So normally we are going to see everything run in a single instance. Whenever we have peaks, it can go to 2 or 3. So that's how we left the configuration, so we can control the costs a bit by limiting to 3, but also allow the any peak that we didn't foresee to be handled properly. So just to show a little bit that we have, every single one of these projects, they handle one particular logicapps. The one that I'm showing the screen right now shows exactly what is my structure, and this is the structure we use across every single logicapps. So you are going to see that I have the code for the logicapps itself here, with its artifacts, with maps. We pretty much just use maps. We don't use schema so far, and all my workflows should do the work that I want to do. We have the standard, connections, the parameters that we use, configuration. We have the pipeline itself here together in the same project, and let's call it like accessories. So whenever we need to deploy other things related to that project, it's going to be together in the same thing, like Vault or Service Bus. Okay, so that's how we do the organization of our projects. Okay, so that comes for the next slide, which is going to talk. Is going to talk about that. So we have one repository per logicapps. So if I have like a logicapps that do sales order, is going to be one repository handling that. The other one that I mentioned about inventory is going to be another one, and so on and so forth. We do have a shared services repository, which means that anything that I need for the execution of my logicap, or any other services that I use like together with my logicapps, like service bus, storage accounts, API management, application sites, log analytics, all of those things that we need for a solution, they are shared across in the platform. We have a single shared service repository that's going to be the responsible for maintaining that infrastructure. And we do have also another project specifically to manage modules and templates. So if I want to deploy a Key Vault, it's going to be the same kind of deployment across like all my environments. So instead of having to duplicate and work directly with the bicep resource, we do have a module specific to do the creation of the things that we need. And we also use like lots of YAML templates to help us, minimize the work we do in the DevOps side whenever we are coding the actual code. Another thing that we do, we work like with a Git flow structure where we maintain the code across our environments. We have 4 environments today, which is development, test, pre-production, and production. And in those environments, we define what's going to happen based on what we're doing in the code. So if we are working in a feature branch, when we commit the code, that goes directly to our development environment. When we do a merge to the developer branch, that triggers the execution, the deployment to development and test. And you can see this represented here you can see this represented here in the screen. So this is a commit to a feature branch. This is a commit to a developer branch. And when we do a commit to a release, then it goes to pre-production and production. So this help our organization of the code and when things should be going to whatever environment. That is like using a combination with bicep templates and parameter files. So we know like whenever we deploy to another environment, which settings we should be using to deploy in that particular environment. In the pipeline itself, and I'll talk specifically about the pipeline, we use stages, as you saw like in the previous slide, that I control stages to be doing deploy. We control like stages for environments, and we control stages for other things, like, for example, doing the builds. So we do have a build stage. That build stage is going to be responsible to make sure the code is good enough to be deployed. And if we pass that stage, we then publish the code to the pipeline and move to the next steps or to the next stages. Okay. The idea of publishing the code, even though like for logicapps is pretty much like there's not a compilation per se, but we always publish the code because we want to see if the code's gonna be what is the code that we deployed in that particular execution. So let me switch here. And you're going to see here that whenever I deploy my code, I should be able to see what has been published. And if I want to inspect what is in there, just open the zip file that contains, that is like together with your pipeline execution, you should be able to see what has been deployed. We do lots of validations to make sure that we just go to the next stage or to the next job or to the next step. If I have like all the previous execution working well. So we do lots of conditions in the pipeline to make sure the codes, the deployment worked fine until that point. And another thing that we do is the Git hash comparison, which means that what I want to know with this is like what exactly is the code that changed between one execution and the next. So I can go back here to show you guys what that means to us. So if I take like one example of the deployment that we did, so this is one of the changes we did few weeks ago. And if I look specifically into this deployment, I have like all these things that I need to do, like deploy service bus, deploy the logicapps infrastructure, deploy the logicapps workflows. I'm just doing that because in my check, or in the check that we do, I know exactly what has changed between one execution and the next. So that helps us save time in the pipelines. So instead of trying to deploy like everything all the time, we just deploy things that have changed. Let me find one. Yeah, this is a good example. So I'm checking for changes. So this is what came back from the Git hash comparison. It's saying you change like one workflow inside your Logic Apps. So I am skipping service bus. I am skipping this Logic Apps infrastructure, and I'm just deploying the Logic Apps code itself, right? So the Logic Apps code is like a unit, so I need to deploy everything. I cannot only deploy like a single workflow or a single map. So we deploy the entire unit. So that's why we have this deployment happening here. And at the end of my process, I update to the latest hash. So the next time it runs, I know exactly what is going to be the next, the next difference. To update the hash, we use libraries, and we have variables inside of those libraries to control per environment what is the latest hash for the deployment. So that's how we know what has changed. Another thing we do, we deploy, as I mentioned, like we deploy the shared resources in a separate repository pipeline. But that's for the infrastructure, which means like the proper service bus, API management, storage account, and so on. But if I have dependency on things being used specifically for that Logic Apps, like I need a queue, or I need a topic, or I need a container in a storage account, I will add that to the project itself. So I think that's one of the things that I showed before. So let's go back here. As you guys can see here, this is my one of my Logic Apps projects that I have like all the code for the Logic Apps, but then I also have the need to create queues. And this is here in a bicep template. Again, we just use bicep for everything. So it doesn't, it can be like Logic Apps, or it can be like anything else. But this is how we do. So we do the deployments of related things together with my Logic Apps code. So that's, I guess, a good approach. I don't maintain those things like in a separate repository, because it's going to be very hard to know who is using that. So that's the reason that we put this together with the Logic Apps codes. Yeah, that's what I'm saying here. Deploy the infrastructure only for these shared resources in their own pipelines. The Git hash that I just explained, like we only deploy what has changed by using Git hashes comparisons. So yeah, that saves like a lot of time to us, as you can see here in this example. Instead of spending time trying to deploy things that are already there, we pretty much don't spend like any time on them, and just go for the things that we really need to deploy because they changed. And the last thing is we use bicep modules and YAML templates. So instead of having to redo things like all the time, we try to find what is the common things, or the common ways of working between like all those pipelines, and we put them in modules or YAML templates. So the other thing we do, we have a step to validate the bicep template to make sure it's in a good state before we even try to deploy. And in some pipelines, we do a what if command. So we can check the differences before allowing the deployment to happen. We only do that in the shared resources right now. I think that's the most important one. So I have, as I mentioned, the shared resources. I have service bus, I have storage accounts, API, and service plans, and all of that. So this what if command we are doing only in that shared resource, because before I approve the deployment, it's going to the environments that we have. I want to see exactly what has changed from one to the other. So the what if is a good tool to tell us what happened between one execution to the next. The reason to use bicep modules and YAML templates is to facilitate the developer's life. So for the developer of the Logic Apps, there is like a ton of steps or a lot of configuration that we need to do in the Azure DevOps pipelines. But for them, they just need to refer to single templates. So that's pretty much the goal. They pass parameters that we need to pass for each one of those templates that we use. But it becomes like a lot easier for them to specify or to create like pipelines for the code that they are doing. So instead of them spending like a lot of time doing the coding of those pipelines, they just use templates that make their life a lot easier. And this is like an example of how we do. So we have like the modules. This is just some of the modules that we have, like to create API connections or function app, the Logic app itself, key vault, storage accounts. We use a few scripts to help us manage like the Git hash with those two here, or even import APIs in a faster way because we just import the things that have changed here as well. And these are some of the templates that we have. So you're going to see, for example, the publish of Logic Apps standard, deployment of a Logic Apps infrastructure, deployment of a Logic Apps code. So this is what makes the life of the developer a lot easier. I forgot to do one thing. Let me switch quickly here, and then we can come back. So as an example, so we do I have like one Logic Apps that I deployed yesterday. So that Logic Apps are very, very simple Logic Apps. So we do have a simple HTTP request being received and a response being sent back. So that's the only thing this guy does. So let's say that I want to make a few changes on it, which means that I want to use a liquid map as once the designer opens up for us. Yeah, so that's the code that I have in place today. But let's say that I want to make a call to a map. So I'll be calling this. For me, it's going to be a simple transformation from JSON to JSON. I will specify the name that I added there, and I'll be pointing to this map that I have deployed before. Because I have my pipeline already set, whenever I commit this code, the deployment is going to happen. But before we do that, let me switch real quick to what is my pipeline. So I have like I was talking like about modules and templates, but for the sake of this, demonstration here, I just did like everything at once. So I have this deployment to deploy the Logic Apps infrastructure, and I have this other task to deploy the Logic Apps code. Okay. If I look at the bicep for the Logic Apps infrastructure, that's the guy that I'm using. And in here, let's go to the top. I have a few parameters that I want to pass. I have a previous key vault that has been created already. I have a previous managed identity that have been created already. And this is about, okay, do the service plan creation, do the storage account creation, log analytics, application site. So all of this is going to be created if they haven't been already. Again, I did this all together for the sake of this presentation. This is the actual Logic App. This is about deploying the infrastructure. Okay. So I'm doing everything that I need, creating connections, creating access permissions. So everything that needs to be done is going to be done here. And this is about that step, the Logic Apps infrastructure. Whenever I'm ready to deploy the code, it's going to be this other step, which I use the build that I did in this stage. So again, stage for building the infra, stage for deploying the infrastructure and the code. When I commit the code, and I send that to the remote repository. If we switch here now, let's go back here. So I have the pipeline being triggered because I'm monitoring the main branch, which is going to trigger the execution. It's going to take some time because in this demo, I didn't do like all the validations that I mentioned before. So while this finishes, let's switch to the actual code that we have in our solutions. I was showing to you guys. So this is what the developer needs to do whenever he wants to work like with our structure. So I have the build phase or the build stage. I have the development, tests, pre-production and production stages. I do my conditions to make sure that I have the code in the state that I want. So the things that I was talking about, the branches and how we use and what that means to our deployments. So we control here in those conditions. I only go to the next stage, like test, if my previous stage has been worked fine. And I just need to specify templates. So that's pretty much what the developer needs to do, and specify the parameters for each, which makes it a lot simpler for them. This guy here, it's here as well in the same project. But if we look at what it actually does, so this is the code to say deploy. Sorry, this one. This is the code to say deploy my infrastructure if I need. And this is the code to say deploy my workflow code if I need. All the controls for validating the Git hash and all those things that I spoke to you guys, that's being handled in those templates, and the developer doesn't need to know that. So he just needs to pass the right parameters. These other things that it's in here is because, as I mentioned to you, sometimes I need to add service bus topics and subscriptions. Sometimes I need to add a container in a storage account. Sometimes I need to do other stuff that is related specifically to that project. So we manage here as well. But in terms of the Logic Apps deployment, is pretty much a template that I'll be using. I can show a little bit more. Let me close this to try to release a little bit of memory before this thing gives up on me. So here is the templates that I was mentioning, like the things we use to do things the same way over and over. So we have the bicep modules here at the bottom. They are just bicep modules, nothing majorly complicated about them. It's just about knowing which modules to use. Sometimes we do need to send information out of the bicep module to be used in the next step or the next execution. So sometimes we do use this. But for those that have worked with bicep, it's very simple, very not complicated to work with them. Normally the bicep modules, they're very fairly simple to work with. Okay, so as you can see here, nothing major happening. Sometimes we do things like in the module to set up like permissions or stuff like that. But yeah, very simple to work with them. These are my this is my code that I do to set up the infrastructure. This is the code that we do to deploy the code itself. They use other templates like checking the file changes, as I mentioned, for Git hash, downloading other scripts that we need to do, and a few other tasks that we have in our code. And just to finalize, just to show that, like in this deployment that I did from Visual Studio Code, not from Visual Studio, but the code that I committed from Visual Studio Code was triggered the execution of this pipeline, which deploy both my infrastructure as well as the codes. And if I go back here, you should see that logicapps up to date. So I can look up, that's the code that I have. And if I go to the designer, that's one thing that I noticed, like sometimes it doesn't show up, but if we force the execution, it's gonna pick the latest thing. I think it's just one thing with the logicapps designer. But if we do look here in the execution, we should see, yeah, we should see the map being executed. That's my latest version of my code. Let's try one more time to see the designer. Yeah, now I can see. So it's a little bit like something that needs to be fixed properly. But after I do a deployment, it doesn't show up in the designer, but it's there. So just the one is execution should be seeing that shortly coming up. Cool. Yeah, I think I ran out of time, so I'll just finish up here. Thank you again for allowing me to do this presentation. Hopefully, it was a session that you guys can use like in your day today. For those that want to keep in contact, these are my contact details. I have my blog post. This is my Twitter account and also my LinkedIn profile. So thank you for having me.
Hello, everyone. So this is going to be our last community session of the day, and then we've got the round table, which Sandro has offered to join us for as well. So Sandro really needs no introduction. He is a guru, I will say, when it comes to data mapping. So I can't think of a better person to do this session. I do want to just thank him sort of publicly. He's given us a ton of feedback on the data mapper, which has improve the overall quality of it. And he's given us so much feedback that we said, hey, you get to do a session now. So thanks, Sandro, for being a good sport. And I'll hand it over to you. This is going to be a live session, folks. So feel free to add questions into chat and we'll sort of see what we can do in terms of getting those surfaced and getting Sandro's attention as we sort of work through the session.
Yeah, thank you, Kent. So yeah, this is a live session. It's 10 o'clock here in Portugal. So my kid is just on the other room. I hope he's not entering in the room, but yeah, never knows. So be aware. So for those that doesn't know me, my name is Sandro Pereira, as Kent mentioned. I live in Portugal, Porto, and I'm the head of integration at DevScope. I'm being an MVP from 11 years. I think this year is 12 years on the MVP program. I started as a Beanstalk MVP, integration MVP, and now I'm an Azure MVP. But my focus is on enterprise integration, and that means working with Beanstalk and Azure Integration Service. Everything that is integration related with Microsoft. This is what I do all here. So you have my emails there, my LinkedIn, my blog. Feel free to reach me out if you have any questions about this, or share some feedback. And I'm also an instructor delivering trainings about, again, everything that is related with enterprise integration, Beanstalk and Logic App, Azure Integration Service, all of this stuff. And this was me 10 years ago, speaking about data mapping, transformations in general. In that period, it was about Beanstalk transformations. And that led to me creating a book that is free about, it's a 400 pages book that I did in almost 1 year, focus about just mapping. In this particular case, about Beanstalk mappings. Nevertheless, is XSLT behind the scenes. It still works today and is still very. The content is, you can use it nowadays, even now. And that's the reason why I'm here also speaking about the new data mapper that the Logic App team just released a few weeks ago. This book the book that I wrote talks about 12 Beanstalk mapping patterns. These patterns are not related to Beanstalk itself. It's related about transformation in general. And so these mapping patterns will also be applied in the new data mapper. We hope that all of these can be worked also in the new data mapper. And the 12 patterns I described was about direct translation. That means just copy from the source system to the destination schema without changing the content of the fields, just kind of direct mapping. Of course, we are changing the format of the message. It can be from a different XML schema to a JSON schema or XML to XML. We also have the data translation. That means that we are going to a specific field or several fields of the message, and we actually going to translate or transform that value. A date to an age, something like that. So it's going to be different. Concatenate fields, all of this stuff. We also have content enriching pattern. That means that we are going to enrich the message, the destination message, with more data that we receive on the source schema. We also have kind of aggregating patterns, and that means that, for example, aggregating two types of message into a single, combine these two messages in a single one. This is very common to happen when we receive a message. We go fetch the message to another internal system, and then we need to combine this information into another final message to be delivered to an end system. We also have the content filter pattern or data cleaning pattern. Sometimes we can, but these two names kind of do the same. So we receive more information on the source schema, but we don't actually need that amount of message. So we are reducing the number of fields from the source to the destination. We have the splitter pattern that somehow is kind of the inverse of the data aggregator pattern. When we have a message, but we want to kind of generate two different messages to be delivered to the two different systems. Okay, we can apply a map and then another map, or we can apply one map to do all of these. Instead of being two maps execution, we have one map execution, and it creates two types of message. And then we have kind of more complex situation that is grouping patterns and sorting patterns. Most of the times, these two type of patterns are combined inside one transformation requirement. We have conditional patterns that based on a condition we're going to map or not, or going to map different values. And then we have looping patterns and these kind of canonical data patterns. When you have a canonical schema and different schemas from different source systems, but then we have a canonical schema internally that we map all of these to a canonical, and this name value when we have a schema that only contains keys and values, and we map to that one. These are the 12 patterns I wrote on the book, and some of these we are going to try today. Some of them probably at the moment are not supported, but they are going to be supported. And in real case scenarios, we see all of these patterns combined in a single transformation requirement, okay? It doesn't mean that we only going to apply one of these patterns in a specific transformation on a specific map. These are subsets of patterns that we see daily on the transformations. And of course, in a real transformation, we are going to apply several of these patterns inside the map. Well, I'm not finding an excuse, but it's important to mention that data mapper is still in preview, okay? That means that you are going to find issues and something maybe not working at the moment. The important is for you to give feedback, because that's the importance of the private preview, is for you to give feedback, and you have this link there where you can submit issues. It doesn't need to be an issue. It can be an issue, it can be a requirement, a feature that you need. Just kind of go there and submit your feedback. I can say that I'm using the data mapper since private preview, and it was probably for me it was easy to say I'm not going to try that. But for you to have an idea, me and along with Kent, on the first week we opened more than 60 bugs, new features or improvements that we need to have in the data mapper. And I can say that all of these are going to be handled by the Microsoft. They are heavily investing and hear the feedback and put on the roadmap to build on the new features. So yeah, if something don't work, do not say I'm not going to work this. Just submit the feedback, and at the end is going to be a good data mapping tool. Without any delays, I'm not want to spend too much in slides. I'm going to show the data mapper in action, okay? But before that, for those that came from the Beanstalk background, this was kind of the Beanstalk mapper, okay? We have the source schema, we have the target schema or the destination schema, and in the middle, we have different layers with all the transformation rules. And these squares that you see there, they are called functoids, okay? Kind of functions that you can transform data from the source schema to the destination schema. A concatenate, a scripting functoid that basically is kind of code, in this case, kind of a little bit of a C# code. We have conditions and creating the process, kind of adding new data to the destination that is creating a timestamp here, and a lot of loopings and cumulative sums to calculate this. This is also the map that you use on the Logic App consumption. Actually, what you are seeing here is the Logic App consumption. So Microsoft did a lift and shift from the Beanstalk mapper and create this Logic App mapper. I don't know what's the correct name for that, but is the mapper of the Logic App consumption. if you create that, you have to then export the XSLT to the integration account, and that's it. And the good things about this is kind of you can select the map. You provide an instance input of the message, and you can right-click, test the map, or also debug the map, and you see that at the end it's going to execute, and you have the result. Kind of you test your mapping transformation, and then everything is good. You deploy to the integration account, and you can use inside the Logic App consumption. Okay, and that's also work in the Logic App standard, but you need to use the integration account. Okay, this is the new data mapper. Okay, you don't need the integration account for that, for using the data mapper. This is built-in functionalities inside the Logic App standard. Once you create a map, you have a folder of artifacts, and you have the map definitions, the maps, and the schemas there. When you create that, it's going to create a file, and we are going to create soon one map. But it's going to create that, it's going to execute. You don't need more an integration account to have maps and schemas in the Logic App standard. And this is the new data mapper. So this is the exact same exercise I show on the Beanstalk map, on the Logic App consumption map. This is the same exercise. And this exercise is what I call the basics of the maps. Because when I create the book, I select a specific transformation with the most common rules of transformation. That means kind of we need to do a concatenation. We do to do a age calculation based on the data of birth. We have a direct mapping, that is the address. We have a zip code that is a conditional mapping, because on the source schema, the zip code is not mandatory. And if it's present, we need to map. Otherwise, we will not map the zip code. And that means that the zip code is not going to appear in the message. It's not an empty string. It's not going to appear. So this is optional. We have a processing date that is adding more information to the map. And at the end, we have the same phone billing calculation that is do a sum of all the calls that I made and put in international calls and national calls. So when you open the map and when you create the map, we are going to create this from the scratch. What you see here is kind of the overview. So then you have to enter in each node, and you see that in this case, I have the concatenation, I have the age calculation, I have my data, my address, all of these transformations, and then can enter in the phone billing. And if I have here a huge different mapping condition, but it's doing the same, it's doing all the calculation. And we also can do the same of testing these. In this case, at the moment, we are not saying we are going to select the file. We just copy the sample file to the input. And this is the same input. And then just run a test, and this is going to be the outcome. So that means that I'm Sandro Pereira, 45 years old, and national calls is 2.7 and international is 15. If you go to the same one, it's actually the same, 2.7 and 15, 45, Sandro Pereira, everything is the same. So we actually can do the exact same transformation both in the Beanstalk mapper, in the Logic App mapper, consumption one, and in the data mapper itself. Okay, so I'm going to come back here, but let me show you another pattern, and that's the aggregator pattern. The aggregated pattern basically means that you have two types of message, and we want to combine that in a single message. So in Beanstalk, we can do this type of transformation inside the orchestrations, because in Beanstalk we can use transformations on the receive ports, on the send ports, or in the orchestration. These multiple input message we can only do inside the orchestration, because what Beanstalk does is behind the scenes create a different type of message with two messages inside, kind of import that message in a different schema and do the transformation. So by default, data mapper only support one schema, but we can apply the same concept in the Logic Apps standard as we use in the old days in Beanstalk. So what I have here is that I'm going to send a simple request, and you can see that inside my Postman, this is only going to be a user ID, last name, and first name. Then what I'm doing here inside my Logic app is I'm going to emulate, I'm not calling an external system, but it's kind of emulating a call to the external system and receive a message back from that internal system. So to emulate this call, I just create a compose and create my second type of message. That is going to be the user ID and then address, postcode, and town. Okay, just imagine that I call kind of a SQL server and receive this information back. Okay, which is, for simplicity, I use this emulation. And then what I'm doing here is exactly the same that Beanstalk server do behind the scenes. I'm creating a new message. In this case, it's a JSON with two input message part 0 and message part 1. On the part 0, it's my message that I'm sending with the Postman. On the part 2 is the message I received from the external system, and that can be more than 1, 2, 3, 4, 5. I decide that. And then I'm going to pass that to my mapping. And you see that my mapping is composed by two types of message, and then I'm going to start mapping these. So you can see the schema here, that all my schema is input part 0, user ID, last name, first name, and then the other is the other type of message that I was creating inside the Logic Apps standard. So the first part about the user ID full name, I'm going to extract this information from part 1, okay? And when I came to the address, then I'm going to map this from the address, postcode, and town. And so kind of with a direct transformation, I didn't want to apply too many rules there. Inside the Logic Apps standard, now we have a different action. So if you see add action, if you search, we have now a data mapper action operation, and you can say transform using a data mapper XSLT. So if I choose that, I can select what is the content that I'm going to send. This is going to be, oh, not this one, sorry. This is going to be the outputs of my multi-part message, and then I select what is the map that I'm going to use, and that's going to be the aggregation mapping, okay? Just let me delete this because I already have this here. As you can see, outputs, Logic App, aggregation pattern. Awesome. And then I have my response, that is the response of this transformation that I have here. So fingers crossed, this is live, run without debugging here. Just a small second, start this. And come on, runtime. And then I come back here and say, send it. And if everything works fine, I'm going to receive the response back of that transformation soon enough. There you go. ID, full name, address, and that's it. Okay, it works. So let me stop this. So everything good there. Just a small note that you need to have this work runtime.NET isolate and this Azure Web Job Features flag enable multi-language worker. Otherwise, you cannot use the data mapper in runtime. Okay. So how you create a map? There is an extension data mapper that you can install, and then you can kind of create a new data mapper and provide a name. And let's call it Community Day. Spell, but no worries. Right? So you have the source schema, you have the target schema, and then we can kind of click add, select existing. I'm going to the person origin, add, and then add a target, select person target, and that's it. Okay. And of course, it's going to create behind the scenes a new map here on the artifacts. It's going to create a new map here once I save that. Of course, all the schemas have to be there for me to import from here. So now, again, I'm on the overview page. I cannot do nothing, so I need to enter that here. And by default, because I didn't have nothing, it's going to appear in a blank situation. And then you say select elements and say, okay, I want the first name, last name, date of birth, address, and zip code. Okay. And then start to create all the functions. Here, what I'm going to put here is not called functoids, it's functions, but it's kind of the same that you see. It's a function that you can do a transformation. And in the first case, I want a concatenation. So concat. And if you select the concat here, we see that the first input will be the last name. I'm going to add a field here. This is going to be a custom one because I want to put a comma on the middle, and then I'm going to say first name. And then I'm going to grab these and put in my full name. Okay. At the moment, you cannot drag and drop this one, but Microsoft is fixing that. It's going to release, I hope soon, the way that we can drag and drop all of these functions from one side to the other. So now I need date of birth, and date of birth is going to be a little bit tricky, but we can do the same with a subtract. Substring, sorry. And I'm going to say that my substring is going to be the date of birth, and I'm going to get the first 4 digits about that. And then I'm going to do, because this is a string, I'm going to do a toInt, integer, and then I'm going to say that from the toInteger is going to be the substring, and then I'm going to do a subtract. There you go, math. And from my subtract is going to be the int. No, sorry. The first is going to be, I'm going to cheat here, but I'm going to put 2023, that is here now. I'm going to subtract. Of course, I can get that value from another function, but not to do a more complex situation. And then I'm going to put the age here, okay? Again, it's kind of overlap. You cannot kind of drag and drop, but a little trick is go back to the main overview and then enter again. And it's going to render in a different way. You can read now a little bit better this, okay? And I have to select again this one, address and zip code. So address, is going to be a direct stuff. So I'm going to copy from one side to the other. And the zip code is a condition. So what I'm going to do is saying that not this one, kind of exist here, and on here I'm going to say zip code on the exist, and then put if else. Oh, sorry, not if else, but if. This one I'm going to delete, and this if, the first one is going to be a true condition, so it's going to be the exist, and then the second one is going to be the zip code, and then map these to the zip code. And finally, the age is going to be the date and current date time value, for example. And this is going to grab this for this one. So I can save it now if I want. Go back here, go back again. So I save it. I can do partial testing. So let me do a test here. Let me copy the same message back and say, boom, test it. And you see that we have all of this stuff already being mapped in the correct situation. And even if I go here and say I'm going to remove the zip code, just you guys know that this is going to work, get the zip code disappeared. So it's mapping correct one, condition, and so on. Let me see. I have a few more minutes. I hope I can do this exercise because this phone element is a bit more complex, no? But let's try it. Can't, if I go over the time, just interrupt myself, okay? So I'm going to start with. So here I want to kind of phone number. I want to do the total of national calls and international calls. So this is going to be the phone number, and because I'm in Portugal, the international code of Portugal is +351. So that means that I'm going to see if it starts with 3 plus 351. If so, that means that I need to add this to the total national. So now I need to do a if else. If else, there you go. And this is else going to be the start. And if true, then what I'm going to map is the cost. Otherwise, what I'm going to say is 0 because, well, I want to have 0 if I didn't have any national calls. And then because again, this is going to be a string or it's a kind of a decimal, I'm going to do to number to guarantee that it's going to be a number. And this one is going to be the if then else. And then because I want to sum all of them, I have sum here, and on the sum, that means that my collection is the num, and the scope is my phone calls. And then I put that on the total national. Let me save that, going to the little bit here so I can run this better. And if I do a test again, I should have now some exactly total national 2.7, okay? And if you remember, there was 2.7 in the other one. Now, I need to do the opposite. So I need to kind of go to the logical knot, because, oh, sorry, it's not here. So let me enter here, and I put logical knot here. So if it doesn't start with 3.5, it's going to receive a false, and I'm going to convert to a true. And then I'm again going to put if else, and that if else is going to be that not, and again is going to be cost, and again the same as 0. And I need to put to number again, and that's going, sorry, just keep these out of the way. That's going to be here, and oh, damn it, I want to be quick, but, and then I have a sum there, and this sum is going to be my collection. So the scope is going, let me put here. Again, Microsoft is improving a little bit this experience. So I already gave this feedback to them. So they are improving a little bit, because then I have to go here, and then I have to go back again here. Just to put, what is, and sorry, but there was a bug. So again, Microsoft is improving this, and because I didn't map the correct, I went outside, and it broke the design. So again, they are improving. They are going to fix that. The important is that it works, and with that, I think is everything. And let's kind of try to respond some questions.
So I did try to address some of the questions that did come up. So I think we're caught up there. I think we'll probably, just in the interest of time, move over to the the round table. And Sandro, if you don't mind sticking with us, that'd be great. And then we'll see a few other PMs join here as well. And yeah, if folks have other questions around Data Mapper, feel free to add them in chat, and Sandra will take a look at those. But I think generally we should be caught up on that front. There was one comment, quite impressed with aggregator mapping pattern. We'll definitely try that. So yeah, good job, Sandra.
Yeah.
I was on mute. So Alex, all yours if you wanted to moderate the questions. And Divya, if you're online and wanted to join, just open your camera. I'll add you to the stream as well.
All right. Great, thank you. So we've got a couple questions that are submitted, and of course, feel free to either submit them to the Poll Everywhere link that we have, or put them in the chat, and we'll kind of get to them. But for now, we're just going to go through our top ranked questions for the Ask Me Anything that we put out. So one of the top ones is Data Mapper deployable? We couldn't make it deploy, always complains of missing assemblies. I know, Sandra, you just gave your whole talk about Data Mapper, but Ken, I know you and I also could take that one, but it's question number one.
Is the Data Mapper deployed?
Yes. The question was, is data mapper deployable?
So I suspect what it is what Sandro did show there. Like in the host.json file, you do need to enable the multi-language worker, and the runtime needs to be .NET isolated. So we do have that called out as a prerequisite in the blog post on Tech Community. We can try to dig that up here. But I suspect I can use those settings in VS Code. And really what you're doing is you're generating an XSLT file as you build and test and save your map. And then from there, what there is a data mapper action, built-in action that you then go ahead and use to select the XSLT file that you've previously generated. But I do feel it's probably related to those prerequisites.
But
So
also,
I'll
when
go
you
ahead and
deploy the
find that link
solution,
and paste it into
right,
chat.
well, when you deploy the solution, also going to deploy all the artifacts on the folder. So it's going to deploy all the XSLT behind the scenes that you can use in your container of the Logic App standard.
We've got another question related to data mapper that's kind of on our top ranks as well. It says, one topic to discuss could be something on transforming payloads. Microsoft pushed liquid templates a few years ago. Now we get the data mapper and are encouraged to go to Logic Apps standard for enterprise scenarios. Will liquid transformation still have a place in enterprise integration scenarios?
You want to respond to that, or should I? Well,
I don't know. I can't speak very well on any sort of liquid transformation, so I'll give that one to you guys.
So I can start saying that I didn't say that on the session, but this data mapper, it transform messages from XML to JSON, XML to XML, JSON to JSON. So it supports all the kind of formats that you need. Does it going to replace liquid template? Probably not. So depending on the scenarios, you can use the data transformation or you can use liquid templates. The thing is that this data mapper out of the box is support with the Logic Apps standard, and you don't need nothing to contain the liquid transformation like integration account or something like that. You can use the data mapper itself. And it's going probably to be more readable and better to maintain than the liquid language.
Yeah, I could provide some more sort of insights there as well. So like, I don't think there's any plans of like removing liquid at this point. I wouldn't anticipate a whole lot of investments in it though either. I think our goal is to have a unified experience around data mapping. And so that is like JSON, that's XML, and then in the future, CSV. And what we've done with the data mapper is we've got more of this unified approach and sort of this unified architecture to enable that. Obviously, like between XSLT and Liquid, there's some different like incompatibilities that exist. And by us standardizing on XSLT 3.0, we can have a consistent experience across JSON and XML so that your support is the same. And the other thing that we do is support like any to any, right? So XML to JSON, JSON to XML, etc. So having that compatibility is very important. So we do use a third-party library underneath the hood that sort of helps us enforce a lot of this or implement a lot of this compatibility. But that's one of the drivers why we're not using Liquid. But certainly if there's scenarios that for some reason you could do in Liquid, but you can't do in the data mapper, we definitely need to know about that. But we don't anticipate, many of those types of situations.
Mm-hmm. And the only other thing that I would add to add is you can create new things using the data mapper, but that doesn't mean that the legacy maps that you have, like I call it legacy just because it's anything that you created up to now, right? Those things are not going to disappear. You're not going to be forced to remap that just because you have the new data mapper. You're going to be doing that at your own time, and if it's have any benefits for your project.
Yep.
Yeah. So Another kind of related question to Data Mapper and our top ones here. It says, thanks for the event, very interesting. And how do you see the Transform XML versus the Data Mapper? Will the Data Mapper replace the Transform XML over time?
So I think this is kind of similar situation in my mind. So the XML transform today, it does support XSLT 3.0. It also does support the XSLT plus .NET Framework support that we've enabled before. So if you're moving your BizTalk assets, right, that also is supported basically through like XSLT 1.1. So once again, like, I don't see that changing anytime soon, especially like Data Mapper is in public preview. We're working towards GA. So like there's nothing drastic going to happen here from that perspective. Our goal obviously is we want people using Data Mapper. We want you to use like that first class experience and to be able to have a graphical mapper where you can go ahead and do all of the things that you need to do. But on the flip side, like, yeah, there's no plans to remove or do anything drastic with the existing capabilities.
Yeah, it would be the same thing that we talked about Liquid. All the existing investments is protected by using the XML transformation that you're probably already using today, with the added bonus to on those BizTalk migration scenarios, you having the ability to support everything, including code, while anything greenfield, I would suggest people starting to use Data Mapper.
Awesome. Now a question, one of our top ones not related to Data Mapper. We've got a question saying, my customer is considering migrating integrations from BizTalk to Azure. What advice do you have to do this?
Maybe I can start with roadmap and then we'll throw this over to Sandro, since I know this is part of your daily activity. So last year we did announce a roadmap to help address the gaps between BizTalk sort of use cases, BizTalk scenarios, and Azure Integration Services scenarios. And so part of that includes like support for that XSLT plus .NET Framework so that you can generally lift and shift your maps. Today, obviously, we had the big announcement about .NET Framework custom code. So if you've got assemblies that you are sort of calling and you've got logic, or transformations that are in code, we're supporting that. We've introduced, preview support for Swift. There's some other roadmap items going on right now just related to the rules engine and XML. And then also at Integrate, we just showed an early view of business process tracking, which is a successor for BAM. So as you can see, what we're trying to do is sort of address the capability and ensure that a customer can solve their requirements using AIS. It's not to say that the technology is going to be exactly one for one, but we want to be able to address the use case. Now, I know, Sandro, you just did a session at Integrate just a couple of weeks ago about this topic. So I'll hand it over to you, and you can probably provide some really practical advice.
Well, indeed, I did a session in Integrate. It was a 45-minute session about this topic. So I'm going to try to resume here. But, BizTalk and Azure Integration Service, they are two different platforms. Behind the scenes, they do not work the same way, okay? BizTalk is a product, a single one platform that has everything. Azure Integration Service is a bunch of service that you use to do enterprise integration, and you also have to combine that with other Azure service that are not kind of in the branch of BizTalk, in the Azure Integration Service, like keybolts, log analytics, and so on and so forth. But the important thing is you have to do an assessment to your environment, of your BizTalk environment. You have to understand what is there, how it was built, and then do some prioritize the deployment to Azure. Start with a small one, a simple one, and kind of go one by one. Do not try to do a big bang migration, because that will not work, okay? So choose one solution, a small solution, and start building that solution in Azure. And I mentioned start building because it's not migrating. Take this opportunity to kind of try to see if you can do the things different. How you can improve. Talk to the business. Can we do this in a different way? And because you have to do a little bit redesign. So if you need to do a redesign, nevertheless, take this opportunity to see if you can actually innovate your solutions. But before starting to migrate from Beanstalk to Azure, you have to set up the base, the foundations of your integration platform in Azure, and that means about all the rules, naming conventions. Are you going to use one subscription, multiple subscription? How are you going to divide the environments, kind of Q&A, production, pre-production, because that will happen nevertheless in Azure. Are you going to use resource groups, subscriptions? There is Azure DevOps subscription that's going to spend less money because it's not a production subscription. Are you going to use that or not? And then you also to have to think about the monitoring and how you are going to track all from A to Z the flow of the message. Start building your foundations, and then afterwards start to migrate the small ones, because you will face errors, and that's the best opportunity to kind of improve all of this foundation to the big ones come and to migrate. So I think that these are the basics. Of course, I can spend hours about this.
Yeah, and I did put a link to sort of a blog post that contains many resources about this topic. There's the architecture guidance paper. We've done some interviews with some of the speakers here today. Sandro's one of them. Michael Stevenson is another one. Daniel Probert's another one. Stephen Thomas is another one. So we've got a lot of outside perspectives on this, or maybe not outside, independent perspectives on this. So go ahead and check out that link as well.
All right. Another question we've got here that was upvoted says, does Logic Apps support XML schema format?
Yep. So we saw that today in Sandro's demo. He was using XML schemas, XSDs. So yeah, we support XSD, which is XML. We support then JSON schema as well. And then in the future, CSV, but not quite yet.
Mm-hmm. And I think as the flip side of that, because I saw a whole lot of questions around this schema format in a way. Thought that they was asking if they had support for XML as first-class citizen, and we know that we don't have that support today, but it's something that is on our roadmap. So if you think that is important, it's a good point to add some feedback to that. I see there is a question from Luis on the comments, and I think I have one started from a long time ago that I'll bring after that. So the question from Luis is, are there any plans to integrate the data mapper, which is currently exclusive to Visual Studio Code, in the Azure portal?
So yeah, there is a roadmap item for that. So that is definitely something we want to do. No timelines to share on that at this point. We are focusing on VS Code first. So I would expect like a very sort of complete offering or more comprehensive offering there. And then once we've got that locked in, then we'll look at Portal. But yeah, Portal's definitely part of the strategy moving forward.
Mm-hmm. And on a similar note, there is something about the designer. There was one question from early on from Prijesh. Just one thing. Standard Logic Apps on the new design in the portal, I'm not able to drag shapes or move to other places or to scope. Earlier in the old design, I was able to do. So it's something that might need. I know that some of those things have been fixed, but not all of them. Sandro probably has also a lot of other experience on those ones. As far as I understand, those items are in our roadmap, or actually not on our roadmap, on our backlog, but we just don't have an ETA for that yet. But the ability to copy and paste and to use like shortcuts is something that we had on our backlog as well. So with those ones out of the way, Alex, any other questions on the AMA?
Yeah, we've got a couple others. One of them says, what are some easy authorization best practices and pitfalls in Logic Apps Standard?
Mm-hmm. So that is related to easy auth, Kent. I think you did some work on that one.
Yeah, so there is, so okay, two things, I guess. One is like, so I do have a video on this, on how to actually implement this. It is a little cumbersome, we'll just be honest, because it requires you to call an API. But we are rolling out some newer features in the not so distant future, so over the course of a few months, that will help with this, that will allow you to sort of enable this in a more seamless manner. So I'll dig up that link, and at least it can get you started and using the API, and then yeah, do look for some first-class support in the not so distant future.
Mm-hmm. Another question from the audience here from Cameron is, are there any plans to support consumption logic apps in VS Code? So two parts for that question, probably. One, we have an extension on VS Code that supports logic apps consumption, but it's not a support that allow you to do design on VS Code and publish directly for that. This is also now a roadmap, but it's the focus right now is making sure that you make the end-to-end experience with Logic Apps standard from VS Code all the way so from local development all the way to deployment more streamlined. So we're not going to be looking at that in the near future. Is something for later. And just in case, the link for the easy outlet here. Next question on the Ask Me Anything, because then we have another one coming back.
We've got another one that says, data mapper functions either don't work or lack of examples means it's difficult to learn right away using, and then I think it cuts off, but I think it's just marks on meaning it's difficult to learn like the right way to use them.
Well, I can do that. But yeah, it's a learning experience. Once I start using the data mapper, I was kind of difficult a little bit to understand how this interaction with all the function works. There is no documentation at all to explain all of these functions. Some of them you understand, like concatenate, it's quite simple. Some of them, well, I came from the Beanstalk background, so I know a little bit about this, but I can see that many people that are not experienced as the Beanstalk mapper, it is going to face a little bit some difficult in the starting point. But yeah, Microsoft is improving the documentation. Kent did awesome videos on his YouTube channel explaining a little bit. And all the experience about having the function and move the function are going to be improved. So it's going to be quite easier in the future to starting from zero on this new data mapper. And I know that Kent is working with more documentation. I'm going to start also producing some videos and small documentation about this. And I hope that will facilitate a little bit the experience.
Awesome.
And I know that we have another question that looks like it got asked in the chat, Wagner, if you want to put that one up.
Yes. So the next question on the chat is about the APIM connector. So when can we expect the APIM connector in standard Logic Apps? The good news, as Kent replied on the chat, is it is available now. So you would be able to use the APIM connector as a built-in, right? And we wrote some blog posts to talk about that. And here is a link for the blog post.
Oh, that's actually a video, but yeah, same.
The video, yeah. We also have a blog post about that one. Sorry. So like too many sources, which is good.
Yeah, I also dropped a couple links just related to the data mapper patterns. So if there's particular scenarios you're interested in, let us know, and like we'll work on it, and we'll try to bribe Sandra with another T-shirt if he can build some of those too.
Both of us has beautiful T-shirts today.
We needed to find one for Alex now. All right, I think we are at time. So on my one is 1 minute to go. Do we have any other question that we can answer in 1 minute, or do we
no, I think that's pretty much all of them.
That's perfect. So with that, I think as for everyone that joined, thank you for staying with us for 6 hours, 1 minute and 30 seconds. And I'll let Kent, Alex, and Sandra to give the last words.
So,
yeah, no, thank you. Go for it.
Sorry, my bad. I was going to say, one ask I do have is, if this has been useful for you, if you've enjoyed this, please just put a comment in the YouTube chat here. This helps sort of reinforce or validates our efforts and the need here, and we'd love to be able to show that up to our leadership. So any support you can provide us only helps us, give you more of this type of content. So that would be one ask I have. Another ask would be, try out the custom code. It's now available. The blog post is out. And then also, just look for our monthly newsletters, look for our monthly meetups. Please help amplify the content and help grow the community.
And on that note, amplify and share the link for the sessions and everything, because the more views that we have, the better. So we can bring that kind of stuff later again.
And don't forget to use our hashtag too, hashtag Logic Apps Aviators, so that we can find all your appraisal and content.
Exactly. Sandro?
Well, thank you for inviting me here, and it was a pleasure to be here both on the roundtable as in the session. And as Kent mentioned, if you have any question about new data mapper, feel free to reach Kent or me. You have my email also. I can try to help as much as I can, and or any other question related with Logic App or integration in general. So with that, thank you.
Thanks, everyone,
Thank you,
see you the next time.
Thank you.